हेलो माय डियर मैकेनिकल एंड सिविल इंजीनियर्स, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? प्लीज गाइस डू जॉइन मी फास्ट so that we can start this much awaited marathon session on fluid mechanics as early as possible. Sorry guys for the delay. I have been traveling from Gurgaon to Noida. It takes around 2 hours, more than 2 hours to reach over here, and the weather you all know in NCR is very cold nowadays, so that is why I could not start the session on time. Please guys do join me fast, and those who are already here, respond me through the comment section if my audio and visual quality are fine. Can you guys properly hear me? So is my audio and video quality are fine? ये किससे होगा? बैक बैक यस, अक्षय, विवेक, प्रशांत, बद्री, अनुष्का, किलर, श्रेयस, गुड मॉर्निंग गाइज, नमस्कार, आदाब, सुप्रभात, गुड मॉर्निंग, सत श्री अकाल, अस्सलाम वालेकुम, वणकम. Please get yourself settled down fast. So shall we start? Are you all charged up? So for those who are attending my session for the very first time, we will complete the entire syllabus of fluid mechanics in one shot. All right. So this is my quick introduction for those who are attending my session for the very first time. My name is Chandrasekhar, mechanical engineering graduate from IIT Delhi. I have also cleared engineering services examination, which is conducted by UPSC. Worked in Steel Authority of India Limited for a couple of years, and from last 11 plus years, I have been into teaching, guiding the students who are preparing for various competitive examination like GATE, ESE and other PSUs. These are my favorite subjects. Fluid mechanics is common for civil and mechanical. So please mention your branch in the comment section. How many of you are from the civil engineering? How many of you are from the mechanical engineering? Yes, Vinit, the syllabus for civil, mechanical and engineering science is more or less same for GATE exam. So we will cover the entire syllabus. The only difference is in civil engineering, the extra topic is open channel flow, and in engineering science, this doublet and superposition of the flows are more important. Otherwise, if we talk about the syllabus wise, both all the branches are having same syllabus. All right. So this is my mail ID. If you want to have any kind of discussion regarding your preparation, regarding the fluid mechanics, you can always connect with me through the mail ID, or you can join me on the Telegram. That is Mechanical by Chandrasekhar. Already more than 1500 students are part of my Telegram channel. हाँ विवेक, इंजीनियरिंग सर्विसेज प्रीलियम्स के लिए भी मोर देन सफिशिएंट है. विनीत, यस वी विल ट्राई. सो माय टेलीग्राम चैनल इज मैकेनिकल बाय चंद्रशेखर. द लिंक इज ऑलरेडी देयर. यू कैन join me on the Telegram. Once you become part of my Telegram channel, these many benefits you will be getting. Okay? अभी से ड्रीम्स We have just started. I even don't know how long it will take to complete the entire syllabus. Depending your motivation, depending your enthusiasm, we will try to complete each and every detail. Yes, problems will also be there. Definitely problems will also be there. So theoretical discussion, the concept, the formula along with the numericals as well. Yes, until completion, please promise yourself that you will stay in the session till the end of the session. Acha, Dreams, were you there throughout the session? ये अगर मैं इसको ये करता हूँ स्लाइड चेंज करने के लिए तो ये रिमूव हो जाता है जो भी मैं लिखता हूँ. We are just यहाँ से लेके So, shall we start? So, this is the entire schedule for the marathon. Today, we are discussing fluid mechanics, and for mechanical, this is the entire syllabus. Please do not miss a single session because it is very high time you should cover everything, or whatever you have studied so far. You should revise all the concept in the concise manner. So this is why this marathon session is planned. And on Saturday and Sunday, you must be aware about the aptitude. There will be session taken by Rakesh Talreja sir on 13th and 14th of Jan for the aptitude. So shall we start? So let us start slowly and steadily. I will try to resolve all your queries. Please do share your questions, your doubts in the comment section. So what are we going to discuss in the today's session? We will start with the fluid properties. We will start with the fluid properties. In fluid properties, we will discuss mainly viscosity and surface tension. These are most important properties. Then we will enter into the fluid statics when the fluid is at rest. What are the various topics we are going to cover? One is the manometry, pressure measurement. The class is going to be started now. This is the index. This is what we are going to discuss in today's marathon. Then hydrostatic forces, and then buoyancy and flotation. These are the topics we are going to cover in our fluid statics. Then we will talk about the kinematics of the fluid flow, fluid kinematics, and then dynamics. In dynamics, ideal flow, Bernoulli equation and momentum equation. The application of Bernoulli equation and application of momentum equation will be covered in fluid dynamics. Then the real flow, internal real flow will be discussed, flow in a pipe, The real flow can be classified as laminar and turbulent. So laminar and turbulent flow will be discussed. And then we will talk about the multi-pipe system, series or parallel combination of pipes. Series or parallel combination of pipes. And then the boundary layer theory or external flow. These are the topics we are going to cover in today's session. What is the Navier-Stokes equation, Vinith? The Navier-Stokes equation is the momentum equation applied to the internal flow. Yes, we will talk about the Navier-Stokes equation as well. So this is the syllabus we are going to cover in today's session, all right? So if you have any doubt in any of the topics, hydraulic machine, Abhi Patel, I don't think we will be able to complete in today's session. I will take an extra class for hydraulic machine because hydraulic machine is not very much important in civil engineering, but yes, it is very, very important in mechanical engineering. So hydraulic machine I will discuss separately. So the reference book, one of the masterpiece for fluid mechanics, is written by Sengel. You can refer these books for theoretical clarity, and you can refer this K. Subramaniam for numerical practice. For numerical practice, you can go with the K. Subramaniam. Only the numericals are there in these problems and solutions written by K. Subramaniam. Laminar flow we will discuss. So let us, it is my humble request to everyone, guys, please be focused. Whatever I am going to discuss in today's session will be all for your benefit. So your objective, or I expect from you guys to be fully attentive, fully charged up, keep yourself motivated so that I also get the energy from you guys. All right. So don't ask me this part will be covered or this will not be covered. We will start from the scratch and we will enter into the complexities of the fluid mechanics. Entire fluid mechanics will be discussed. All right. Starting from the statics, then kinematics, then dynamics. These are the three parts of fluid mechanics. Dimensional and model analysis and hydraulic machines are the two things which I am keeping away from this marathon so that I can plan another session very soon for combined topic of model analysis and hydraulic machine. All right. Okay. So shall we start? Please give me thumbs up. Everybody, please do give me thumbs up so that we can start. So let us start with the definition of the fluid. What exactly is a fluid? Fluid is a substance which deforms continuously on the application of shear force. Deforms continuously. Deformation is angular deformation we talk about. And angular deformation happens when there is a shear or tangential force is applied. When we apply a shear tangential force Ft on a substance, there must be angular deformation no matter how small is the magnitude. So these are the three conditions which makes a substance fluid. All right. Whenever we apply a small amount of shear force, whenever we apply even if we apply very small amount of shear force like 0.001 Newton magnitude, so there must be an angular deformation. Angular deformation means shape of the element, fluid element must change. So because of the angular deformation, there is an angular deformation of theta. This is the angular deformation, let us say. The particles which were earlier lying in a vertical plane, now they are part of this surface. So we can say the flow is taking place in x direction and normal to the flow is y direction. There is the velocity profile developed. Whenever we apply a shear force, there is a velocity profile developed. U will be a function of y, and it implies that du by dy is not zero. Du by dy is not zero. What is du by dy? What is du by dy? Tell me, what is this du by dy called? Everyone. And according to no slip condition, the fluid particle which is in direct contact with the solid surface will be having zero velocity. The fluid particle which is in direct contact with the solid surface will be having no slip over the surface. So this is how velocity profile gets developed when we apply a shear force. Velocity gradient. Well done, Anwar, Anushka, Vinay. What is the unit of velocity gradient quickly? So variation of any parameter with space is called as gradient, and velocity, the change in a parameter with time is called as rate. So it is the velocity gradient which gets developed in the fluid. So this is the definition of being a fluid. Now let us start with the second inverse is the unit. Definitely the unit of this is second inverse. Second inverse, meter per second upon meter. So let us start with the properties of the fluid. That is our first chapter. Let us start with the properties of the fluid. Fluid properties. What is density? Let us start with the first chapter, the properties of the fluid. First one is the density denoted by rho. What is density? Density is mass per unit volume. The unit is kg per meter cube. That is the density. Mass per unit volume. The unit is kg per meter cube. Density for a liquid is treated constant. Density of a liquid is taken constant, whereas density of a gas varies with temperature and pressure. Density of gas varies with temperature and pressure, and that is the reason liquids are called as incompressible fluids, whereas gases are known as compressible fluid. Density gives us the information about lightness or heaviness of a substance. Whether a substance is light or heavy, that is given by density. Can you just let me know, as the temperature increases, what happens to the density of a liquid? Gas. As the temperature increases, what happens to the density of a gas? As the temperature increases, density of gas will decrease. As the temperature increases, density will decrease. As the pressure increases, density will increase, right? The another parameter is called as, this is called as mass density. There is another property that is called as weight density. The next property is the weight density. Gamma is equal to rho into G. That is called as weight density, weight per unit volume. Weight density is weight per unit volume. The unit will be Newton per meter cube. That is weight density. Gamma is equal to rho into G. Weight per unit volume is weight density of a substance. The density of a fluid does not change with location, whereas the weight density of the fluid changes with location because it is a function of G. And you must know that acceleration due to gravity on the moon is 1/6 of acceleration due to gravity on the earth. So the weight density of water will be 1/6 on the moon compared to water, compared to earth. All right. There is another parameter that is called as, one more parameter is there, which is called as specific gravity or relative density, S. That is the ratio of density of a substance upon density of water at 4 degrees Celsius. The ratio of density, or if we multiply and divide by G, then we can call it as gamma for a substance upon gamma for water. That is called as relative density or specific gravity. We can call it as relative density or specific gravity. What is the unit of relative density? It is unitless. This parameter is unitless. Unitless parameter. this is weight density. So sometimes the question may give you, sometimes the question may mention that the density of a particular fluid is X, but whether it is mass density or weight density or relative density, which depends on the unit of the parameter given. I hope you understand this. It will all be depending on the unit of the parameter given. If the unit is given as kg per meter cube, then it will be mass density. If the unit is given as Newton per meter cube or dyne per centimeter cube, then it will be the weight density. And if it is a unitless parameter, then it will be relative density. So do not get yourself confused with the word density mentioned in the question. So many students commit this mistake, silly mistake. They do not give much attention to the unit of the parameter given. They only read density and they assume it as rho. All are densities. All these parameters are densities only. The only difference is the unit of these parameters. Mass per unit volume is mass density, weight per unit volume is weight density, and the ratio of densities of a substance to the density of water is the relative density of that particular fluid. I hope this is clear. Can we proceed further? Sometimes the unit conversion, if it is given as 1 gram per cc, so can you convert it in 1 gram is equal to 10 to the power minus 3 kilogram. 1 centimeter is 10 to the power minus 2. This will be the conversion. Sometimes it can be given as gram per milliliter. 1 liter. Can you let me know how much will be kg per meter cube density? If it is given as 1 gram per milliliter, how much will be the density in kg per meter cube? One liter is equal to 10 to the power minus 3 meter cube. 1 milliliter is equal to 10 to the power minus 3 liter. So that will be equal to 10 to the power minus 6 meter cube. Yes or no? So 10 to the power minus 3 upon 10 to the power minus 6. That will be equal to 10 to the power 1 gram 10 to the power minus 3 upon 10 to the power minus 6. So how much is that? How much is that? Isn't it 1000 kg per meter cube? That is how you should be able to convert. These conversions you should be clear with. Now let us move to the next property, and sometimes Newton, 1 Newton is equal to, the unit of force is also one Newton is equal to 10 to the power 5 dyne, or 1 kgf is equal to 9.81 Newton. These are the conversions you should be clear with. Sometimes they can give you the unit as Newton or dyne, or they can give you the unit of force. These are the forces. The unit of force, gravity force or any other force. So you should be able to convert one unit into another. The next property, which is very, very important, is viscosity. Viscosity. Density tells us about attractive status. उल्टा बोल दिया. 1 Newton is not 9.81 kgf. 1 kgf is 9.81 Newton. Do not commit this mistake. 1 kilogram force is equal to 9.81 Newton. Right? Now the next property is viscosity. Density gives us the information about the lightness or heaviness of a substance, whereas the viscosity gives us the information about the thinness or thickness of the fluid. Whether a fluid is thin or thick. Thin means less viscous. The viscosity is less. Thick means more viscous. The viscosity of fluid 2, this is, let us say 1, this is 2. We can say viscosity of 2 is more than viscosity of 1. So what is viscosity? Viscosity is the fluid friction. We can call it as fluid friction. It is similar to friction, but in the fluid. Viscosity can be called as fluid friction. And viscosity is the resistance to angular deformation in the fluid, or resistance to the flow, or resistance to angular deformation, or resistance to relative motion between the adjacent fluid particles. So mathematically, viscosity is the measure of internal resistance between adjacent fluid particles in relative motion. It is called as fluid friction. So it gives the information whether a fluid is thin or thick, right? So as I have already told you, if we apply a shear force, if we apply a tangential force, then the velocity profile get developed. U will be a function of y, and du by dy will be non-zero. And if we compare any two fluid particles, adjacent fluid particles which are separated by distance dy, this is the angular deformation. This is the angular deformation. So from here we can develop a relation du by dy is equal to d theta by dt. Du by dy is velocity gradient, and d theta by dt is called as rate of angular deformation. This is called as rate of angular deformation. So according to Newton's law of viscosity, Newton had done some experiment and he had developed one expression that is called as Newton's law of viscosity. According to Newton's law of viscosity, which gives the defining equation for coefficient of viscosity. So as I told you, d theta by dt is equal to du by dy for a fluid. According to Newton's law of viscosity, he said shear stress developed is directly proportional to rate of angular deformation or velocity gradient. This is the mathematical expression for Newton's law of viscosity. Shear stress developed is directly proportional to rate of angular deformation or velocity gradient. If we convert it into equation form, then we need to insert a constant of proportionality. Mu into d theta by dt is equal to mu into du by dy. This is the mathematical form for Newton's law of viscosity. There are three parameters. Shear stress, the unit is Newton per meter square or Pascal. Another parameter is mu. The third one is rate of angular deformation or velocity gradient. That is, we can either call it as rate of shear deformation, rate of angular or shear deformation, or it can be called as strain rate, strain or flow. Strain rate or flow rate. All right. So this is the mathematical expression. So we can find out the unit of viscosity. What is mu here? Mu can be called as coefficient of viscosity, that is already mentioned. What is the unit of coefficient of viscosity? Or it is called as dynamic viscosity. Why it is called as dynamic viscosity? Because it gives the information about the shear stress required or applied shear stress. That is why it is a dynamic quantity. That is why it is called as dynamic viscosity. Or we can also call it as absolute viscosity. Why it is called as absolute viscosity? Because it is independent of density of the fluid. So many students have this wrong notion कि viscosity might be a function of density. because they are looking very similar terms. People think, so many students think there might be a connection between the density and the viscosity, but to your surprise, let me tell you, there is no connection between the absolute viscosity and the density of the fluid. Clear? Is it clear to everyone? If the velocity profile is linear, I have already told you, the velocity profile, it can be anything. That u as a function of y can be any curve. But if the velocity profile is linear, then du by dy becomes constant. For linear velocity profile, du by dy will be constant, and the value of constant will be v by h. For linear velocity profile, if the velocity profile is linear, v is the velocity of the fluid particle in contact with the moving surface, h is the thickness of the fluid. This is the fixed surface. So when the velocity profile is linear, then the slope of du by dy is nothing but the slope of the velocity profile. Slope of the velocity profile will become constant, and the Newton's law of viscosity can be written as tau is equal to tangential force applied per unit shear area. Shear area, tangential force per unit shear area is equal to mu into v by h. It is constant. Shear stress developed will remain constant when the velocity profile is linear. Constant means it will not be a function of y. The shear stress developed will remain constant. Here, Ft is the tangential force applied. Ft will be the tangential force applied. This is Ft. And As is the shear area over which the tangential force is applied, or As is the contact area between the moving surface and the fluid. It can be called as the contact area between the moving surface and the fluid. V is the velocity of the fluid particle in contact with the moving surface. This is the moving surface. This is stationary surface. And h is the thickness of the fluid. What is thickness of the fluid? The distance between the moving surface and the fixed surface. So whenever the velocity profile is given as linear, or for that matter, the velocity profile is not given at all in the question, what we need to do is we should assume the velocity profile to be linear, and we should apply this modified expression for Newton's law of viscosity. I hope this is clear to all of you. Clear? Now the unit of viscosity. I told you viscosity is the ratio of shear stress upon rate of angular deformation. Viscosity is defined as the amount of shear stress required to produce unit rate of shear strain or unit rate of angular deformation. What are the unit of viscosity in SI or MKS system? Either you call it as Pascal into second, tau is Pascal, d theta by dt is second inverse. So it will be Pascal second, or we can call it as Newton second per meter square. Newton per meter square is Pascal, or we can write it as kg per meter second. किसी ने बताया था अभी थोड़ी देर पहले मुझे? हाँ, ड्रीम्स, y is the variable parameter. जो भी कोई डाउट हो, please do let me know through the comment section. I will be more than happy to assist you. But हो सकता है कि ये explain करते करते I might not see your doubts, but I will try my level best to clear all your doubts before moving further. Why traversing dreams? Y is the variable parameter. Y can be 0, Y can be h. Y can be h by 2, Y can be h by 3. So y is the distance from the fixed surface at which the velocity is u. U and y are variable parameter. V and h are constant parameter. That is the difference. Do you understand? Look, u is the velocity at any y. So we can say at y is equal to 0. Do you agree u is equal to 0? At y is equal to h, then U is equal to V. Y is equal to H, U is equal to V. Y is equal to H means this point. This is Y direction. Right? So these are the units of dynamic viscosity, absolute viscosity, or coefficient of viscosity. In CGS system, the unit of viscosity, the dimensional formula is M1 L minus 1 T minus 1. This will be the dimensional formula. You can always write the dimensional formula. The unit of dynamic viscosity in CGS system is Newton will be replaced by dyne second per centimeter square, or kg can be replaced by gram per centimeter second, or we can call it as poise. And you should always remember 1 poise is equal to 10 to the power minus 1 Pascal second, or 1 Pascal second is equal to 10 poise. 1 Pascal second will be equal to 10 poise. 1 Pascal second is equal to 10 poise. Sometimes the unit might be given in millipascal second or millipoise, centipoise. If it is given in millipoise or centipoise, you can easily convert the millipoise into centipoise, millipoise into poise, and then poise will be converted into Pascal second. Right? This is how. These are very, very important. Units are very, very important. Sometimes the gate paper setter plays with the units and dimensions. So you should be clear with converting one form of unit into another form. Right? Now, as I said, dynamic viscosity is independent of density of the fluid. But there is another parameter or another property defined as viscosity only, which depends on density. What that viscosity called? That is known as kinematic viscosity. That property is called as kinematic viscosity, or we can call it as momentum diffusivity, denoted by nu. The nu is dynamic viscosity per unit density. When density comes into picture, it becomes the kinematic viscosity or momentum diffusivity. It is the momentum transfer ability of the fluid. So we can say kinematic viscosity is inversely proportional to density. What is the dynamic viscosity of water? You should have a little bit idea of that. Density of water is equal to 10 to the power 3 kg per meter cube, isn't it? And dynamic viscosity of water will be equal to 10 to the power minus 3. 10 to the power minus 3 kg per, 10 to the kg per meter second. So what will be the kinematic viscosity of water? What will be the kinematic viscosity of water? So you can say dynamic viscosity upon density. How much is that? What will be the kinematic viscosity of water? So SI unit of kinematic viscosity is meter square per second. And the dimensional formula will be M0L2T minus 1. The CGS of kinematic viscosity is stock, or centimeter square per second. And 1 stock is equal to 10 to the power minus 4 meter square per second. Or we can say 1 meter square per second is equal to 10 to the power 4 stock. This is how you should be able to convert. It will be 10 to the power minus 6 meter square per second. So this is the relation between dynamic and kinematic viscosity. If we want the kinematic viscosity, dynamic viscosity should be divided by density of the fluid. Is this clear? If anybody is having any doubt, just let me know. Otherwise, get yourself ready with your pen, notebook and calculator to solve a couple of numericals based on these. Now again, let me remind you that in the question, if the viscosity word is given, do not always think that it is the dynamic viscosity, right? You should always have a look to the unit of the parameter. If the unit is poise, Pascal second, dynes second per centimeter square, or gram per centimeter second, or millipoise, centipoise, then it will be dynamic viscosity. But if the unit is meter square per second, or centimeter square per second, or stock, then it is not the dynamic viscosity. It is the dynamic viscosity divided by the density. That is kinematic viscosity. All right. हाँ, मोमेंटम ट्रांसफर एबिलिटी का मतलब है when a particle or when a molecule of a fluid collide with another molecule, adjacent molecule, how much momentum it can transfer, that ability is called as momentum transfer ability. For an example, if you are in a room and if you switched on the fan at one corner of the room, then will you feel the air flow at the other corner of the room? Definitely yes, because the momentum transfer ability of the air molecules is far better or far more than the momentum transfer ability of liquids. If there is a swimming pool, static fluid, static water, if you make a disturbance in one corner of the swimming pool, if you jump in one corner of the swimming pool, there is high chances the other corner you will not feel the disturbance. You will not feel the motion of water at the other corner, isn't it? Because the momentum transfer ability of the liquid molecules is less. Similarly, if there is a solid, if you disturb the solid from one end, you will not feel the disturbance on the other end. That means the momentum transfer ability of the solids is far less. So we can say kinematic viscosity of a gas is greater than kinematic viscosity of a liquid. Whereas the dynamic viscosity of the liquid will be greater than dynamic viscosity of a gas. Dynamic viscosity of liquid will be more. The resistance to deformation for the liquids will be more than the gas, but the kinematic viscosity or momentum transfer ability of the gas will be more than the liquid. I hope that clears your doubt. Sports and entertainment, Malayalam. Is this clear? Can we proceed further? Now, like any other property, viscosity also depends on temperature. Like any other property, viscosity also depends on temperature. Actually, viscosity is governed by two factors. Viscosity of a substance is governed by cohesive force, the intermolecular force of attraction between similar molecules, and the molecular collision or molecular momentum transfer. Viscosity is governed by these two factors. As the cohesive force or molecular collision increases, as cohesive force or molecular collision increases, the viscosity of the fluid also increases. By increasing the molecular collision or cohesive force, viscosity will also increase. This AGS, this is actually the marathon session. If we will move very slow, then we may not be able to cover the entire syllabus. So that is kind of a revision, quick revision. All right. If I'll note your point and I'll follow your point, then so many students might get disturbed because everyone wants to get the syllabus to be completed in a quick and precise manner. That is why it is the session is planned in a single shot. So cohesive force or molecular collision increases, viscosity increases. Now as the temperature increases, if the temperature of the fluid increases, then the molecules move away from each other. And the molecules move away from each other, the cohesive force decreases. But due to high temperature, the molecular collision increases. So we cannot, by increasing the temperature, we cannot say whether the viscosity will increase or decrease. Because one of the governing parameter decreases, another governing parameter increases. Do you understand? I hope you guys understand this. Viscosity of a fluid is governed by two factors: cohesive force, molecular collision. And either of them increases, that will increase the viscosity of the fluid. Right? And if these parameter decreases, that will decrease the viscosity. But the problem here is by increasing the temperature of the fluid, one parameter decreases and another parameter increases. Right? One is decreasing, another is increasing. So what do we do now? We need to find out which is more dominating parameter governing the viscosity. And that is where the variation of viscosity with temperature for liquid and gas comes into picture. How? In case of a liquid, if we talk about a liquid, then in case of a liquid, cohesive force dominates. When we talk about a liquid, because in liquids, molecules are closely spaced compared to the gas. When the molecules are closely spaced, the molecular momentum transfer or the molecular collision is not dominating. They are not able to collide with each other because they are very, very close. The momentum transfer of the molecules will not be more. If there are two particles very close to each other, and if they collide, less momentum transfer will take place. But if somebody is coming from far away and then collide, then the momentum transfer will be more. So because the molecules are closely spaced, molecular momentum transfer is not dominating in case of a liquid. So the governing factor is cohesive force. So by increasing the temperature of the liquid, because the cohesive force decreases, so that will decrease the viscosity. I hope this is clear. But if we talk about a gas, molecules are widely spaced. Cohesive force is negligible. Molecules are widely spaced. So cohesive force is very small. Cohesive force is more when the molecules are close to each other. Cohesive force becomes weak when the molecules are away from each other. So cohesive force becomes less dominating. And molecular momentum transfer or molecular collision becomes the dominating factor in governing the viscosity whenever we talk about a gas. Molecular collision. And by increasing the temperature of a gas, we will not focus on the cohesive force because it is not dominating. We will focus on the collision of the molecules. At higher temperature, more is the kinetic energy of the molecules, more will be the momentum of the molecules, more will be the velocity of the molecules, more will be the molecular collision or momentum transfer. So that will increase the viscosity of the gas. So this is very, very important. Viscosity is having a different variation with temperature in case of a liquid. It is having a different variation with the temperature in case of a gas. The only difference is because of the dominating factor out of the two factors governing the viscosity. I hope that makes it clear to everyone. Is this all fine? We will provide the PDF of this session through my Telegram channel. कोई सा भी बना दो एक्सप्लोरर, काइनेमेटिक और डायनेमिक, काइनेमेटिक और डायनेमिक, फॉर बोथ ऑफ देम इट विल वर्क. बिकॉज लिक्विड के केस में तो आपको कंफ्यूजन होना ही नहीं चाहिए, बिकॉज डेंसिटी ऑफ द लिक्विड रिमेन्स कांस्टेंट, इट डज नॉट वेरी विद द टेम्परेचर. सो variation of dynamic viscosity will decide the variation of kinematic viscosity. But if we talk about a gas, even if we talk about a gas, in case of a gas, so as the temperature increases, as the temperature of a gas increases, what I told you, dynamic viscosity increases and density will decrease, isn't it? As the temperature of the gas increases, density will decrease. I told you. So denominator is decreasing, numerator is increasing. So what will be the overall effect? There is an increase in kinematic viscosity. There will be an increase in, or we can say kinematic viscosity will increase at a faster rate compared to the dynamic viscosity whenever we talk about a gas. I hope that is clear. Sarwan, there is no as such major difference between dynamic and kinematic viscosity. Physical significance wise, there is no difference at all. Both represents the resistance to the flow only, whether it is dynamic or kinematic. Why we call it as kinematic viscosity? Because it gives the information about the kinematic quantity, meter square per second, meter and second. It gives us the information about the momentum transferability, and momentum is related with the velocity. Velocity is a kinematic quantity. Because kinematic viscosity gives us the information about the momentum transferability, which is a kinematic parameter. Kinematic parameter means which are related with the motion. That is why it is called as kinematic viscosity. Why do we call mu as dynamic viscosity? Because it gives us the information about the shear stress required. It gives us the information about the shear stress required for the flow. So shear stress is related with the force, shear force. Shear force is a dynamic parameter, dynamic quantity. So that is why we call it as dynamic viscosity. Clear it is? Yes? Now let us move further. Now there are fluids which obey Newton's law of viscosity. There are fluids which do not obey Newton's law of viscosity. But do not worry, in fluid mechanics, we only concentrate on the fluids which obey Newton's law of viscosity. We are not going to discuss those fluids which do not follow the Newton's law of viscosity. So the fluids following the Newton's law of viscosity are known as Newtonian fluid. Whether it is mentioned or not in the question, we will always assume the fluid to be Newtonian fluid. But yes, there are fluids in nature which do not obey Newton's law of viscosity. They are known as non-Newtonian fluids. So rheology is related. Rheology talks about the study of non-Newtonian fluid. Fluid mechanics do not talk about the non-Newtonian fluid, but rheology talks about the non-Newtonian fluids. Study of non-Newtonian fluids. The study of non-Newtonian fluids is called as rheology. So rheological behavior of the fluid. Shear stress on y-axis, tau, and rate of shear deformation or rate of angular deformation d theta by dt on x-axis. So when the curve between tau and d theta by dt is linear, isn't it? This is tau is directly proportional to d theta by dt. Yes or no? Tau is directly proportional to d theta by dt for C. So C is Newtonian fluid, and all the others are non-Newtonian fluids. C is Newtonian fluid. D is the non-Newtonian fluid, which is called as dilatant. D is dilatant, whose viscosity is the slope of the curve. Viscosity is the slope. Viscosity is represented by the slope of the curve. The slope of the curve represents the viscosity of the fluid. So we can say the viscosity increases with the deformation for the dilatant fluid. Viscosity increases. So that is why they are also called as shear thickening fluids. Dilatant fluid is also known as shear thickening. Whereas B is called as pseudoplastic. Pseudoplastic fluid. Or the viscosity decreases. The slope decreases. So they are also known as shear thinning. They become thin. and A is called as Bingham plastic. Bingham or ideal plastic. Ideal plastic. Example, ketchup, toothpaste, etc. Toothpaste and ketchup are ideal plastic or Bingham plastic fluids. It is also a straight line, but there is an intercept. There is an intercept on y-axis. So there is a difference between A and C. When the straight line passes through origin, it is Newtonian. When the straight line does not pass through origin, it will be Bingham plastic, ideal plastic. So that is the difference. So these A, B, and D are non-Newtonian fluids which do not obey Newton's law of viscosity. They are non-Newtonian fluids. They are called as non-Newtonian fluids. Clear? Any doubt? So that is not important, but you should have a little idea. That is why I have kept this slide for your understanding. Now let us try to solve one question. Everybody, please try to solve this one. Can you guys solve this one? Blood is a pseudoplastic fluid. Blood, milk, paint, syrup. Blood, milk, paint, syrup, these are pseudoplastic. Sugar or salt solution. Sugar solution, salt solution. Butter. Quicksand is dilatant. Toothpaste, ketchup, these are Bingham plastic. So there is a question on the screen. Please try to solve. This is 0.5 centimeter. This is 0.5 centimeter and the inclination is given by this theta. This is how the inclination is given. And this is a cubic block which is moving with a velocity 0.5 meter per second. And there is a fluid over here. Oil. There is oil in between the moving surface and the fixed surface. And the weight of the cubic block is 130 Newton. This. So what will be the viscosity of the fluid? Which viscosity we need to calculate? Which viscosity we need to calculate? We need to calculate the dynamic viscosity, because without knowing the density of the oil, we cannot calculate the kinematic viscosity. Now try to understand how to proceed from here. Because the velocity profile is not given in the question, can we assume the linear velocity profile? The velocity profile is not given, we have to assume the linear velocity profile. So our expression will be tau is equal to tangential force per unit shear area is equal to mu into V by H. From here we will calculate mu. Velocity profile is not given, that is why we need to take it as linear. Right? Now, what is the tangential force? The force which acts parallel to the surface is tangential or parallel to the fluid. So 130 Newton, this weight is acting in downward direction. So if we take the normal to the surface, this is the normal. So this is the normal component of weight and this will be the shear component of weight, Ft. What is Ft? This angle is also theta. So do you agree Ft will be equal to this component? Weight is acting in downward direction. Weight always acts vertically downward. This angle is also theta. So Ft is equal to W sine theta, yes or no? Ft will be, tangential force will be W sine theta. The tangential force is the force which is acting parallel to the fluid. So the component of weight will be the tangential force. Do not commit this mistake. The tangential force is W sine theta. And what is sine theta? From here we can say this will be 13. Yes or no? This will be 13. So sine theta is how much? Perpendicular upon hypotenuse, 5 by 13. Sine theta will be 5 by 13. Hypotenuse square is equal to base square plus height square. So now if we put the values, what is the shear area? Shear area is the contact area of the moving surface and the fluid. This will be the shear area because it is a cubic block of side 1 meter. So this is also 1 meter. This is also 1 meter. So the shear area will be 1 by 1. The shear area is the contact area of the moving surface and the fluid. So now we are ready with all the parameters. Tangential force is 130 into sine theta. Yes or no? Ft is equal to W sine theta. That is the catch. W is 130, sine theta is 5 by 30. Shear area is 1 into 1 meter square. Sides are 1 is equal to mu. What is V? V is the tangential velocity of the fluid particles in contact with the moving surface. So the moving surface is having the velocity 0.5 meter per second. So the particles in contact with the moving surface will also have the same velocity according to no slip. The particles, the fluid particles in contact with the moving surface will be moving with the same velocity according to no slip. Similarly, the particles which are in contact with the surface at rest will also be at rest. There is always a no slip whether the surface is moving or the surface is at rest. So V is equal to 0.5 upon what is the thickness of the fluid? This is the thickness of the fluid, 0.5 centimeter. The perpendicular distance between the moving and the fixed surface. So 0.5 into 10 to the power minus 2. What is the final answer for dynamic viscosity of the oil? Unit क्या होगा? What will be the unit? What will be the unit? That is important. अरे वाह, Anwar had mentioned exactly 0.49999. Wow, that much accuracy. It is around 0.5 Pascal second or Newton second per meter square or kg per meter second. I hope this is clear. Newton second per meter square. Well done. Great. Keep it up, guys. जिन लोगों ने solve किया, those students who had given time and effort to solve this question, I am really thankful to all of you. That is the dedication level I want you from all of you guys. कि जितना आप dedication, जितना आप motivation और जितना आप interest show करोगे, the more energy I also develop, and I will try to make each and every concept as simple as possible for your understanding. All right. So can we proceed further now? Beautiful question. This is very beautiful question. Can you do? Can you solve? Let me give you the options also. Option A is pi mu omega d to the power 4 upon 32h. Option B is pi mu omega d to the power 4 by 16h. Option C is pi mu omega d to the power 4 by 8h. And option D is pi mu omega d to the power 4 by 4h. These are the options. Can you solve this? Let us try to solve together. There is a small twist in this question. That is why I have kept it in the slide. There is a circular disc. This is the circular disc, which is slowly rotating in a liquid of viscosity mu. There is a liquid here, and the disc is rotating over the liquid at a small distance h. This distance, the distance between the fixed surface and the disc is h. H is called as fluid thickness. H can be called as fluid thickness from the fixed surface as shown in figure. Find the torque which is required to maintain the angular velocity omega. We need to find out the torque which is required to maintain the angular velocity omega. अरे वाह, याद कर रखा है क्या? या मेरी ही कोई क्लास अटेंड की थी? How do you know the answer? How you got the answer without any help? Well done. तो quickly मैं इसको डिस्कस कर लेता हूं. There might be students who are not aware about the concept related to this question. जिन लोगों को आइडिया है, please stay and please get yourself concept revised again through this question. But those who are having a difficulty, try to understand. So the fluid, in the fluid, the velocity profile is not given. So we can assume the velocity profile to be linear. As simple as that. Whenever the velocity profile is not given. Dreams ने option B दिया है, तो dreams के लिए specially मैं ये question solve करूंगा. The velocity profile can be assumed as linear. So we can say tau is equal to mu into V by H. Right? We can assume, we can use the modified expression for Newton's law of viscosity. Now, what is mu? Viscosity of the fluid. As simple as that. What is H? Fluid thickness. No problem at all. The problem appears with this V. What is V? V is, listen very carefully. What is V? V is the tangential velocity of the fluid particles in contact with the moving surface. V is the tangential velocity of those fluid particles which are in contact with the moving surface. Now try to understand. If the particle in contact with the moving surface is here, the tangential velocity will be 0 because V is equal to, we can say V is equal to R into omega. Yes or no? If the particle is lying on the axis of rotation, then the R will be equal to 0. So V will be equal to 0. But if the particle is lying here, then the tangential velocity will not be 0. If the particle is lying here, then the tangential velocity will be maximum. Yes or no? So here the velocity, tangential velocity of the fluid particle in contact with the moving surface is variable. In the previous question, that was not the case. In previous question, it was not the case. अगर मैं previous question की बात करता हूं, in the previous question, all these particles which are in contact with the cube are moving with the same velocity. So V was not variable here. But in this question, V is a variable parameter. The velocity here will be 0, velocity here will be maximum. So we need to go for integration. Then we need to go for integration. And because it is a circular disc, for integration, we need to take an elemental ring. The area of the elemental ring is equal to 2 pi small r into dr. We need to take a ring. For the disk, element is taken as ring. And if we integrate the element of the ring from r is equal to 0 to r is equal to capital R, then we will get the entire disk, isn't it? So we need to go for integration. Now our analysis starts. We can say dt is equal to df into r. Yes or no? Dt is equal to df into r, and df is equal to tau into dA into r. Yes or no? And tau can be written as mu v by h. So if we integrate dt, then we will get tau is equal to mu into r omega by h, that is tau, into 2 pi r into dr, that is the area, into r. If we integrate from 0 to d by 2, you will get the answer. Then you will get the answer. Yes or no? Why we need to go for integration? I hope that is clear to everyone. If any of the parameter is variable, then we always go for the integration. Then we always integrate. So that is why the integration is done. So that is the torque required to maintain the angular velocity, or we can also call it as loss of torque. Due to fluid viscosity. Either we call it as loss of torque due to fluid viscosity, or we can call it as torque required to maintain the angular velocity, one and the same thing. If the question asks you to find out the power loss, what is the power loss? Torque into omega. That will be the loss of power. Torque into omega will be power loss. Or power required to maintain, or we can also call it as power required. Either it is power required to maintain the angular velocity, omega, or the loss of power due to viscosity. Now the next property is compressibility. I hope surface tension is all clear to everyone. Is the surface tension clear to all of you? Now let us move to the next property, that is compressibility of the fluid. Beta. What is compressibility? Compression ability. Compression plus ability is compressibility. Compression ability of the fluid. Mathematically, it is the reciprocal of bulk modulus K. The unit of bulk modulus is Pascal or Newton per meter square. And what is bulk modulus K? Direct stress upon volumetric strain. And volumetric strain can be written as d rho by rho. So beta, coefficient of compressibility, is 1 by k, that is equal to d rho upon rho into dp. This is called as coefficient of compressibility. The unit will be meter square per Newton. That is called as coefficient of compressibility. That is called as coefficient of compressibility, reciprocal of bulk modulus. So if beta is equal to 0, it implies d rho will be equal to 0, or we can say rho will be equal to constant. What is the meaning of rho is equal to constant? It is not a function of temperature and pressure. Such fluids are called as incompressible. Such fluids are called as incompressible. Incompressible fluid. Example is liquids. Liquids are incompressible. Liquids are incompressible fluids. If beta is non-zero, it means d rho will be non-zero. It means rho will not be constant. If rho is not constant, it is a function of temperature and pressure. Such fluids are called as compressible. Gases are compressible fluids. So the fluid can be classified as incompressible and compressible based on the compressibility, based on the factor compressibility, or based on the property compressibility. If beta is equal to 0, the fluid is incompressible. Liquids are incompressible because in liquid density does not vary with temperature and pressure. But if beta is non-zero, the fluids are called as compressible. Now the next again important property is surface tension. Another important property. Surface tension. When the liquid surface is in tension, it is the property of the liquid. It is the property of the liquid surface or liquid interface. It is not the property of gaseous surface, because gases do not have surface, so it is not defined for a gas. But yes, it is only defined for a liquid or incompressible fluid. So it is the property, listen very carefully, surface tension is the property which is shared by two fluids, and one of them must be a liquid. The another fluid can be a liquid or can be a gas, because there must be an interface. It can be oil and water interface. The surface tension of oil and water interface can be defined. The surface tension of water and air interface can also be defined. But surface tension of helium and oxygen cannot be defined, because they will mix. There will not be any interface, there will not be any surface tension. So it is the property of the liquid interface or liquid surface. And what is it? This is the liquid interface. So whenever, because of the cohesive force, the molecules of the liquid surface are having a tendency to move in downward direction. Because of the cohesive force by the liquid molecules, these interface molecules, this is the interface. These interface molecules are having a tendency to move in downward direction, like this. These are the molecules which are having a tendency to move in downward direction. To overcome this downward motion, or overcome the downward tendency, all the liquid interface molecules develop the strong cohesive force with each other. All these molecules which are lying on the interface develop the strong cohesive force with one another, and the whole liquid surface appears like a thin elastic film in tension. There is a tension developed in the entire liquid interface. That property of the liquid interface is known as surface tension. That is known as surface tension. And this can resist small forces, like paper clip floats on water. Paper clip can easily float on water. Even though the paper clip is made up of metal, and metal is heavier than water, still paper clip or steel needle or a coin floats on water. The justification is because of surface tension of water. So the force developed due to surface tension is surface tension force, which is the tensile force, normal and tensile. Pressure force is normal and compressive. Whereas surface tension force is normal and tensile. It is acting normal to the common line of interface, and it is acting in the plane of the liquid surface. So we can say Fs is directly proportional to length of the common interface, or we can say, if we insert a constant of proportionality, sigma into length. So sigma can be defined as force per unit length of the common interface. The unit will be Newton per meter. This is sigma, and sigma is a function of temperature. Why? Why sigma is a function of temperature? Because it is the cohesive force. Surface tension is nothing but a cohesive force, strong cohesive force, which is developed between the surface molecules or interface molecules. And because of this strong cohesive force, which depends on temperature, so as the temperature of the liquid increases, we can say cohesive force decreases, and that will decrease the surface tension. That will decrease the surface tension. Right? If we multiply and divide by meter, the Newton meter will become joule. So there is another unit of this, joule per meter square. The unit of surface tension can also be written as joule per meter square, either Newton per meter. Either we call it as Newton per meter or joule per meter square. So joule is the amount of work required, and meter square is the change in surface area. So surface tension is also defined, because surface tension minimizes the surface area of the liquid. Surface tension minimizes surface area of the liquid. It minimizes the surface area of the liquid because of a strong cohesive force. Because of a strong cohesive force, the surface area of the liquid becomes minimum. So the surface tension can be defined as the amount of work required. It is defined as the amount of work required to increase unit surface area of the liquid. How much will be the work required to increase the unit surface of the liquid is nothing but the value of surface tension. I hope this is clear. Yes, Danesh, well done. Look, that is for Shravan. This is weak cohesive force on the liquid interface. There is a weak cohesive force on the liquid interface, right? Weak cohesive force on the liquid interface. And if the cohesive force becomes strong, if there is a strong cohesive force developed on the liquid interface, then there is a tension developed in the liquid surface. This is how the liquid surface becomes very tight. If it becomes very tight, we can easily put anything over it. If it is weak, if the liquid interface is having weak cohesive force, whatever we put on this, then it will go inside. But if the cohesive force becomes very strong, if the cohesive force is very strong, then whatever we put over the liquid surface, it can easily hold. Are you getting it? So that is how the surface tension can easily hold the small forces, small loads. Because of the surface tension, try to understand, because of the surface tension, there is an upward force developed. The component of surface tension force, one component of surface tension force will be in upward direction. When one component of surface tension force is in upward direction, it is in downward direction. The weight of the body is in downward direction. So weight of the body becomes equal to the component of surface tension force. That is how this body will be in equilibrium. So the amount of surface tension force is very small. That is why very small forces can be easily held on the liquid surface because of surface tension. Yes, Samaira, to be very honest, to be very clear, the surface tension is shared by two fluids. Out of them, one must be a liquid. So it is actually decided by the relative intensity of cohesive and adhesive force. It is actually decided by the relative intensity, relative magnitude of cohesive and adhesive force. So it is the property of intermolecular forces. It is a function of intermolecular forces, right? For water and air, surface tension will be different. But for water and oil, surface tension will be different. So the other fluid also becomes important. There is nothing called surface tension of water. Whenever surface tension of water is mentioned, the other fluid is by default air. The information should be given like this. Surface tension for water and air interface at 20 degrees Celsius is equal to 0.0736 Newton per meter. This is how the information ideally must be provided. But people do not feel the need of mentioning air because air means atmosphere and atmosphere is everywhere. That is why people only mention surface tension of water. But that is technically incorrect to say surface tension of water. Technically correct statement should be the surface tension of water and air interface must be this much. I hope that clears your doubt. Now, few applications of surface tension. There are two forces. Pressure force is normal and compressive. If we talk about a liquid drop, this is the pressure force, normal and compressive. This is the surface tension force, tensile and normal and tensile. So for equilibrium pressure force, and this is, let us say, inside pressure, this is, let us say, outside pressure. So delta P for a liquid drop or for that matter air bubble. Air bubble is also having a single interface. Liquid drop or air bubble are similar, or gas bubble. So delta P, that is equal to inside pressure minus outside pressure, is equal to 4 sigma by d. D is the diameter. That is the formula for a liquid drop. That will be the formula for a liquid drop. Inside a soap bubble, there will be two interfaces. There will be two interfaces in case of soap bubble. So delta P, pressure difference between inside and outside, Pi minus P naught, is equal to 8 sigma by d. D is the diameter. And for a liquid jet, jet means the diameter is very, very less compared to the length. For this, delta P is equal to 2 sigma by d. These are some of the applications of surface tension where we can find out the pressure difference between inside and outside of a liquid drop, air bubble, soap bubble, or a jet, liquid jet. These are the formula you must remember. And they are obtained by equating pressure force and surface tension force. They are obtained by equating pressure force and surface tension force. Can you solve this one? Can you guys solve this question? Which formula is supposed to be used? What will be the answer to this one? We will use, because it is an air bubble. Air bubble is similar to liquid drop. What is the air bubble? There is an air trapped inside the liquid. Only one interface will be there. There will only be one interface. So delta P is equal to 4 sigma by d. That is where students commit mistake, because they think that bubble means 8 sigma by d. They start thinking that bubble means 8 sigma. But because air bubble is having a single interface, that is why 4 sigma by d. So difference in pressure across an air bubble of 1 mm diameter is 1 mm. 4 into sigma is given as 0.072 upon 1 into 10 to the power minus 3. If you want it in SI unit, then put all the given parameter in their SI unit. Yes, delta P will be equal to 288 Newton per meter square or Pascal. 288, right? This is important. A spherical water drop. The shape of the water drop will be spherical due to surface tension. Because surface tension minimizes the surface area. Surface area is minimum. The surface tension always minimizes the surface area of the liquid. That is why the shape is spherical. The spherical water drop of 1 mm diameter is required to split into 64 small drops of equal size. What will be the amount of work done? So it is from the definition. Sigma is equal to amount of work required per unit change in surface area. So the question is to find out the work required. So we need to find out change in surface area. Now, because volume of the liquid remains constant, there is no change in volume. When it was bigger drop, whatever was the volume, for 64 small droplets, the volume remain constant. So what is the volume? Can we write 4 by 3 pi r cube? That is the volume of bigger drop, is equal to, now the volume has become 64 4 by 3 pi r cube. So from here we will get r is equal to capital R by 4. That is second concept. Volume of the liquid will remain constant. The third one is, what was the initial surface area? that is 4 pi r square. What is the final surface area? Final surface area is 4 pi into small r square, and small r is equal to capital R by 4. Sorry, the final surface area will be 64 multiplied by 4 pi r square. Yes or no? One drop will have 4 pi r square area, and there are 64 drops. So 64 multiplied by 4 pi r square. Small r is equal to capital R by 4. So it will be, isn't it, 16 pi r square? So change in surface area, that is final surface area minus initial surface area, that is 16 minus 4, 12 pi r square. Put in equation number 1. Put in equation number 1. This is the equation number 1. This is the definition. So we can say work will be equal to the surface tension, that is 0.073 into 12 pi, capital R is 0.5 mm. 0.5 into 10 to the power minus 3 square. That will be Newton meter or joule. That is how the answer will come. How much is the answer? Is the question clear or not? ये आंसर आना चाहिए. Are you getting this or not? अनिकेत, ये तो गलत है. This is not correct. टेन टू द पावर माइनस 3 भी गलत है. -6 नहीं होगा क्या? Do not commit the mistakes. Try to understand the concept and do the calculations correctly. अच्छा, यही तो गलती करते हैं. Diameter, if diameter is given and if you require radius, take care of these things and take care of the units as well. Then only you will get the correct answer. Very nice. Good, 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 good. आगे बढ़े. Then the next property of the fluid is capillarity, that is extension of surface tension. The next is capillarity. What is capillarity? The rise or fall of a liquid in a small diameter tube inserted in the liquid due to surface tension. The capillarity is due to surface tension. Rise or fall is due to surface tension. The capillary rise is due to less cohesion. Example is water and glass. If glass tube is inserted in water, there will be capillary rise. Capillary fall is due to more cohesion. Example, mercury and glass. If the glass tube is inserted in mercury, so here water will rise. If this is water and this is the glass tube, then water will rise. This is called as contact angle, theta. Theta is less than 90 degree. This is called as contact angle. Theta is called as contact angle. If a glass tube is inserted in a mercury, then there is a capillary fall. This angle is theta. Theta is greater than 90 degree here. Theta is less than 90 degree here. When theta is less than 90 degree, then cohesion is less than adhesion. When theta is greater than 90 degree, then cohesion will be greater than adhesion. When cohesion is less, the liquid is wetting liquid. It will wet the glass surface. And if cohesion is more, then it will not wet. The liquid will be non-wetting liquid. Right? Because of theta less than 90 degree, the meniscus is concave. It will have concave meniscus. And for theta greater than 90 degree, it will have convex meniscus. Like this. So this was the initial level. This was the initial level of water. Here, this was the initial level of water, the initial level of mercury. So there is a capillary fall, there can be a capillary rise. And that is due to surface tension. The rise or fall will take place due to surface tension. So how much rise or fall will take place, which can be calculated by equating the forces on this liquid. This is the surface tension force, which is sigma. Surface tension force will be equal to sigma into 2 pi r or pi d. Sigma into pi d. This angle is theta. So there will be upward component Fs cos theta is equal to weight, that is rho into volume pi by 4 d square into g mg. So downward force must be equal to upward force. This force must be equal to this force. So H will come out to be 4 sigma cos theta upon rho of liquid into G into D. This is the formula. This can be capillary rise or fall. It can be capillary rise or it can be capillary fall. Wow. Thank you very much, Ajay, for the nice words. Great to hear that. आप लोगों का भी selection हो जाएगा. If you are dedicated enough, if you are working really hard to clear the examination, nothing is impossible. So आपका dedication and hard work is what matters a lot. If we are getting H as positive, then it will be capillary rise. If we are getting H as negative, it will be capillary fall. Hi, Hari, Sindhu. Good morning. So it will depend on theta. If theta is less than 90 degree, then H will be positive. If theta is greater than 90 degree, then H will be negative. So there will be capillary rise if theta is less than 90 degree. There will be capillary fall if theta is greater than 90 degree. H depends on these many parameters. H represents the capillary rise or capillary fall, right? When a glass tube is inserted in pure water, theta is equal to 0 degree. So H will be maximum in that case. That is 4 sigma by rho GD. When in case of normal water, theta is less than 90 degree. H will be negative. Capillary rise. Contact angle. If for mercury, theta is greater than 90 degree, 132 degree. So H will be positive. It means, H will, I made mistake here ना. H will be positive. पिछले वाली slide में भी गलती कर दी क्या? Theta is less than 90 degree, H will be positive. H will be positive, capillary rise. But here H will be negative, capillary fall or capillary depression. So this is about the capillarity. Capillary is not important. Viscosity and surface tension are the two properties which are most important. The last property is vapor pressure of the liquid. Vapor pressure. Pressure exerted by the liquid vapor. It is also a property of the liquid. The pressure which is developed or exerted by the liquid vapors on the liquid surface is called as vapor pressure. So vapor pressure is proportional to, we can say, the pressure exerted by the liquid vapors. These are the saturated vapor of the liquid, also called as saturation pressure. We can also call it as saturation pressure of the liquid. The pressure which is exerted by the saturated vapor of a liquid in phase equilibrium with its liquid. That is called as vapor pressure. So vapor pressure is directly proportional to number of vapor molecules. Vapor pressure is directly proportional to number of vapor molecules which are formed at phase equilibrium, which are formed at the equilibrium, or which are formed in saturation, at saturation. So more is the vapor pressure, means more are the number of vapor molecules. More vapor molecules will exert more pressure. More vapor molecule will exert more pressure. Less vapor molecules will exert less pressure, isn't it? So if the saturation, the vapor pressure is more, it means number of vapor molecules are more. If the saturation pressure or the vapor pressure is less, it means the number of vapor molecules are less. So vapor pressure is also defined as the saturation pressure of the liquid, below which liquids get converted into vapor or liquid boils. If the liquid pressure becomes less than the vapor pressure, then there will be evaporation of the liquid, or there will be vapor bubbles form when the liquid pressure falls below the vapor pressure. So more vapor pressure implies more liquid molecules, more vapor molecules. It means the liquid is easily boiled. Easily boils. If the vapor pressure of the liquid is more, it means the number of vapor molecules will be more. It means the liquid easily boils. Such a liquid is called as volatile liquid. The liquid is called as volatile. Such a liquid is called as volatile liquid. If the vapor pressure is less, then it implies less vapor molecules. The number of vapor molecules formed are less. So such a liquid is difficult to boil. So it gives us the information about the boiling point or boiling of a liquid. More vapor pressure means easy to boil, easily boils, and less vapor pressure means difficult to boil. When the liquid pressure becomes less than the vapor pressure, then the boiling of the liquid will take place. And whenever the boiling of the liquid will take place, there is a problem existing that is called as cavitation. Have you heard about cavitation? Do you know what is a cavitation? Whenever the liquid pressure becomes less than the vapor pressure or the saturation pressure of the liquid will boil. That is what I have already told you. Or boiling means vapor bubbles will form. This is how the vapor bubbles will form. And these vapor bubbles are carried away from the low pressure region. These vapor bubbles are carried away from low pressure region, and their sudden collapse, implosion. They are imploding. They are not exploding. Their sudden implosion generates extremely destructive high pressure waves, which leads to vibration, erosion, and reduces the performance of the hydraulic machine. So cavitation is not helpful. Cavitation is dangerous. Cavitation is not required. We always try to avoid the cavitation. This is the condition avoiding the cavitation. The condition to avoid the cavitation is the liquid pressure should always be greater than its vapor pressure. The liquid pressure must always be greater than its vapor pressure. I hope this is clear to everyone. This condition is very, very important in hydraulic machines. So that completes our chapter number 1, that is the properties of the fluid. Though the topic was little theoretical, but the understanding of each and every concept minutely is very much important for your better understanding of the analysis of the fluid. Clear? Alak Pandey, thank you very much. Hari Sindhu, for an example. जैसे मान लीजिए वेपर प्रेशर ऑफ वाटर इज इक्वल टू 1 atm होता है एट 100 डिग्री सेल्सियस. Vapor pressure of water is 1 atm at 100 degrees Celsius. Vapor pressure of water is 1 atm. vapor pressure of water is 1 atm at 100 degree Celsius, right? अगर flowing water का अगर 100 डिग्री सेल्सियस पे वाटर फ्लो कर रहा है तो वाटर वेपर में कन्वर्ट नहीं होगा जब तक कि प्रेशर वाटर का 1 atm से ज्यादा है। किसी भी लिक्विड का बॉइलिंग दो तरीके से हो सकता है, या तो टेम्परेचर को राइज कर दो, द टेम्परेचर बिकम्स मोर देन द सैचुरेशन टेम्परेचर ऑफ द लिक्विड, देन द लिक्विड विल कन्वर्ट इनटू वेपर, दैट इज वन पॉसिबिलिटी। द अनदर पॉसिबिलिटी इज व्हेन द लिक्विड प्रेशर बिकम्स लेस देन द वेपर प्रेशर, देन द बॉइलिंग विल टेक प्लेस। और ये आप ये पूछना चाह रहे हैं ये आया कहां से, यही पूछना चाह रहे हैं कि ये कंडीशन कैसे आई, कैसे हमें ये पता चला कि when the liquid pressure becomes less than the vapor pressure then the boiling will take place? Is this your question, Hari Sindhu? Look, saturation temperature is the function of liquid pressure. Similarly, saturation pressure, or we can say, अगर ये कंडीशन आप जानना चाह रहे हैं तो देखिए, किसी भी लिक्विड का सैचुरेशन टेम्परेचर उसके प्रेशर पे डिपेंड करता है। इट इज अ फंक्शन ऑफ प्रेशर ऑफ द लिक्विड। एंड सिमिलरली वेपर प्रेशर, जिसको सैचुरेशन प्रेशर भी बोल सकते हैं, इज ए फंक्शन ऑफ लिक्विड टेम्परेचर, राइट? सो बॉइलिंग कब होगा किसी भी लिक्विड का? बॉइलिंग, वी ऑल नो that the liquid temperature becomes greater than saturation temperature. Is this the condition of boiling? Yes or no? अगर मैं पूछूं what is the boiling point of water, what is the boiling point temperature of water? If your answer should be the boiling point temperature of water is 100 degrees Celsius at 1 atm pressure. Your answer should be boiling point temperature of water is 100 degrees Celsius at a pressure of 1 atm. Because it is a function of pressure, right? Now, if the water temperature become more than 100 degrees Celsius in an open container means the pressure is 1 atm. Right? So, in an open container, if you boil water, the water will convert into vapor only when the temperature of water becomes more than 100. That is the condition. Now, either you increase the temperature of the liquid to achieve this condition, or you can decrease the saturation temperature of the liquid. अगर वाटर का saturation temperature कम कर दिया जाए, we are not increasing the temperature of liquid, we are reducing the saturation temperature of liquid, then also this condition is achieved. For an example, if you want to get better marks than Sharma ji ka ladka, if you want more marks than Sharma ji ka ladka, then what you can do? Either you work more harder than him, that is one way to get better marks than Sharma ji ka ladka, or what you can do is you can distract his performance, or you can distract him so that his performance reduces, then also you can achieve what your father wants. So that is the another possibility. So reducing the saturation temperature means decreasing the liquid pressure. Saturation temperature is a function of liquid pressure, or increasing the temperature of the liquid increases the vapor pressure of the liquid. So this changes the vapor pressure. If you work on this, then that will change the vapor pressure of the liquid. If you will work on this, then you need to change the pressure of the liquid, and there is a greater than sign. So these two conditions are similar in nature. These two conditions will give you the same result. Are you getting it? हाँ, चतुर. Because it is all about the relative performance. IIT बॉम्बे अगर आप कभी गए हो या सुना हो, कोई हो किसी का भाई बहन IIT बॉम्बे में, IIT बॉम्बे में एक बड़ा फेमस वर्ड है आरजी गिरी। किसी ने सुना है आरजी गिरी? That the chatur used to do, what the chatur used to do, that is called as RG Giri. RG means relative grading, and if you try to distract somebody to reduce his performance, that is called as RG Giri. Clear? So this is nothing but this condition only. इसको other words में लिख सकते हैं, when the liquid pressure becomes less than the vapor pressure, the boiling of the liquid will take place. The boiling or the vapor bubbles will form, and the bubbles will always have the shape of a sphere. Bubbles are always spherical because inside pressure is more than the outside pressure. Concave side pressure is always more than the convex side pressure. That is why the bubbles will form. The shape of the bubble will be spherical. Air bubble ho, चाहे vapor bubble ho, चाहे liquid drop ho, all are having the spherical shape. I hope this is clear to everyone. Now let us move to the next topic, or the analysis of the fluid. First we will talk about the analysis of static fluid, then we will move to the analysis of the moving fluid. But before that, let me tell you the definition of being an ideal fluid. Let me tell you, ideal fluids do not exist in reality, but to make our analysis simple, we consider the fluid to be ideal sometime. So ideal fluid is the one which is having zero viscosity, non-viscous, or we can also call it as inviscid, or we can also call it as frictionless fluid, because viscosity is fluid friction. The fluid which is having zero viscosity, the fluid which is having zero compressibility, or the fluid which is having zero surface tension, no surface tension. The fluid which is having these properties to be zero is considered as ideal fluid. This is called as ideal fluid. Now let us move to the next one. Now the fluid statics. Fluid statics means fluid in hydrostatic condition. And when the fluid is said to be in hydrostatic condition, the fluid is said to be in hydrostatic condition when tau is equal to 0. The fluid is said to be in hydrostatic condition when the shear stress developed is equal to 0. Tau is equal to 0. And the Mohr circle becomes a point. For hydrostatic condition of the fluid, Mohr circle becomes a point. Equal and alike normal stresses. A state of zero shear. Surface tension means zero implies cohesive force is zero. Negligible cohesive force, that is zero surface tension. Surface tension is due to cohesive force. Dreams. So zero surface tension means no cohesive force must be acting between the adjacent fluid particles. Clear? Mohr circle will become a point. Now the first chapter is regarding the manometry. The first chapter in hydrostatic condition or fluid statics. So whatever we are going to discuss is applicable for fluid at rest. When there is no motion, there is no question of relative motion. It means no relative motion. And the fluid is at rest, or if the fluid is flowing, but if the flow is ideal. Or the third possibility is fluid is moving like a rigid body. When there is a fluid in a container, moving container, when the fluid is kept in a moving container, the fluid is moving like a rigid body. So when the fluid is at rest, or even if the flow is there, but if the flow is ideal, or when the fluid is moving like a rigid body, these are the three possibilities for the fluid to be said to be called in hydrostatic condition. Now whatever we are going to discuss will be applicable for all the three cases. Whatever we are going to discuss, the first chapter will be about the manometry. Manometry. Pressure is equal to normal force per unit area. Pressure is normal and compressive. The unit is Newton per meter square or Pascal. Can anybody let me know pressure is pressure a scalar or a vector quantity? Is the pressure a scalar or a vector quantity? There is another unit, kgf per centimeter square or bar or atmosphere. There are so many units of measuring pressure. Is it a scalar quantity or vector quantity? 1 bar is equal to 10 to the power 5 Pascal or 100 kilopascal. 1 atm is equal to 1.013 bar, or 1 kgf is equal to 9.81 Newton. You can easily convert. So first we will talk about the Pascal law. This is Pascal law. That is applicable to a static fluid. So according to Pascal law, pressure is not a function of x, not y, is constant. In case of static fluid, pressure will not change in any direction. Pressure is a scalar quantity. Yes, it is a scalar quantity. It is not a tensor quantity, Bhaskar. Stress is a tensor quantity, but pressure is not a tensor quantity. Pressure is a scalar. It only requires the magnitude. Pressure only requires the magnitude. Stress requires magnitude, direction, and the plane of action. So pressure can be called as zero order tensor. We can call it as zero order tensor. Whereas stress is the second order tensor quantity. There is a difference between pressure and stress. So according to Pascal law, pressure at a point in a static fluid is equal in all direction. It does not depend on the direction. According to Pascal law, pressure is direction independent. Pressure at any point will be same in all the direction. Px will be same as Py is equal to Pz. At any point, pressure will be same in all the direction. The another statement which makes the Pascal law more clear, whenever we apply external static pressure exerted or developed on a fluid is transmitted uniformly throughout the fluid in a horizontal plane. The transmission of pressure is uniform throughout the fluid when it is in a horizontal plane. Look, what does that mean? If we apply a normal force F1, if we apply this is used in hydraulic press. This concept is used in hydraulic press, hydraulic lift, hydraulic ram, hydraulic jack, etc. Now, whenever we apply an external force F1, on the piston, this is the piston. The area of the piston is P1. This is piston. The area of the piston is A1. So there is a pressure P1 developed here. And if there is a static fluid. And this is the point 2, let us say. So the pressure at 2 will exert a force. Pressure at 2 will exert a force which is normal and compressive. That is F2 is equal to P2A2. So according to Pascal law, P1 is equal to P2. Or we can say, what is P1 here? P1 is equal to F1 by A1. F1 by A1 is equal to F2 by A2. A1 is the area of the piston. A2 is the area of the ram. This is the ram. So whatever the force we apply on piston will develop some pressure, and the pressure will be equally transmitted in the horizontal plane. So pressure at 1 will be same as pressure at 2, and pressure at 2 will develop a force. So if A2 is 100 times of A1, if A2 will be 100 times of A1, then F2 will become 100 times of F1, isn't it? So we can easily lift heavy objects through this arrangement based on Pascal law. This arrangement is based on Pascal law. I hope this is clear. You will get better clarity of Pascal law through this statement number 3. When the fluid is static, first of all, the condition is the fluid must be static. Any 2 or more points at the same elevation, it means horizontal plane. Any 2 or more points at the same elevation in a continuous mass of same static fluid. If there is a continuous mass of same static fluid, then they will have same pressure. Same elevation means horizontal plane. Continuous mass means single fluid. If it is a single fluid, then it will definitely be a continuous mass. Multiple fluids means discontinuous mass. And the fluid must be static. If these 3 conditions are getting satisfied, then the pressure will be same for those points. Though the points which satisfy these conditions, all the points which satisfy these 3 conditions, then the pressure will be same. Or we can say out of these 4 conditions, any 3 conditions are getting satisfied, then the 4th one will also be true. In other words, we can say out of these 4 conditions, if any 3 conditions are getting satisfied, then the 4th one will also be true. समझिए इसको. Try to understand this. If there is a U-shaped tube, and there are multiple fluids. There are 2 fluids. Rho 1 and rho 2. There are 2 fluids. Both the limbs are open to atmosphere. Now, both the fluids are static. Do you agree static fluid condition is getting satisfied for all the points lying? If we take any point in the arrangement, the condition of static fluid will get satisfied. Now, if I draw a horizontal line like this, if I take point 1 here, if I take point 2 here, 1 and 2. Now, if we observe 1 and 2, are they lying at the same elevation? Yes, because they are part of a horizontal plane, horizontal line. Static fluid, same elevation. Now, are they part of continuous mass of the same static fluid? It means if they are part of a single fluid, 1 is the part of rho 1 fluid, 2 is also part of rho 1 fluid, yes or no? If both the points are part of a single fluid, then it is the continuous mass. How to check? Join 1 and 2. Join point 1 and 2. Either from top or from the bottom. If they are joined by a single fluid, it means it is a continuous mass. So if you join 1 and 2 from the top, then rho 1, then atmosphere, then rho 2. There are 3 fluids. It means discontinuous mass from the top. But if we join 1 and 2 from the bottom, only 1 fluid is there, that is rho 1. It means it is satisfying the condition of continuous mass also. When these are satisfied, all the 3 conditions are satisfied, then we can say according to Pascal law, P1 and P2 will be equal. Then P1 and P2 will be equal. Now let me know, if we draw a horizontal line here, this is let us say 3, this is let us say 4. Will P3 and P4 be equal? Will P3 and P4 be equal or not? Yes or no? Hi Arithro, I did not see you. You are just coming. You have just entered into the class. Will P3 and P4 be equal? Try to check. Static fluid, yes, applicable. Same elevation, yes, applicable. Continuous mass, are they part of a same fluid? Try to check. If we join 3 and 4 from the top, then we are first traveling in air and then rho 2 fluid. 2 fluids. It means discontinuous mass from the top. If we join 3 and 4 from the bottom, are we traveling in a single fluid? First we are traveling in rho 1 and then we are traveling in rho 2. It means discontinuous. So 3 and 4 are not part of a single fluid. So this condition is not fulfilled. So we can say P3 and P4 will not be equal. Any of the condition get violated, then pressure will not be same. Right? Clear? So Pascal law has nothing to do with the area, shape, size of the tubes. Look, either A1 is equal to A2 or not. It does not matter. P1 will always be equal to P2, whether A1 is equal to A2 or A1 is not equal to A2. Clear? Is not a function of geometry, area or size of the tubes. It has nothing to do with the geometry, area, size. I hope you understood the Pascal law. Can you easily find out which 2 points will have same pressure, which 2 points will not have same pressure, depending on these conditions? If any of the condition mentioned is not satisfied, then the Pascal law will not be applicable. Next is the measurement of pressure in absolute term or the gauge term. The next, let us talk about absolute pressure or gauge pressure. Absolute pressure or gauge pressure. What is absolute pressure? As the name suggests, absolute pressure is the pressure which is measured with respect to absolute zero or absolute vacuum. When we measure the pressure at a point with respect to absolute zero, this is absolute zero. If we measure the pressure at a point with respect to absolute zero, then we get the absolute pressure. And what is the gauge pressure? Gauge pressure is the pressure measured with respect to local atmospheric pressure. This is the atmospheric pressure. This is the atmospheric pressure line. If we measure the pressure at the same point with respect to local atmospheric pressure, then we get the gauge pressure. Right? So absolute pressure at any point can be written as the local atmospheric pressure plus gauge pressure, or we can say gauge pressure at any point is equal to absolute pressure minus atmospheric pressure, and atmospheric pressure must be local. Why local? Because atmospheric pressure varies with location and weather conditions. Atmospheric pressure varies with location and also varies with weather condition. And gauge pressure can be positive or negative. Gauge pressure can be positive or negative. And the negative gauge pressure is called as vacuum pressure. The negative gauge pressure can also be called as vacuum pressure. Negative gauge pressure is called as vacuum or suction pressure. Negative gauge pressure is called as vacuum pressure or suction pressure. So this is how you can relate. Those who are mechanical engineers, in our analysis of thermodynamics, we always use the absolute pressures of the fluid or absolute pressure of the gas. But in fluid mechanics, we generally use the gauge pressure. So, and the question is related to the thermodynamics, then we will first find out the absolute pressure. If gauge pressure is given, absolute pressure can be calculated. And if the question is from the fluid mechanics, and if absolute pressure at a point is given, we can easily find out the gauge pressure by subtracting the atmospheric pressure from the absolute value. That is how these pressures are interrelated. The next one is hydrostatic law. The next one is hydrostatic law. How the pressure varies in vertical direction. Pressure is not constant in a vertical direction. Pressure is not a function of horizontal plane. That is Pascal law. Pressure does not vary in a horizontal plane. That is the Pascal law. But pressure varies in vertical plane. That is the hydrostatic law. So according to hydrostatic law, dP by dz is equal to plus rho g when z is measured in downward direction, and dP by dz is equal to minus rho g when z is measured in upward direction. So with depth, increases with depth, and pressure decreases with height. Pressure increases with depth and decreases with height. That is the hydrostatic law. Right? So if we integrate this, then we will get pressure variation as a function of Z. We can easily get pressure variation with Z if we integrate this. dP by dZ is the slope of P versus Z curve. For incompressible fluid, if rho is equal to constant, then we can say dP by dZ is equal to constant, yes or no? If dP by dZ is constant, then pressure as a function of Z will be linear. Then the pressure as a function of Z will be linear. The variation of pressure with Z will be linear. Rho is constant means incompressible fluid. So for an incompressible fluid, if we want to calculate the pressure at depth h, here Z is equal to 0, here Z is equal to h. This is Z direction, downward direction. Here the pressure is P atm. So dP is equal to rho into G into dZ. The integration will be, Z integration will be from 0 to h. Integration of P will be from P atm to P. So P is equal to P atm plus rho GH. That is the absolute pressure at a depth h from the free surface. That will be the absolute pressure at a depth h from the free surface. What will be the gauge pressure? What is the gauge pressure? That is rho GH. Gauge pressure at a depth h is rho GH. Rho is the density of the fluid. And we can also write the pressure in terms of head. That is P by rho G. That is called as pressure head. That is known as pressure head in terms of fluid column. This is called as pressure head in terms of fluid column. Fluid column. This is called as pressure head. If the pressure is given in Pascal, we can easily calculate the pressure head. If the pressure head is given, we can calculate the pressure in Pascal. This is the conversion. Now, if there are multiple fluid, let us say, this is rho 1, this is rho 2, this is, let us say, H1, this is, let us say, H2. Can you find out the pressure at this point? If there are multiple fluids, rho 1 and rho 2, what is the value of P? What will be the value of pressure? हाँ हरी संधू PDF मिलेगा. ट्रेवर्सिंग ड्रीम्स, अगर पॉजिटिव और नेगेटिव दोनों मेंशन है और नेगेटिव वैल्यू आ रही है तो यू शुड मार्क नेगेटिव. नेगेटिव गेज प्रेशर. देयर इज अ डिफरेंस बिटवीन पॉजिटिव गेज प्रेशर एंड नेगेटिव गेज प्रेशर. So you should always mark negative when you are getting the negative value, right? If the word vacuum is used, then you should mark that. Vacuum pressure. Negative gauge pressure is also known as vacuum pressure. Clear? So can you solve this? So how to find out the pressure at a depth h? Here the pressure is P atm. So P atm is the pressure at the top. Here the pressure is P atm. We are traveling in downward direction. Pressure increases with depth. So plus it will be more than P atm because with depth pressure increases. We are traveling in rho 1 fluid. into G into H1. This is the pressure at the interface. The pressure at the interface of two fluids is P18 plus rho 1 G H1. Now we are further traveling in downward direction. Again plus, because pressure always increases with depth. Then we are traveling in rho 2 into G into, how much is this distance? How much is this distance? H minus H1. Isn't it? Yes or no? That is equal to the value of P. That is equal to P. It is the absolute pressure. Why it is absolute? Because PATM is taken into consideration. When we consider the atmospheric pressure, it means atmosphere is not the reference. And if we want to find out the gauge pressure, then P absolute minus PATM. So it will be rho 1 G H1 plus rho 2 G H minus H1. Do you understand this? This is the gauge pressure at the depth H. Very nice. Badri, Vishal, good, good, good. Samaira, check kariye H minus H2. It will not be H minus H2. It will be H minus H1. Is this clear? So this is about the hydrostatic law. So these two laws are important in writing the pressure equation. What are the two laws? One is Pascal law, which says the pressure in a horizontal plane remains constant. Another is the hydrostatic law, pressure varies with depth. So please guys, do not forget to like this session so it reaches to all your friends, colleagues who are preparing for GATE 2024 examination. Do like and share. It is my humble request to all of you. And do not forget to subscribe our BYJU'S YouTube channel as well. So many students are watching, but number of likes are very less. Are you not happy? कर दिया? Well done. जिन्होंने कर दिया उनको तहे दिल से मेरा शुक्रिया, और जिन्होंने नहीं किया है उनको मेरी रिक्वेस्ट, प्लीज डू लाइक एंड शेयर. लेट अस मूव फर्दर. कोई डाउट हो यहां तक मुझे बताइएगा. Otherwise, try to solve this question. Good. Please do solve this one. Can you solve this? Please give it a try, everyone. करेक्ट ऑर्डर. हाँ, किसी को कोई डाउट हो तो मुझसे पूछेगा. इफ एनीबडी इज हैविंग एनी डाउट. If you have any doubt, do let me know. हाँ, it is doubt resolution time. प्रेशर कहीं पे नेग्लिजिबल नहीं होगा. जहां पे कुछ नहीं होता वहां पे प्रेशर कुछ नहीं होता. प्रेशर इज एक्सर्टेड बाय द मॉलिक्यूल्स ओनली. प्रेशर इज डेवलप्ड बाय द मॉलिक्यूल्स. इफ देयर इज नथिंग, इट मींस एब्सोल्यूट जीरो. जब कुछ नहीं होगा तो वहां प्रेशर भी नहीं होगा. एब्सोल्यूट जीरो प्रेशर कहां होगा ये पूछना चाह रहे हैं. एब्सोल्यूट वैक्यूम जहां होगा वहां एब्सोल्यूट जीरो प्रेशर होगा, विच डज नॉट एग्जिस्ट इन रियलिटी. इसको कैसे करेंगे? प्रेशर हैव बीन ऑब्जर्व्ड एट 4 डिफरेंट पॉइंट्स इन डिफरेंट यूनिट्स एज फॉलोज. Point A is having a pressure 150 kilopascal. Point B is having a pressure 1800 millibar, 20 meter of water, 1240 millimeter of mercury. Now you should convert the pressure in a single unit. Let me convert everything in kilopascal. Point A is having a pressure 150 kilopascal. Now point B, 1800 millibar. So we can say 1800 into 10 to the power minus 3 bar into 100 kilopascal. So it will be 180 kilopascal. Point B is having a pressure 180 kilopascal, 20 meter of water column. So pressure is given by density of water into 10, 9.81 is 10, into 20 meter. That is Pascal, divided by 1000. That is kilopascal. So it is around 200 kilopascal. Point C is having a pressure around 200 kilopascal. 1240 millimeter of mercury. So density of mercury 13.6 into 1000 into 10 into 1.24. That is kilopascal. So how much is that? It is around 165 kilopascal. Yes or no? Convert all the given pressure in a single unit. So point A is having a pressure of 150 kilopascal. Point B is having a pressure of 180 kilopascal. Point C is having a pressure of 200 kilopascal. And point D is having a pressure of 165 kilopascal. So if you convert them, if you arrange them in the decreasing order, then the maximum is C 200, then B 180, then D 165, then A. This should be the correct order of pressure intensity. CBDA. Well done. Akshat, Anushka, Vinay, Bhaskar, Shreyas, एस्पिरेंट्स सीबीडी एस्पिरेंट्स गलत कर दिया आपने. सीबीडीए प्रनाथ, राइट? क्लियर? Now let us move to the manometers. Manometers are the pressure measuring devices. Manometers are the pressure measuring devices which are based on the principle of balancing of the fluid column due to the pressure difference. Whenever there is a pressure difference, the fluid column balances to compensate the pressure difference. There are two types of manometer normally. Simple manometer which measures the pressure at a point, and differential manometer which measures the pressure difference. These are the type of manometer: piezometer, U2 manometer, single column manometer. These are majorly types of manometers, right? Now, this is called as piezometer, open-ended tube. These are called as piezometers. Open-ended tube. So this is, let us say, point 1. The fluid in this pipe is rho 1. This is, let us say, point 2. The fluid in the pipe is rho 2. If we attach a piezometer, the outer limb is open to atmosphere. The other end of the piezometer is open to atmosphere. Let us say the fluid rises by H1 height in the first piezometer. And let us assume the fluid rises by H2 height in the second manometer. So if the pressure is same, if the pressure is constant, then we can say, what is the pressure at 1? What is P1? Isn't it rho 1 into G into H1? Yes or no? What is P2? It will be rho 2 into G into H2. If P1 is equal to P2, then we can say rho 1 G H1 is equal to rho 2 G H2. G and G are getting cancelled out. So we can say rho 1 H1 is equal to rho 2 H2. This is the condition of converting one fluid column into another. For an example, or we can say S1 H1 is equal to S2 H2. If we divide the whole equation, whole expression by, if we divide the entire expression by rho of water, then it will become specific gravity, isn't it? Density divided by density of water will become specific gravity. So अगर ये पीछे वाले क्वेश्चन में क्या था, 20 मीटर ऑफ वाटर. In the previous question, it was 20 meter of water. We can easily convert 20 meter of water into meter of mercury, or vice versa. Mercury can be converted into water column having the same pressure. Look, 20 meter of water. How to convert? In meter of mercury. Now what we will do? Because it is water, so we will say rho of water 1000 into 20 is equal to what is Hg. What is the density of mercury? 13,600 into H2. So we can easily find out H2. The height of mercury column giving the same pressure. Rho1 H1 is equal to rho2 H2. Or this can be converted into meter of glycerin also, meter of oil. So either you take the specific gravity of water is 1 into 20, specific gravity of oil is 0.8 into H2, that is oil column. This is mercury column. So these are the two expressions converting one fluid column into another. Convert single column manometer, inclined single column manometer, inverted manometer. These are the special type of manometers which are used when the pressure difference is very small, to measure the low pressure difference. These instruments are used to measure the low pressure difference, right? Now another is U2 manometer. In U2 manometer, density of manometric fluid should be greater than density of the flowing fluid. Density of the manometric fluid, rho m is the density of manometric fluid. This is the manometric fluid, rho m. Density is rho m. So as long as the pressure in both the limbs are same, then the level of manometric liquid will remain constant. The level of the manometric liquid will be same in both the limbs, right? When the pressure difference is there, if P1 is greater than P2, then there will be a downward deflection of manometric fluid. There is in left limb, and there is an upward deflection of the manometric fluid in the right limb. So there is a pressure difference, there is a deflection in the manometric fluid. Or if P1 is less than P2, this is called as U2 manometer. The shape of the tube is U, that is why it is called as U2 manometer. If P1 is less than P2, if P2 is more, then there will be downward deflection in the right limb and there will be an upward deflection in the left limb. So this is called as the total deflection of the manometric fluid, X. And because we are neither adding any liquid, manometric liquid, or removing any manometric liquid from this arrangement, so we can say volume of the manometric liquid always remains constant. Yes or no? Volume of the manometric liquid will remain constant. अच्छा, आपको कैसे लगा कि स्टूडियो में कोई और भी है? धीरज सर आए थे अभी. Volume of the manometric liquid will remain constant. तो जितना वॉल्यूम यहां है उतना ही वॉल्यूम यहां रहेगा. Let me assume it as A. This area is, let us say, A1. This area is, let us say, A2. Let me assume this as B. So we can say A1 into A must be equal to A2 into B. Yes or no? So we can easily find out if A1 and A2 are given. If any one of them is unknown, we can easily find out the unknown, because the total volume of the manometric fluid remains constant. And A plus B combined together is called as X. That is called as manometric fluid deflection. That is called as manometric fluid deflection. That is called as manometric fluid deflection. All right, clear? This is how U2 manometer works. So one limb of the manometer, U2 manometer, is attached to the pipe where we want to calculate the pressure. So due to the pressure difference, when both the limbs are open to atmosphere, then the pressure will be same. But when one of the limb is attached to the pipe, then there will be a pressure difference, and due to pressure difference, there is a deflection in the manometric fluid. By measuring this deflection in the manometric fluid, we can find out the pressure difference. That is how it works. Nahi, Mahisha, we are not equating the pressure of water and mercury. What I was telling in the previous slide was, try to understand. In the previous slide, what I was trying to make you understand was, if the pressure at a point is given in meter of water column, there are so many units of measuring the pressure. One is Pascal, kilopascal, bar, kgf per centimeter square, atmospheres, or the height of the fluid column. That is another way of measuring the pressure at any point. So if the pressure at a point is given as 20 meter of water, that is the way of representing the pressure, or that is the way of mentioning the pressure at any point. Whether the point is in the water or not, it does not matter. If I am having a oil, for an example, I am having an oil container, and I am measuring the pressure at any point in the oil container, and I am saying it as 20 meter of water. Now, what is the value of this 20 meter of water pressure in Pascal? We can easily do that. Rho of water into G into 20 meter will give you the Pascal. But if somebody asks you what will be the pressure at the same point in the oil container in terms of mercury column, then what will you do? If the pressure is given in terms of water column, then you can easily convert it into mercury column, even though the point which we are talking about is neither in water nor in mercury. The point is in oil. Actually, are you understanding this? So that is how sometimes, for an example, there is a container. I am having a container filled with, let's say, oil. I can say this is point A. Pressure at point A is 20 meter of water. I can say this is point B. Point B is having a pressure 5 meter of mercury. I am having point C. Point C is having a pressure 200 kilopascal. So, ये question actually आपको, so which pressure is more, or if we want to compare, we can easily convert everybody in water column. We can easily convert everybody in mercury column. That is what is the meaning of converting one fluid column into another, giving the same pressure. ये क्वेश्चन जो है, ये क्वेश्चन बेहतर तब होता जब मैं इन पॉइंट्स को कहीं शो करता. These are the 4 points in a oil container. These 4 points are there in the oil container. The question says which point lies above, which point lies below. This is an oil container, let us say. I am having an oil container, and these are the 4 points for which pressure is given. So we can comfortably say that point C is lying here, then point B is lying here, then point D is lying here, then point A is lying here. This should be the arrangement, isn't it? Point C is having more pressure, so it must be lying below. Point A is having the least pressure, so it will be lying above. And between B and D, B is having more pressure, B should lie below than D. This is how the arrangement of the points be. Clear? हाँ, अब चलते हैं हमारे ड्रीम्स के क्वेश्चन पे. A1 may be equal to A2, A1 may not be equal to A2. Look, this is the general expression. This is the general expression. If A1 is equal to A2, if A1 will be equal to A2, let us say. If A1 is equal to A2, then do you agree A will be equal to B? And A plus B is X. So each one of them will be X by 2. Yes or no? A and B will be equal when A1 is equal to A2. If A1 and A2 are not equal, then A will not be equal to B. Ha, Badri Vishal. That is correct. When Sandeep is being called Sandy in his college, जैसे गंगाधरी शक्तिमान है, right? So let us move further. Now, how to write the pressure equation for a U-tube manometer? Pressure equation. Density of manometric fluid is greater than the density of flowing fluid. This is the manometric fluid. This is the manometric fluid. And this is the pressure we need to calculate. And this is rho F. This is the flowing fluid, rho F. This is the manometric fluid deflection. X we can easily calculate. What is X? X is equal to A plus B. And we know A1 into A is equal to A2 into B from the initial level. There is a manometric fluid deflection. Let me assume this as Y. This is open to atmosphere. Here the pressure is P atm. So we start from point P. The pressure at this point is P. The pressure at this point, it is called, there are two methods. One is called a jumping method. One is known as jumping method. In jumping method, what we do is we jump from one point to another in the fluid having the same pressure. Jump through continuous mass of same static fluid in a horizontal plane. It means jumping will be done between the points which are having same pressure, and same pressure will be decided by the condition of Pascal law. This is nothing but the condition of Pascal law. So we will jump from one point to another. This is our origin and this is our destination. We start from origin P, then this point will also have the pressure P, because these 2 points, even though the pipe is having the flowing fluid, even though the fluid is flowing in the pipe, but in the tube the fluid is static. In the tube the fluid is stationary. So we can apply the Pascal law. So pressure here will also be P, because these 2 points are joined by the continuous mass of same static fluid in a horizontal plane. Then we are moving in downward direction. Pressure increases with depth. We are traveling in rho F into G into Y. We are here. Can we jump from here to here? Yes or no? Can jumping be possible between these 2 points? Are these points having same pressure? Are these 2 points having same pressure? Yes or no? No, because they are not joined by the continuous mass. They are not joined by the single fluid. They are not part of a single fluid. Then we are further moving in downward direction. So again plus, still we are traveling in rho F fluid into G into X. Can we jump from here to here now? Yes, we can jump. Here we can jump. These 2 points are part of a single fluid. From the bottom, they are single only. Now we are here. Now we are traveling in upward direction. Pressure decreases with height. There is a negative sign. Now we are traveling in rho M fluid into G. How much height we are traveling? X. Then we have reached to our destination. This is our destination. Whatever the written on the screen should be equal to P atm. Yes or no? And because we are considering the atmospheric pressure, that is why absolute pressure will be calculated. If we want the value of gauge pressure, then absolute minus atmosphere will be the gauge pressure. Then it will be rho M into G into X minus rho F into G into X plus Y. Clear? This is the jumping method. Or you could have started from this P atm, or you could have written like this. P atm, we are traveling in downward direction, so plus rho M into G into X. You could have jumped from here to here. right limb to left limb, then we are traveling in upward direction, minus. Then rho f into g into how much height we are traveling in the same fluid, x plus y, is equal to P. Destination is P. That will also give you the same result. That will give you the absolute pressure. Absolute minus ATM is gauge pressure. There is another method that is known as datum line method. Only the name is different, otherwise the concept wise they are same. Again, we draw a datum line, means the horizontal line is drawn through a continuous mass of same static fluid where the pressure is same. So we need to draw a horizontal line and call it as datum line. This horizontal line can be called as datum line because these 2 points will have same pressure. Or we can draw a horizontal line like this. These 2 points will also have same pressure. Or we can draw a horizontal line like this, as per your choice. Your choice, you can draw any of the three. You can call any of the 3 lines and as the datum line. Because the point lying on the datum line must have same pressure. And how it is ensured? Because the datum line should be drawn through continuous mass of same static fluid. The horizontal line should be drawn through continuous mass of same static fluid. Then the pressure will be same according to Pascal law. Again, if we, this is X, this is Y. Now, let me call it as A, let me call it as B. Pressure at A is equal to pressure at B. Here the pressure is PATM. So if we write the pressure equation, start from this point. This is having the pressure P. We are traveling in downward direction plus rho F. We are traveling in rho F fluid into G into X plus Y. Here that is equal to PA. And to write PB, start from the atmosphere PATM plus, because we are traveling in downward direction, plus rho M into G into X is equal to PB. And according to Pascal law, PA is equal to PB. If RHS is same for both the equation, LHS will also be same. You will get the same. Jumping is easy. Sometimes datum line method is more convenient. Sometimes jumping is more convenient. But concept wise they are same. So we cannot say one is easy and one is difficult. There is difficulty level is same. It is not about difficult or easy. Sometimes datum line method becomes more convenient. Sometimes jumping method becomes more convenient. In datum line method, we do not have to write these 2 equations again and again. What we could have done, P plus rho FG into X plus Y is equal to PATM plus rho MGX. Single equation could have worked. Right? So these are the methods. I hope these methods are clear. Anybody is having any doubt? Please do let me know. If you have anything to ask, do let me know. Or shall we proceed further? Can you solve this one? Can you solve this question? Yes. Yes, the somic pressure measured by the manometer is the gauge pressure. Definitely, it is the gauge pressure. Pressure measuring devices measure the gauge pressure because atmospheric pressure is variable. Atmospheric pressure varies. Find the pressure difference at the floors of 2 tanks. There are 2 tanks. Let me call this point as 1. Let me call this point as 2. So pressure at 1 is P1. Pressure at 2 is P2. We need to find out. This is called as inverted U2 manometer. Inverted U2 manometer. It is called as inverted U2 manometer. And for inverted U2 manometer, density of manometric fluid should be less than density of flowing fluid. Rho 3 is the manometric fluid. Rho 3 is the manometric fluid. it is inverted U2 manometer, right? Now, how to write? Start with point 1, P1, because we are traveling in upward direction. Because we are traveling in upward direction, so the pressure decreases with height. In which fluid we are traveling? Rho1 into G. How much distance we are traveling? H1 to reach here. H1. Then, can we jump from here to here? Will it be allowed? The jumping, this will not be allowed. So what we will do, we will move further in upward direction. There is a negative sign. Then we are traveling in ρ3 fluid into G. And this distance is how much? H2 minus H1. H2 minus H1. We are here. Then can we jump? Yes, we can jump from here to here. This is the point having the same pressure. Then we are traveling in downward direction to reach at point 2. Then there will be plus sign. And then there will be ρ2 into G into H2 is equal to P2. This is the pressure equation. From this pressure equation, we can find out P2 minus P1 or P1 minus P2. From this pressure equation, we can easily find out P1 minus P2. That is the jumping method. Okay, you could have drawn, you could have written the expression where this is the jumping method. You could have used the datum line method also. This is, can we draw this as the datum line? This is the datum line. This horizontal line can be taken as the datum line. This horizontal line can be taken as the datum line. Pressure at this point will be equal to pressure at this point because they are joined by the continuous mass of a single fluid from the top. They are part of a single fluid, isn't it? Don't think that this cannot be taken as a datum line. From the bottom, they are not part of a single fluid. But from the top, if you see, these 2 points are part of a single fluid, ρ3 only. That is why pressure at this point will be equal to pressure at this point. So, start from point 1, P1, traveling in upward direction, minus ρ1G H1, further traveling in upward direction, minus, now we are traveling in ρ3G H2 minus H1. This is the pressure at X, Px. This is point X. This is point Y. So, how to write Py? Then P2 is the pressure at the bottom. We are traveling in upward direction, minus we are traveling in ρ2 into G into H2. This is Py, and according to Pascal law, Px and Py will be equal. That is another way of writing the pressure equation. That is datum line method. That is the datum line method. Right? Or some people use another way. Look how. Some people write the equation in another manner. Because the pressure Px is equal to Py is equal to P. They know that Px is equal to Py is equal to P. So here the pressure is P. Here also the pressure is P. So we are traveling in downward direction. So P, we are traveling in downward direction plus. We are traveling in ρ3 into G into H2 minus H1. Here, we are further moving in downward direction, then plus. We are traveling in ρ1 into G into H1 is equal to P1, is equal to pressure at 1 P1. This is equal to P1. Similarly, start in the right limb, pressure is P. We are traveling in downward direction plus. Now we are traveling in ρ2 G H2 is equal to P2. Subtract these two. If you subtract these two, you will get the same answer because P and P will get cancelled out. If you subtract these two equations, then you will get the same expression. Is this clear? Now there is a single column manometer. This is how the single column manometer looks like. Single column manometer. Why it is called a single column manometer? Because A1 is very, very large compared to A2. One area of one limb is very large compared to another limb. It is also known as micromanometer. It is also known as micromanometer. Initial level of manometric fluid was here. Initial level was here. This was the initial level. And when we attach, this is having density as rho F. Density of the flowing fluid is rho F. This is the manometric fluid rho M. Rho M is greater than rho F. Then by attaching a pipe, this is, let us say, H1. This is H2. By attaching a pipe, this is the level in the left limb. This is, let us say, delta H. So if we write the pressure equation, this will be the datum line. We can call this to be a datum line. If we write the pressure equation, then we can start from PA. PA is the pressure. Here also pressure is PA. We are traveling in downward direction. So plus rho F into G into H1 plus delta H is equal to pressure here is equal to PATM. We are traveling in downward direction plus rho M into G into, if we want to reach here, then it will be H2 plus delta H. This is the pressure equation. The pressure equation will have a similar concept. Writing the pressure equation using the Pascal law and hydrostatic law will be same, isn't it? And can we say A1 into delta H? This volume is decreasing in the left limb and this volume is rising in the right limb. So can we say A1 into delta H is equal to A2 into H2? Or from here we can say delta H is equal to A2 by A1 into H2. Yes or no? This instrument is used to measure the low pressure difference. It magnifies the deflection. And for A2 to be very, very less than A1, we can say delta H is very small. We can ignore delta H. And if we ignore delta H, then we can say P is equal to rho M into G into H2 plus or minus. That is the gauge pressure. Then we can say minus rho F into G into H1. That is the gauge pressure. So this is how the single column manometer is used. There is another instrument which is called as inclined single column manometer. One more instrument is there that is called as inclined single column manometer. Clear? If you have any doubt, please do let me know. Is this all clear to everyone? For inclined single column manometer, there is angle theta. Angle of inclination with horizontal. With the horizontal. Pressure equation will remain same. This is H2. This is H1. This is delta H. Pressure equation will remain same. But this is L. So we can say pressure equation will remain same as earlier. Here also A2 is very, very less compared to A1. That is called as inclined single column manometer. Pressure equation, there will not be any change. But we can say A1 into delta H is equal to A2 into L. It will be A2 into L. This volume. and H2 will be equal to L sine theta. H2 will be equal to L sine theta. Isn't it? H2 will be equal to L sine theta. There is a parameter defined that is called as sensitivity of the instrument. That is equal to 1 upon sine theta. That is equal to L by H2, which is greater than 1. That is called as inclined single column manometer. This is inclined single column manometer. I hope this is clear. Any doubt? Please do let me know if you have any doubt so far. These are the instruments. Now, can you quickly solve this one? Can you solve this question? And after this question, we will move to the hydrostatic force. After this question, we will move to the hydrostatic force. And after hydrostatic force, we will move to the buoyancy and flotation. Statics is very, very important compared to any other topic. Fluid statics is very important. And after the buoyancy and flotation, we will take the lunch break. Will it be okay? Or do you need a break right away? Yes, tell me. If you guys need a break, you need a break for 10 minutes? Okay, so let's take a break for 10 minutes. In my watch, it is 1:15. We will be back. Take 10 minutes break. And meanwhile, try to solve this question. Solve this question, and after this, we will. They are not closed. They are open like this. This is how the figure is. Okay. So see you after the break. And we will start the hydrostatic forces. All right. See you guys. Hello guys, welcome back. Did you try this question? Am I audible and visible? क्या आंसर है इसका? सौमिक सी, राजा सी, विनय सी, एस्पेरेंट ए, अनुष्का ए. So let us solve this one. So guys, there is an important announcement with me. Abhinav Negi sir is there.
Dhiraj sir.
Dhiraj sir is also there
Dhiraj sir busy with
to motivate you.
So again guys, in the same jacket. Just when salary will come, I'll buy a new jacket.
जैकेट के लिए आपको सैलरी की कोई जरूरत नहीं है, तक मैं जानता हूँ.
Okay. So guys, the complete FM marathon will be done by sir, and you all are enjoying and giving us the superb response. Okay, and as we promised yesterday that me and Dhiraj sir will be taking Som practice session. Okay, that will be tonight at 11:30 p.m. Okay, Som practice session tonight 11:30 p.m. Okay, and here complete Som FM marathon will be done. And also guys, if you are 2025 sprint, then there is a workshop, free workshop at 7:30 p.m. where we can win 50,000 scholarship and 5,000 Amazon voucher to 3 students. Okay, but first please attend the complete FM marathon. Harry Sundu from Bihar. Okay, so one promise was practice session live, that is today at 7:30 p.m. Second promise was PDF. So one PDF is shared by the student itself of last year. Okay, so that is same. You can refer it. That is shared in our board telegram. दोनों में
आप में मेरे में मैं कर दूंगा.
Otherwise, we will
है
find that.
मेरे वाले में है वैसे.
है ना?
शेयर किया था.
So एक बच्चे ने ही शेयर कर रखा है. You can see that complete so marathon PDF. Okay, so both promises we have done. A PDF also, that is in our telegram group, and practice session.
Yes guys, be ready, and within 1-2 days you will get the schedule of maths and FT completely on the telegram channels. Be ready for that. Okay, everything will be covered on this channel for every mechanical and civil student. So be ready, and even if you are appearing for XC, for that also everything will be there. Analysis of both the exams will be done, mechanical, civil, XC, every exam. Okay, so
On
be
the
ready
same- on the same day.
So you just need to be with us till your results. Okay,
Yes, 11:30 p.m. is the class timing tonight.
tonight 11:30 p.m.
Okay, and analysis of mechanical will be on 3rd, civil will be on 4th, and XZ will also be on 2nd weekend. XZ will also be there. Complete analysis. Okay, so we 3 are of all na civil mechanical sub hai.
XC.
So guys, do like and share so that rest of the student also join. है ना, पूरा कल जैसा ही रिस्पॉन्स दिखाना है और एकदम मचा देना है आज भी, और ये रोज चलते रहना चाहिए. ठीक है. टू मैकेनिकल स्टूडेंट आई वुड ऑल्सो लाइक टू टेल यू कि टुमारो आई विल बी कमिंग विद द नेक्स्ट सब्जेक्ट, दैट इज कास्टिंग वेल्डिंग प्रोडक्शन पार्ट, एंड एनवायरमेंट विल बी देयर फॉर सिविल. So be ready. Every day we have one marathon till from morning till the subject will be over. Okay.
And soil will be on day after tomorrow. Soil marathon. ये सिलसिला यूं ही चलता रहेगा अब. ओके, ठीक है सर, आप मचाइए.
ठीक है सर.
फनींद्र
एक्स ऑफिसर चंद्रशेखर सर, बताइए. मैंने हाथ मिला लिया एक्स ऑफिसर से, मैं धोऊंगा नहीं.
फनींद्र is asking something.
2 minute MD is there. Okay.
वो 14-15 aptitude वाला.
Okay.
Okay, we will see.
13th and 14th को ऐप पे है ना, तो
We will see that. We will see that.
Okay. ठीक है. हाँ, 12th को soil है.
okay guys, so the answer to this question is option A. कैसे होगा ये? Look, let us assume the pressure at A as PA. यहां पे स्टूडेंट्स मिस्टेक करते हैं. Let me tell you the mistake most of the students commit here. जिन लोगों ने ऑप्शन सी को सेलेक्ट किया है, they have directly jumped to the conclusion. Vinay, workshop will be there tonight around 7 o'clock. Option C, those who are getting option C, they are directly jumping to the conclusion. look how to write the pressure equation. If you see the options are in meter of water. So what we will do, we will write the pressure equation in meter of water itself. Pressure equation in meter of water. कैसे लिखेंगे? Let us assume the pressure at point A is PA, pressure at B is PB. So starting from point A, pressure at A is PA. We are traveling in upward direction. When we travel in upward direction, there is a decrease in pressure, negative sign, right? Let me assume this distance to be H, capital H. This is water and this is mercury. The manometric fluid is mercury, the flowing fluid is water. So we are traveling in upward direction in water itself. So no need to convert this water column in any other column because the options are in water column. So we are traveling H height in water. PA minus H will be the pressure here in terms of water column. Then we can jump from here to here. Can we jump? Because these 2 points are having same pressure, continuous mass of same static fluid. This point will also have the same pressure, PA minus H. Can we jump from here to here again? Yes, because these 2 points are also joined by the same fluid, that is mercury. Now from here we are traveling in upward direction. Again negative sign. Now we are traveling in manometric fluid up to how much column? 0.6 meter of mercury. So convert this mercury column into water column. So specific gravity of mercury is 13.6 into 0.6 is the mercury column divided by 1. That is the specific gravity of water. Now can we jump from here to here again? Because these 2 points are also joined by the same static fluid. Now from here we are traveling in downward direction. Now we are traveling in downward direction, pressure increases. Plus we are traveling 0.6 in water. We are here. Now we are further moving in downward direction, plus the distance traveled is H plus H is equal to our final destination is equal to PB. This will be the correct pressure equation using the jumping method. So if you simplify this plus H and minus H will get cancelled out, and PA minus PB will come out to be 7.56 meter of water, right? 7.56 meter of water column. Clear? Now we will move to the next topic, that is hydrostatic forces. Hydrostatic force. What is hydrostatic force? Hydrostatic force is pressure into area. Hydrostatic force is the force exerted by the hydrostatic fluid on a surface. Pressure multiplied by area will be the amount of hydrostatic force. But pressure is a function of Z. In vertical plane, pressure varies according to hydrostatic law. That is why we need to go for integration, because it is variable. And the hydrostatic force is always acting normal and compressive. That is what we have already told you. FM practice session Acharya, I will plan today evening. I will plan either the session will be tomorrow or day after. I will let you know. For the practice session, I will update you. Okay. So hydrostatic force will be calculated by pressure multiplied by area, and the point of application is known as centropressure. The point of application is centropressure. The point at which the total hydrostatic force is supposed to be acting is called as CP. And the depth of CP from the free surface is HCP. So hydrostatic force will be calculated in two cases. One is, नहीं विनय, प्रीवियस क्वेश्चन में आंसर सी नहीं आएगा, if you will solve this equation, PA minus PB अगर solve करेंगे, so it will be 12.6 into 0.6. There is a 0.6 also. So it will be 12.6 into 0.6. It will not be 13.6 into 0.6. PA minus PB will be equal to 12.6 into 0.6 meter of water. That will come out to be 7.56, right, Vinay? यही तो बोला मैंने कि अगर आप डायरेक्टली यहां से कंक्लूड करेंगे, then you will make a mistake in writing the pressure equation correctly. प्रेशर इक्वेशन को सही से लिखेंगे, so 12.6 multiplied by 0.6 meter of water. Right? So let us talk about the hydrostatic force. First, we will talk about the hydrostatic force on a plane surface. Dreams, that is how the questions are framed from the manometry. In the first attempt, the questions look very simple. But if you will commit any mistake in writing the pressure equation correctly, a small mistake in pressure equation will give you the incorrect answer. So you should be very, very careful in applying the Pascal law, in applying the hydrostatic law, right? So hydrostatic force on a plane surface. If the surface is in inclined position, theta is the angle of inclination with the free surface. Angle of inclination with free surface. So the formula for hydrostatic force will be rho into G into A into X bar. And what is X bar? X bar is the depth of centroid. X bar will be the depth of centroid of the plane surface from free surface of the liquid. Why we are considering the free surface? Because the pressures are measured with respect to the free surface. At the free surface, pressure is PATM or zero. Gauge pressure is zero. That is why all the parameters are calculated with respect to the free surface. Rho is the density of the fluid. G is acceleration due to gravity. A is the area of the plane surface in contact with the fluid. And X bar is the depth of centroid of the plane surface from the free surface. And HCP, depth of CP, is calculated by this formula. X bar plus Ig by AX bar sine square theta. Ig is the area moment of inertia of the plane surface about its centroidal axis parallel to the free surface. A is the area of the plane surface. X bar is the depth of centroid of the plane surface. And if it is vertical, then theta will be equal to 90 degree. If the surface is vertical, then theta will become 90 degree. Isn't it? When theta will become 90 degree, then sine theta will be equal to 1. Sine 90 will be equal to 1. Sine 90 will be equal to 1. So the formula for HCP will be given by X bar plus Ig by AX bar. For a horizontal surface, theta will be equal to 0 degree and sine 0 is 0. So HCP will be equal to X bar. The location of CP and G will coincide with each other. Inclined is a generalized case, yes. If you are able to understand the formula for inclined plane surface, then you can modify the expression for plane, vertical and horizontal plane surface. Sine 0 is equal to 0. Sine 0 will be equal to 0. So HCP is equal to X bar. तो कोई भी surface हो, ध्यान दीजिए. Look, if we talk about the plane surface, this is, let's say, free surface. So this is the location of G and this is, let us say, CP. CP will always lie below G This is HCP and this will be X bar. The force will be applied at centro pressure. The depth of centro pressure from the free surface will be HCP and the depth of centroid of the plane surface will be G. X bar is equal to this distance. The depth of centroid from the free surface. Clear? So the force can be calculated by average pressure into area also. And what is the average pressure? Average pressure is the pressure which is developed at G. That is rho G X bar. If you calculate the average pressure, pressure varies with depth. Pressure at A is different, pressure at B is different. Pressure increases with depth. That is why the location of CP lies below G. G is the centroid, which is G is the centroid of the plane surface. Centromass, where the weight of the body, weight of the surface is acting. CP is the point where the hydrostatic force will be acting. So average pressure की जगह rho G X bar लिख दें, multiplied by area, you will get the same formula. You will get the same expression, right? So these are the formula for orientation of the plane surface. There is one more method to calculate the hydrostatic force and the point of application by using the pressure prism. Another method is by using the pressure prism. एक तरीका हाइड्रोस्टैटिक फोर्स कैलकुलेट करने का ऑलरेडी मैंने बताया आपको. क्या है वो तरीका? By calculating the average pressure multiplied by the area. The another is by using the formula rho G A X bar directly. The third formula is developing the pressure prism. For an example, this is the free surface of the liquid. This is the free surface. And pressure is equal to 0. Gauge pressure is 0 at the free surface. This will be a point. And if this is H, then the pressure at the bottom will be equal to rho G H. Isn't it? And pressure linearly increases with depth. So the pressure prism will look like this. This is the pressure prism. It will be a triangle. So if you draw the pressure prism, width is constant. This is suitable for the surfaces which are having constant width. So hydrostatic force is equal to volume of pressure prism. Hydrostatic force can be calculated by calculating the volume of the pressure prism. Area of this triangle multiplied by the width, like this. So it will be the hydrostatic force. Area क्या होगा? Area होगा half into base into height. What is base? Rho G H. Into height कितना होगा? H. That is the area multiplied by width. That is the expression. So H into B is area of the plane surface, B into H. And the depth of G from the free surface is X bar, that is equal to H by 2. H by 2 is X bar. So F is equal to rho into G into area into X bar. And the line of action of this hydrostatic force will pass through centroid of the pressure prism. That is the concept here. When you draw the pressure prism, the line of action of this hydrostatic force will pass through the centroid of the pressure prism. What is the centroid of the pressure prism? The depth of centroid of the pressure prism. ये क्या 2h by 3 नहीं होगा? It will be 2h by 3 from the free surface, and this will be h by 3. Centroid of the triangle. So we can say HCP is equal to 2h by 3. फॉर्मूले से भी वही आएगा और डायरेक्टली भी बोल सकते हैं. HCP is equal to 2h by 3. That is how we can use the concept of pressure prism to find out the location of centro pressure. The hydrostatic force always acts at centro pressure. From the bottom it will be h by 3. From the top it will be 2h by 3. So depth of center of pressure from the free surface will be 2h/3, right? ये कॉन्सेप्ट तब ज्यादा बेनिफिशियल होता है when there are multiple fluids. Try to understand how. This is the free surface. The pressure at the free surface will be 0. There are two fluids. This is ρ1. This is ρ2. There are multiple fluids ρ1 and ρ2. Let me call this to be h1. Let me call this distance to be h2. And width is b. B. So if we draw the pressure prism, एक ये ट्राइंगल बनेगा, यहां का जो प्रेशर होगा, what will be the pressure here at the interface? Isn't it ρ1 g h1? और बॉटम पे प्रेशर होगा ρ1 g h1 प्लस ρ2 g h2. So अगर इसको दो पार्ट्स में डिवाइड कर लें, so there are three figures as such. Three standard figures. This will be ρ1 g h1 and this will be ρ2 g h2. This will be the pressure prism. So F is equal to F1 plus F2 plus F3. What is F1? Volume of this pressure prism 1. That is equal to half into base ρ1 g h1 into height h1 into b. What about F2? F2 is volume of this pressure prism 2. That is equal to ρ1 g h1 base into height, that is h2 into b, width. And what is F3? F3 will be equal to volume of this third pressure prism, that is a triangle. So half into base is ρ2 g h2 into height is h2 into b. Yeah. And if we want to find out HCP, then we will equate the moment about the free surface. So we can say to find out HCP, so we will say HCP is equal to, or F into HCP is equal to F1 H1 plus F2 H2 plus F3 H3. F1 H1 plus F2 H2 plus F3 H3. Right? What is H1? H1 is the centroid of the pressure prism 1, C1. The depth of CP, this is H1. So H1 will be equal to, क्या होगा H1? Isn't it 2H1 by 3? What about H2? The centroid of pressure prism 2. So H2 will be equal to, it will be H1 plus H2 by 2. And what is H3? The depth of centroid of the pressure prism 3 from the free surface. This is H3. H3 will be equal to H1 plus 2H2 by 3. So if we put the values F1, F2, F3, H1, H2, H3 and F total, then we will be able to get HCP. This is how we can determine the depth of center of pressure for the entire arrangement from the free surface. This is how we can calculate HCP. Is this clear? If anybody is having any doubt, please do let me know. चाहे ये प्लेन सरफेस वर्टिकल हो या इंक्लाइंड हो, हॉरिजॉन्टल में तो कोई दिक्कत नहीं है, बिकॉज इन केस ऑफ हॉरिजॉन्टल प्लेन सरफेस प्रेशर रिमेन्स कांस्टेंट, सो नो नीड टू गो फॉर इंटीग्रेशन. प्रेशर इनटू एरिया विल बी द प्रेशर फोर्स. हाँ, ड्रीम्स, ये मेथड, this method is applicable in every type of surface. Try to understand this. The method is equally valid for all type of surfaces, whether they are having constant width or not. But when the width is variable, then you will not be able to find out the volume of the pressure prism unless you do the integration. Are you getting it? Without doing the integration, you cannot find out the volume of the pressure prism. और अगर वॉल्यूम ऑफ द प्रेशर प्रिज्म नहीं फाइंड आउट कर पाएंगे विदाउट द इंटीग्रेशन, देन इट इज बेटर टू यूज द फॉर्मूला, देन नो नीड टू यूज द प्रेशर प्रिज्म. आर यू गेटिंग इट? द प्रेशर प्रिज्म विल नॉट बी ए ट्राइंगल, the width will not be same, so you cannot find out the volume. But agar constant width surface or like rectangle or a square, then this method will be easier to apply compared to the surfaces which are having variable width. और variable width के case में use the formula, direct formula, or do the integration. That is how you will be able to get the answer. All right? अगर circular plate हो, if it would have been a circular plate, we cannot use the pressure prism. सर्किल का सेंटर पे जो विड्थ है वो डायमीटर के बराबर है, टॉप पे विड्थ 0 है, बॉटम पे विड्थ 0 है. So for variable width we cannot use the pressure prism. We can use the pressure prism, but it will not be easier. It will be difficult. Doing the integration is difficult, and for calculating the formula we have already done the integration. ये formula जो आए हैं ये इंटीग्रेशन से आए हैं. ये जो फॉर्मूले मैंने लिखे ये इंटीग्रेशन से ही मिले हैं. So better use the formula because we have already done the integration. बताइए इसमें कोई डाउट? देखिए क्या किया मैंने, फिर से एक बार रिपीट कर देता हूं. F1 will be calculated by volume of this figure. F1 ट्राइंगल का एरिया फाइंड आउट करिए मल्टीप्लाइड बाय विड्थ, दैट इज F1. F2 इस रेक्टेंगल का एरिया फाइंड आउट करिए मल्टीप्लाइड बाय द विड्थ. F3 इस ट्राइंगल का एरिया मल्टीप्लाइड बाय द विड्थ, बिकॉज वॉल्यूम इज व्हाट इज रिक्वायर्ड. क्लियर? इस ट्राइंगल का, इसका बेस है ρ2gh2, हाइट है h2, so half into base into height is the area of the triangle. There are 3 standard figures, 1, 2 and 3. ये 3 स्टैंडर्ड फिगर्स बन गए. सो F1 प्लस F2 प्लस F3 तीनों का वॉल्यूम लिखा है मैंने. विनय क्लियर? अगर सिंगल फ्लूइड होता तो एक ही ट्राइंगल बनता क्योंकि प्रेशर इंक्रीजेस लीनियरली. बट अगर मल्टीपल फ्लूइड्स हैं, डेंसिटी ऑफ 2 इज ग्रेटर देन डेंसिटी ऑफ 1, तो ये एक सिंगल ट्राइंगल नहीं है. इट इज नॉट ए सिंगल ट्राइंगल. The slope of this triangle is different. The slope of this line is different. So it is not a single triangle. Are you getting it? The difference. If the fluid would have been same, single fluid, then it would have been a single triangle. But here, this is a trapezium actually. And this is a triangle. So trapezium can be divided into 2 parts, a rectangle and a triangle. Right? Ab, the depth of CP, इक्वेट मोमेंट अबाउट द फ्री सरफेस. F1 यहां पे एक्ट करेगा. F1 will act at centroid of the figure 1. F2 will act at centroid of figure 2. F3 will act at centroid of figure 3. F1 will act at C1, F2 will act at C2, F3 will act at C3. Now if we equate, and the total hydrostatic force will act at CP, if we equate the moment about the free surface, so total moment of F about the free surface is F into HCP. That should be equal to F1 into H1 plus F2 into H2 plus F3 into H3. And H1, H2, H3 are measured from the free surface because we are equating the moment about the free surface. So इसका जो centroid है ये है 2H1 by 3. So H1 will be 2H1 by 3. इसका जो centroid है वो यहां कहीं है C2. The line of action here, F2 will be acting like this. So ये जो distance है from the free surface, that this is H1 plus this will be H2 by 2. Yes or no? It is half of H2 because it is a rectangle. Centroid of the rectangle is half of H2. So small h2 will be H1 plus H2 by 2. Similarly, ये F3, ये इसका centroid है, इस triangle का centroid है. This distance will be 2H2 by 3. Yes or no? From the free surface, H3 will be equal to H1 plus 2H2 by 3. Anwar, we can equate the moment about the bottom also. We can do the moment about the bottom. Then we will not call it as HCP. Then we will not call it as HCP. HCP is always measured from the free surface. So HCP will come out to be H1 plus H2 minus H bar. Anwar. In that case, HCP will be equal to H1 plus H2 minus H bar. We can do that. We can equate the moment from any point. Clear? Devika, नहीं, F2 के लिए why it will be rho 2g H2. Try to understand. The pressure at the bottom will be rho 1g H1 plus rho 2g H2. Pressure at the bottom using the pressure equation rho 1g H1 plus rho 2g H2. So this entire length is rho 1g H1 plus rho 2g H2. So if this is rho 1g H1, we are calling it as rho 1g H1 plus the remaining distance is rho 2g H2. So we need to calculate the area of this triangle. This is rho 1g H1 multiplied by H2. Wall area of this rectangle. Similarly, for area of this triangle, rho 2g H2 is the base. For triangle, base is rho 2g H2, but for rectangle, the base is rho 1g H1. Adding these two will give you the pressure at the bottom. Direction of pressure force will be normal and compressive. Normal to the surface and compressive towards the surface, right? Is this clear or not? Whatever the expressions I have mentioned, are they clear? Nirvana, it is just the concept. Volume is not a force. The unit is not. Iska unit check kariye. What will be the unit? What is the unit of rho 1g H1? What will be the unit of rho 1g H1? What is the rho 1g H1? Isn't it Newton per meter square? Yes or no? What is the unit of H1? Meter. What is the unit of B? Meter. Meter square getting cancelled out. Isn't it Newton? That is why it is force. That is how it is force. Rho 1g H1 is not meter. Rho 1g H1 is the pressure Pascal. I hope it is clear. So volume of the pressure prism does not mean the unit to be meter cube. Because the pressure prism, that is why we are calling it as pressure prism. Because the base is Pascal. The unit of the base is Pascal. अगर आप इसको B से multiply नहीं करेंगे, area सिर्फ कर देंगे. If you will only calculate the area of the pressure prism, then it will not become Newton. Then it will not become force. Right? I hope this is clear. This type of question will be a little bit advanced type of question. It requires more time to solve. But still, there are questions which had been asked in GATE exam from this pressure prism. Pressure prism will make your life easier. When you are comfortable with the pressure prism, your life, your understanding will become more and more clear. Or your calculation will become more simple. Now there is a question on the screen. One question. Let us solve this one. Can you solve this question? A vertical gate. हाँ निर्वाणा, डेफिनेटली आई विल इंक्लूड सम क्वेश्चंस. और अगर आप पिछले गेट के पेपर को देखें, देयर वाज अ क्वेश्चन इन मैकेनिकल related to the pressure prism only, right? So practice some questions from the pressure prism also. Then you will become more and more comfortable. Giving the concept here, and if you are not practicing some numerical based on the concept, then you will not become comfortable. You will be always be reluctant to apply the concept of pressure prism unless you do some practice, right? There is a question on the screen. Can you solve this? a vertical gate which is 6 meter by 6 meter. It is a square plate. This is 6 meter. The base is also 6 meter. यहां पे स्टूडेंट्स को कंफ्यूजन होने लग जाता है व्हेन आई डिस्कस अबाउट द प्रेशर प्रिज्म. सो व्हेन आई से एरिया ऑफ द प्रेशर प्रिज्म मल्टीप्लाइड बाय द विड्थ will give you the hydrostatic force. Then they start doing the mistake. How? Look, what they start doing is, in this expression they start using the A as area of the pressure prism. Do not mix them. In this formula, in these expressions, pressure prism is not drawn. When I discussed, when I had shown you these formula, pressure prism had not been drawn. Right? So A is the area of the plane surface in the formula. So either use the formula or use the pressure prism. Do not mix them together. Do not mix them. Otherwise, you will commit mistake. So either use the pressure prism or you can solve by using the formula. That is your choice. So 6 meter by 6 meter holds water on one side with free surface at its top. Then moment about the bottom edge. This is the bottom edge. Then you need to find out the moment about the bottom edge of the gate due to the water force. Gamma W is the specific rate of water. First of all, find out F. Rho into G, that is gamma for water, into area of the plane surface. Rho G A x bar I am using. So area will be 6 into 6 into x bar. X bar is the depth of centroid from the free surface. Centroid of the plane surface. I am not drawing the pressure prism at all. So x bar will be equal to 3, isn't it? 6 by 2. So this will be the amount of force, rho g x bar. Now, when we talk about the moment, then for moment to be calculated, the point of application will be required, isn't it? So the point of application of this hydrostatic force is not at G, it is acting at Cp. Now, how to calculate HCP? This is HCP. How to calculate HCP? HCP is equal to x bar plus Ig by Ax bar. X bar is 3. Ig will be equal to, Ig is this, area moment of inertia. This is Ig. Area moment of inertia of the plane surface about its centroidal axis parallel to the free surface. So Ig will be equal to BH cube by 12. So 6 into 6 cube by 12. Yes or no? Into area 6 into 6 into x bar 3. So either use the formula. This will be HCP. So this will come out to be 4 meter. Yes or no? HCP. That is one way. Force will be this and the depth of central pressure will be 4 meter. It will not be 3 meter. The depth of Cp will be more than the depth of centroid of the plane surface, right? So that is one method. The another method is by drawing the pressure prism. If we draw the pressure prism, this is the free surface because it is a rectangle. This is 6 meter. This is also 6 meter. The pressure here will be 0. If we draw the pressure prism, then the pressure prism will be like this. So volume of the pressure prism will be the force. F is equal to, do you agree that is equal to gamma for W into G into 6 rho GH. So half into what is the base? Gamma into G into 6 into height, that is 6. That is the area into 6. That is the volume of the pressure prism. Do not miss this. Are you getting the same result or not? 6 into 6 into 3 into gamma. Here also, you will be getting 6 into 6 into 3 gamma. Now, the line of action of this hydrostatic force will pass through centroid of the pressure prism. This is Cp. Now, do you agree what is the location of centroid of the pressure prism? That will be 2h by 3. 2 into 6 by 3 from the top. Here it will be 6 by 3. So that is 4 meters. So this is HCP. This will be HCP. HCP will be equal to 4. And if we want to take the moment, the force will be acting like this. If we want to take the moment about the bottom, then this will be the perpendicular distance taken care. So the moment about the bottom will be equal to F into 2 meter. That is where students commit mistake. Whenever we want to calculate the moment, then the location of application of hydrostatic force will be required. So when the question goes up to the moment about any point, then you should understand that the hydrostatic force always acts at center of pressure, and distance of center of pressure need to be calculated. From the bottom, this will be. So from the top, the moment about the top, F into, it will be 4 meter. And moment about G, F into, what is the moment about G? What will be this? If the question asks you to find out the moment about the centroid of the plane surface G, G is here. How much you are supposed to take? G is somewhere here. So moment about G, what will be taken into consideration? Bataiye. If we want to take moment about G, this is the force acting here. So do you agree we need this distance, isn't it? The perpendicular distance from the point about which moment is taken. So it will be 4 minus 3, that is 1 Newton meter. Do you guys understand? Yes or no? Do you guys understand it? Aa raha samajh mein? Is this clear or not? So the answer, correct answer to the question given is option number D. Are you getting option number D? Moment about the bottom. Force multiplied by 2 meter. Clear? कोई कंफ्यूजन हो तो बताइए. अब tell me if there is any confusion. Can you simplify this question? Can you solve this one? It is an inclined surface. In the situation shown in figure, length AB is 3 meter. This is AB. This is the inclined surface. M is the midpoint of AB. The hydrostatic force by water on AB, the water is here. And force exerted by water is normal and compressive. This is how the force will be exerted. Normal and compressive. Normal to the surface and compressive in nature. The width of the surface is unit. The width of the surface, this is like this. The width of the surface is 1 meter. And acceleration due to gravity. So first of all, you need to understand the hydrostatic force will not pass through M. It will not pass through M. It will pass through CP, which lies below M. So whatever is the force, it will not pass through M. Whatever is the force, it will not pass through M. That is for sure. It will not pass through the centroid of the plane surface. The force will pass through a point between M and B. Yes or no? Because of increase in pressure with depth. Now, how to calculate the magnitude? What is X bar? If we talk about X bar, then this distance will be X bar. This will be X bar. Apply the formula rho g A X bar. All the options are given in terms of G. Do not write G's as 9.81. So force will be equal to rho of water into G into area, that is 3 into 1 into X bar. What is X bar? Can you find out X bar? Depth of centroid of the plane surface from the free surface, that is 4 plus 1.5. 1.5. AM is 1.5. The distance between A and M is 1.5 into cos 60. Yes or no? This is x bar. That will be the value. This will be the value of force. Now, this is the surface. AB is the surface on which we are calculating the force. We want to calculate the force on AB. So the surface under consideration is AB only, right? And the depth of centroid of AB from the free surface is not 4 plus 1.5. It will be 4 plus 1.5 cos 60, right? X bar hoga 4.75. That is correct. X bar will be 4.75, and then you will get your answer to be 14,250 G Newton, which will be passing through a point between M and B. Can you find out the depth of CP? Can you find out HCP? Can you find out HCP? This. Can you find out HCP? Can we use the pressure prism? Can we use the pressure prism to find out the depth of central pressure from the free surface? Yes or no? Please write Y in the comment section if your answer is yes. Please write N in the comment section if your answer is no. Can we use the pressure prism? Yes, we can use the pressure prism. But the only problem you will be facing, what will be the shape of the pressure prism? The pressure here will not be zero. The pressure at A will not be zero, right? If the pressure at A will not be zero, so it will not be a triangle. The pressure prism will not be a triangle. What it will look like? It will look like a trapezium. Are you getting it? So if you draw the pressure prism, there is a pressure here also. There is a pressure here also. The pressure prism will be looking like this. And it will be difficult for you to find out the centroid of the pressure prism. Trapezium का centroid तो बड़ी मुश्किल हो जाएगा. जिन लोगों को formula याद है, yes, there is a formula to find out the centroid of the trapezium. If you know that formula, then you can easily use. But if you do not know the formula for centroid of the trapezium, then the pressure prism will not be helpful. Clear? हाँ, फनिंद्र आप क्या पूछना चाह रहे हैं? Which area you are talking about? Area of the plane surface you are talking about? The plane surface is a rectangle of dimension 3 meter by 1 meter. This is 1. 3 by 1. This is the area of the plane surface. In the formula, rho g ax bar, A is the area of the plane surface. Right? And x bar is the depth of centroid. Centroid is M. M is the centroid of the plane surface. So the depth of centroid from the free surface is x bar. Clear? Now, who can find out the location of, this is M. This point is M. Who can find out the location of CP? This is CP. It is lying below. So the force will be shown at CP. Here the force is acting, which is normal and compressive. So if I ask you this distance, this is HCP. Can you find out HCP? How to find out this HCP? Use the formula. What is the formula? Use the formula. So HCP is equal to x bar plus Ig by Ax bar. Do not forget sin square theta. What is theta? What will be theta? Rahul, that is true. Well done. अगर कोई trapezium बनता है, the height of the trapezium is h, let us say. Smaller parallel side is A, bigger parallel side is B. तो इसका जो centroid है G, ये जो distance है, this will be h by 3 2a plus b upon a plus b. ये तो ये distance मिला trapezium का जो centroid है. G नहीं लिखना चाहिए मेरे को, because it is actually C. ट्रिपीजियम कौन बन रहा है? ट्रिपीजियम is actually the pressure prism. फनींद्र, क्योंकि पर मीटर, पर यूनिट लेंथ, पर यूनिट विड्थ बोला है ना क्वेश्चन में, बिकॉज इट इज आस्क्ड पर मीटर विड्थ, पर यूनिट विड्थ, दैट इज व्हाई वी आर टेकिंग विड्थ एज 1. यहां थोड़ा सा कंफ्यूजन हो रहा है अब स्टूडेंट्स को. इफ द विड्थ विल बी गिवन 2 मीटर दिया हो सकता था, विड्थ ऑफ द सरफेस वुड हैव बीन 2 मीटर, then the area of the surface would have been 3 into 2, but the depth of CP is depth of x bar is same, x bar will be same, x bar will remain same, there will not be any change in x bar will be 4.75, right? Shravan is asking, from the free surface to A is a surface area, just indication of height of A. This is actually a solid surface, container wall. This is from free surface to A is the wall of the container. We are not interested in calculating the force on the wall of the container. We are not calculating the force on the wall of the container. We are calculating the force exerted on this surface AB. अगर फोर्स इस पे कैलकुलेट करना होता तो हम इस पे कॉन्सेंट्रेट करते. क्लियर श्रवण? So in case of the formula, theta will be equal to 30 degree. Why theta is 30 degree? Because I have told you theta is the angle with respect to the free surface. Theta will be the angle with respect to the free surface. Right? 60 is with respect to vertical. So the formula will be 4.75 is the value of x bar plus IG. IG will be this. This is IG, area moment of inertia about the centroidal axis, parallel to the free surface. This is IG, or parallel to the base. This will be IG. IG will be equal to 1 into 3 cube by 12. Area is equal to 3 into 1 into x bar is 4.75 into sine theta. Sine 30 is 1 by 2. So it will be 1 by 2 square. That will give you the value of HCP. This formula will give you the value of HCP. It is somewhere around 4.789. It is slightly more. It will be slightly more than x bar. HCP will be greater than x bar. You will get it to be around 4.789. याद है क्या? Which is greater than x bar. For horizontal surface, both are coinciding. Now this is the wonderful question. If you will solve this question in a traditional manner, you might end up committing mistake. But if you will use the pressure prism, then it will be very, very easy to solve. Read the question. A hinged gate of length 5 meter, which is already shown in the figure, inclined at 30 degree with the horizontal, it means theta is 30 degree, and with water mass on its left, the fluid is water, is shown in figure. The minimum mass of the gate per unit width required to keep it closed. So mass of the gate, we need to find out. Hinge means moment must be 0. Hinge means net moment must be 0 for equilibrium. Net moment about equilibrium must be 0. Net moment about hinge must be 0 for the vertical for the rotational equilibrium. Now let us solve this one. बताइए, mg is acting in downward direction. The weight of the gate will be acting in downward direction, and the weight of the gate will act at center of gravity or centroid of the gate. So this will be mg. Isn't it? This is how mg will be acting. And the hydrostatic force will be acting at Cp, which is normal and compressive. This is hydrostatic force, which is acting at Cp, right? Now, we need to equate moment about the hinge. For movement, we need to take the perpendicular distance. Now, what is if we draw the pressure prism for this one? If we draw the pressure prism, pressure at the top is equal to 0 and pressure at the bottom will be equal to like this. If we draw the pressure prism, the pressure prism will be drawn like this. It will be a triangle. The pressure prism will be a triangle. So if we calculate force, then it will be rho of water into G into area of the plane surface 5 into 1. Because again it is given as unit width into x bar. What is the value of x bar? X bar will be this. Do not calculate x bar incorrectly. X bar is always measured from the free surface. What is the value of x bar? 2.5. This is 30 degree. So what is x bar? 2.5 sine 30. Yes or no? X bar will be 2.5 sine 30. That is the force. Rho g a x bar. Sine 30 is 1 by 2. Now, if we want to find out the point of application, so it passes through centroid of the pressure prism. If the height of the pressure prism, which is a triangle, is 5 meters, what is this distance? What will be this distance? What is this distance? Isn't it? What is this distance? Isn't it 2 by 3 into 5? Isn't it 2 into 5 by 3? Yes or no? 10 by 3. Centroid of the pressure prism. 2h by 3. That is 2 by 3 into 5. Now we are ready to apply the moment. So net moment must be 0. Try to understand. Equate moment about the hinge. So mg is giving a clockwise moment and F is giving anti-clockwise moment about the hinge. One is giving clockwise moment, another is giving anti-clockwise moment. So if we write the expression mg into what is the perpendicular distance, do you agree this will be the perpendicular distance? So into, isn't it 2.5 cos 30? That is the clockwise moment given by mg about the hinge, is equal to the force multiplied by what is the perpendicular distance? This is the perpendicular distance only from the hinge, 10 by 3. Can you put the values and can you do the calculation? Can you put the values and do the calculation? M into G into 2.5. What is cos 30? Under root 3 by 2 is equal to what is F? Rho of water, that is 1000 into G into 5 into 2.5 into 1 by 2. The only unknown is M. G is getting cancelled out with this G. 2.5 cancel this 2.5. 2 getting cancelled. So M is equal to 5000 by root 3, isn't it? आ रहा है क्या? कुछ मिस्टेक की मैंने? Rho into G into area into x bar. कुछ मिस्टेक की है क्या मैंने? Rho G area into x bar. क्या आंसर आ रहा है? क्या मिस्टेक करी है मैंने? एचसीपी की जरूरत कहां है? अच्छा 10 by 3 लिखा नहीं ना, सॉरी. I forgot to write this into 10 by 3, isn't it? Forgot to mention 10 by 3. तो क्या होगा? 50,000 by root 3. It will be 50,000 by root 3 kg. 50,000 by root 3. What is the answer? हाँ. So that is how you will get your answer to be. आ रहा है क्या? Please tell me. Are you getting option D or not? Are you guys getting option D or not? अच्छा 3 रूट 3 है क्या? सॉरी. 3 रूट 3 अब आ रहा है. Did you understand the concept or not? Have you understood the concept? Now let us proceed further. Now for the curved surface. Whenever we are supposed to take the moment or whenever there is a hinge, for the equilibrium, moment should be equated. Hinge के लिए moment equate करना होगा. Perpendicular distance होता है ना देविका? Look, moment क्या होता है? What is the moment? What is the moment? Whenever there is a force acting like this, if we want to take the moment about O, if there is a force, if we want to take the moment about O, what we need to do is draw a perpendicular. If we want to take the moment, then what we are supposed to do? Draw a perpendicular like this. And this is, let us say, R. So moment about O is equal to F into R. Yes or no? Perpendicular distance. Right? So अब अगर हम perpendicular distance देखें, if we see the perpendicular distance, the force is acting like this. Here the force is acting like this. This is the force. And which is perpendicular to the surface. This is perpendicular to the surface, normal and compressive. This is how the force. So perpendicular distance is this only, isn't it? Perpendicular distance will be this only. This is the line of action of force. And we are supposed to take the moment about O. Then the perpendicular distance is 2h by 3 only. 10 by 3. Isn't it? Devika, I am talking to you. And if we take the moment of mg, the line of action of mg is this vertical line. If we want to take the moment, then this will be the perpendicular distance for mg. That is 2.5 cos 30. For mg, it will be 2.5 cos 30. For f, it will be this distance, 10 by 3. Isn't it? So that is the beauty of pressure prism. If you will solve without using the pressure prism, 80-90% of the students might commit mistake. Right? 2.5 ही तो होगा ये. The total length, it is a rectangle. The length of the rectangle is 5 meters. The centroid will be at the middle. The centroid of the rectangle will be the middle of 5. So this distance will be 2.5. This distance will be 2.5. Isn't it? Aspirant 2.5 भी तो होगा. The width is into the plane. चलिए आगे बढ़ते हैं quickly. We need to go a long way. बहुत सारा कवर करना है. Now for curved surface, नहीं x bar कैलकुलेट करेंगे तो x bar will not be 2.5 aspirant because we are x bar will not be 2.5. अगर सरफेस अगर यही सरफेस अगर वर्टिकल होता, ये 5 होता, अगर मान लीजिए ये 5 मीटर होता, तो x बार 2.5 होता, देन x बार वुड हैव बीन 2.5. बट अगर ये इंक्लाइंड है, इंक्लिनेशन की वजह से HCP इज नॉट 2.5. HCP is x bar is not 2.5 because of inclined surface. X bar is not 2.5. X bar is the depth of centroid measured from the free surface. X bar will not be 2.5. X bar तो मैंने लिखा ना 2.5 sin 30 होगा x bar. यहां चेंजेस आते हैं. This is what you need to understand. Rho g a x bar will be 2.5 sin 30. Clear? और कोई डाउट? एनी डाउट? दिस क्वेश्चन वाज आस्क्ड इन गेट एग्जाम. स्टूडेंट्स को लगता है कि बहुत लेंथी क्वेश्चन है, बट इफ यू आर अप्लाइंग द कॉन्सेप्ट ऑफ प्रेशर प्रिज्म, यू विल बी एबल टू सॉल्व द क्वेश्चन इन ए सिंगल लाइन. In one line you will get the answer. So it is not that tough. Now the curved surface. Now for a curved surface, not only the magnitude of pressure but the direction of force is also changing. Here the force will be acting normal and compressive like this. Here the force will be acting like this. Here the force will be acting like this, like this. The direction of force is also changing. So integration will not help. Other than the magnitude, the direction is also changing. So the integration will not help. What we need to do is we need to resolve this force into two components. One is the horizontal component. Another will be the vertical component. Resolve the force. For a curved surface, we always resolve the force, or we always calculate the horizontal component separately. We always calculate the vertical component separately. So मैं directly आपको concept बताता हूँ कि horizontal component कैसे find out करते हैं. If you are having a curved surface, plane surface और curved surface में फर्क तो पता ही होगा. This is the plane surface and this is the curved surface. If we are having a curved surface like this, and there is a fluid in contact, so to calculate the horizontal component, we take the vertical projection of the curve. What we do is we take the vertical projection of the curve. If you throw light from here, whatever you get on the vertical screen, you take the vertical projection of the curve. And the vertical projection can be treated as a vertical plane surface. एक बार आपने vertical projection ले लिया. If there is a curved surface, there is a slight imagination you require. If there is a curved surface, then what we will do, you will throw light from one side and you will see what you are obtaining on a vertical screen. That is the vertical projection. Once you get the vertical projection, then the vertical projection can be treated as a vertical plane surface and apply all the formula, all the concept which I have discussed for the vertical plane surface to this. That will give you FH. FH will be acting here only. But the line of action of FH will pass through CP for the vertical projection, and the depth of CP for the vertical projection is, let us say, HCP. So apply all the formula. So what we will write for hydrostatic force, for magnitude of hydrostatic force, horizontal component FH, we will say rho of the fluid, whatever is the fluid is, into G, into area of the vertical projection. It is the area of the vertical projection. This is the vertical projection. We will calculate the area of the, we will write the area of the vertical projection multiplied by x bar. X bar is also for vertical projection. All the parameters are for the vertical projection. X bar. This is G for the vertical projection. X bar will be this. Forget about the curve. Find out the centroid of the vertical projection. And x bar is the depth of centroid of the vertical projection from the free surface. And how to find out CP? Again, the same formula. HCP is equal to x bar for the vertical projection plus IG is also for the vertical projection. If a vertical projection is a rectangle, then IG is for the rectangle upon area of the vertical projection into x bar. This will be the depth of, this is the depth of FH from the free surface. If the fluid is on the right hand side, then the direction of FH will be like this. It is always normal and compressive. If the fluid is on the left hand side, it will be the direction of force will be positive x. If the fluid is on the right hand side, again we will take the vertical projection. Vertical projection will be same, but the direction of force will be compressive, right? So this is what is the conclusion for horizontal component. The horizontal component of total hydrostatic force on a curved surface is equal to the hydrostatic force on its vertical projection area. And the line of action of this FH, will pass through center of pressure for the vertical projection. I hope it is clear, right? This is only FH. Similarly, if we talk about FP, if we calculate FP, vertical component, how to calculate the vertical component? Try to understand. Extend all the edges of the curved surface up to free surface. This point will be extended up to free surface. This point will be also extended up to free surface normally, and the width might be something like this. There might be some width. So the volume of the weight of this fluid will be the magnitude of Fp. Extend the edges normally up to free surface. Whatever the fluid, the weight of the fluid the curved surface can contain up to free surface will be the magnitude of Fp. Because the liquid is in contact from the top, the direction will be downward. And if the liquid is in from the bottom, look, if this is the curved surface and the fluid is on the right hand side, like this, then what we'll do? Again, you will do the same thing. Extend, this is the free surface, this is like the free surface. What you will do? Extend the edges normally up to free surface. This is also extended normally up to free surface. The width is into the plane, like this. So this weight of this fluid will be the magnitude of Fp, whether the liquid on the left hand side or on the right hand side. But the only thing is the vertical force will be upward in this case. Only direction will be different in both the cases, but the magnitude will be calculated by the similar manner. Even though there is no fluid here, but we are imagining how much fluid it can contain up to the free surface. So if the volume of this is V, if the volume is, let us say, V, then Fp will be equal to rho of the fluid into V, that is mass of the fluid contained into G, rho Vg. This is the magnitude of, this will be the magnitude of Fp. So if you read the statement for vertical component of total hydrostatic force, then you will find the vertical component is equal to the weight of the fluid which can be contained by the curved surface up to free surface, can be contained. Whether the fluid is contained by the curve or not, whether the fluid is in contact from the bottom or from the top, we do not bother about that. We do not bother about that. What we bother about is the weight of the fluid which can be contained by the curve up to free surface will be the magnitude of Fp. The direction will be decided by actual contact. The direction will be decided by actual contact. I hope this is clear. Is this all clear? Once we get FH and Fp, and the line of action of this Fp will pass through the centroid of the corresponding weight. The line of action will pass through the centroid of the corresponding weight. Centroid is, let us say, this is the centroid of this weight. So the line of action of Fp will pass through this point. This is C, centroid of the weight. If the centroid of this weight is, let us say, here, the line of action of Fp will pass through this line. Right? So very simple. FH and Fp will be calculated separately. And once we calculate FH and Fp, then we can find out the total hydrostatic. FH and Fp are perpendicular to each other. That is why the resultant will be like this. And what is phi? Phi is equal to tan inverse of perpendicular upon base. What is phi? Phi is the angle of FR with horizontal. Phi will be the angle of FR with the horizontal. So that completes our hydrostatic forces. Now we will be discussing about the buoyancy and flotation, and then we will take the lunch break. After buoyancy and flotation, we will take the lunch break, and then after that we will continue our discussion from kinematics and then dynamics. Clear? एक क्वेश्चन है? Yes. First we will solve this question. Please give it a try. इस क्वेश्चन को सॉल्व करिए everyone. What is the FH? Find out FH. First find out FH. For FH, take the vertical projection. For calculating FH, take the vertical projection of the curve. The vertical projection. What is the vertical projection? The vertical projection will be what? तीन बज गए यार. If we will take the vertical projection, imagine if we will take the vertical projection of this curve up to the free surface, we will get a rectangle of dimension 10 meter by 1 meter. Yes or no? The vertical projection will be a rectangle of dimension 10 by 1. So what is FH? FH will be equal to rho of water. The fluid is water. 1000 into 9.81 into what is the area? 10 into 1 into x bar, that is 5. The location of centroid from the free surface, x bar. That is the FH. हरीश सिंधु, हाइड्रोलिक मशीन में अलग से लूंगा. हाइड्रोलिक मशीन आई विल डिस्कस सेपरेटली, राइट. एक सेशन हम प्लान कर रहे हैं, धीरज सर एंड मी. धीरज सर विल बी टेकिंग वाइब्रेशंस on the same day and I will be taking the hydraulic machines. ठीक है, कैलकुलेट कर लेंगे. Now the problem is to calculate Fe because the curve is not a circle. Y is equal to x square by 9. Fe कैसे कैलकुलेट करेंगे? To calculate Fe, what we will do, extend the edges normally up to free surface. This is already on the free surface. The width is 1. So weight of this fluid, this fluid will be the magnitude of Fp, isn't it? The weight of the fluid which can be contained. This is y is equal to x square by 9. How to calculate the weight of this fluid? By taking, if we at any y, if we take a small element dy, find out the area of this. This is x and this is y. So if you calculate the volume of this and integrate from 0 to 10, then you will get the answer. Yes or no? So Fe will be equal to rho of water into G into this volume. Integration of this is x into dy into 1 and the limit of y is equal to 0 to 10. That will give you the answer. हाँ, इंटीग्रेशन करना पड़ेगा. ये 490.5 आ रहा है ना, किलो न्यूटन, न्यूटन और किलो न्यूटन, 490.5 इंटीग्रेट करना पड़ेगा फ्रॉम y is equal to 0 to y is equal to 10. Then you will get the total volume. और x को लिखा जा सकता है, what is x? X is equal to 3 root y. So 9810, then integration of 3 root y into dy, and the limit will be 0 to 10. That will give you the magnitude of Fp. That will give you Fp. Clear? What is the value of Fp? Once you get Fh and Fp, then you can find out Fr. Under root of Fh square plus Fp square. And phi is equal to 10 inverse of Fp by Fh. What is the meaning of direction? Direction means angle with horizontal. Direction means angle with the horizontal. Solve करिए और बताइए मुझे आंसर. And then we will move to buoyancy and flotation. Another important topic. Clear? 620.4. Yes, that is correct. और रिजल्टेंट फोर्स 790 कुछ आ जाएगा शायद. 620.4 किलो न्यूटन. यस, वेल डन. अभी अनवर, गुड. सौमिक, ग्रेट. कीप इट अप गाइज. जितना ज्यादा खुद से ट्राई करेंगे, प्रैक्टिस करेंगे, द मोर कंफर्टेबल यू विल बिकम. बिलीव मी, बहुत सारे स्टूडेंट्स, व्हेन I start taking the first lecture, so many students are afraid of fluid mechanics. But at the end of the sessions, students feel that the fluid mechanics becomes their favorite subject. 790.9. That is correct. So, if you are really interested, if you are giving your full attention to each and every minute concept, believe me, the fluid mechanics will become one of your favorite subjects in entire engineering. The next is buoyancy and flotation, the last topic of fluid statics. When a body is immersed, now we are talking about the three-dimensional body. Earlier in hydrostatic force, we were talking about a surface, whether it is a curved surface or a plane surface, flat surface. Now when a body is immersed in a static fluid, either completely or partially, the net upward hydrostatic force exerted by the fluid on the immersed body is known as buoyant force. So what is buoyant force? Buoyant force is always act in upward direction, opposite to gravity force, opposite to the weight of the body. So buoyant force is nothing but net upward hydrostatic force. Calculate the upward hydrostatic force in the similar manner discussed earlier. Calculate the downward force, hydrostatic force, and the net is equal to buoyant force. And net will always be upward. That is buoyant force. 38.12 तो नहीं आएगा अनवर. 61 point something आएगा. 61 degree आएगा. Why you are getting 38 degree? It will not be 38 degree. It will be 61 degree something. So buoyant force is the net vertical hydrostatic force or net upward hydrostatic force. And according to Archimedes' principle, the buoyant force is equal to weight of the fluid displaced by the immersed body. And so this is the net upward hydrostatic force, which is the weight of the fluid. So density of the fluid into G into volume of the fluid displaced by the body. This is the magnitude of FB. VFD is the volume of the fluid displaced. It has nothing to do with the density of the body which is immersed. It is not a function of buoyant force. 51.67. हाँ, ये correct लग रहा है अनवर. 51.67, not 61. Buoyant force is equal to rho F, density of the fluid, into acceleration due to gravity, into volume of the fluid displaced by the body. It is not a function of density of the body. Right? And the point of application of this buoyant force is called a centrobuoyancy. Eureka moment. Yes. The point of application of this buoyant force, and it is the centroid. The centrobuoyancy is the centroid of the displaced fluid. The centrobuoyancy will be the centroid of the displaced fluid. Clear? इफ देयर आर मल्टीपल फ्लूइड्स, क्या आप इसके लिए बाइंड फोर्स बता सकते हैं? This is, let us say, V1 volume of the body. This is V2 volume of the body. This is ρ1 fluid. This is ρ2 fluid. What will be the bind force? What will be the bind force acting on the body? If there are multiple fluids, what will be the bind force acting on the body? What will be the bind force acting on the body? Bind force is the weight of the fluid displaced by the body. So ρ1 fluid displaced is this much and ρ2 fluid displaced is this much. So bind force is ρ1 g v1, that is w1, weight of the ρ1 fluid displaced, plus ρ2 g v2, and the direction will be upward. This is how we can write the bind force in case of multiple fluids. ρ1 g v1, g भी लिखना होगा, प्लस आएगा. वामसी, वाई यू आर सेइंग नेगेटिव? आप नेगेटिव क्यों बोल रहे हैं? वाई यू आर राइटिंग नेगेटिव? द टोटल वेट ऑफ द फ्लूइड डिस्प्लेस्ड, ρ1 इतना फ्लूइड डिस्प्लेस हो रहा है, ρ2 इतना फ्लूइड डिस्प्लेस हो रहा है, तो टोटल वेट ऑफ द फ्लूइड डिस्प्लेस्ड इज द बाइंड फोर्स. It will be plus now, isn't it? It will be plus. ना 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 ना, वो अलग चीज है. कुंदन अगर ऐसे करेंगे, ध्यान दीजिए, हाँ यहां कंफ्यूज हो गए. बाइंड फोर्स मैंने बोला था एफ नेट, बाइंड फोर्स मैंने बोला एफ नेट. ध्यान दीजिए एवरीबडी, दिस इज द फ्री सरफेस. अगर डाउनवर्ड फोर्स कैलकुलेट करता हूं, एवरीबडी प्लीज हैव ए लुक, why people are writing negative and why it should not be negative. If I ask you FV1, on the top there will be downward force on the top of the surface. If the top is in on the top there will be downward force. Why? Because the fluid is in contact from the top. So FV1 will be weight of the fluid which can be contained by this. This is FV1. This will be FV1. FV1 is equal to ρ1 into G into, let me call it as Vx. Let me call this volume to be Vx. Yes or no? This is FV1, downward force. And FV2 will be upward. Why? Why FV2 will be upward? Because the fluid is in contact from the surface from the bottom. ध्यान दीजिए. This is the body. This is the body. On the top there will be downward force because the fluid is in contact on the top. So there will, the force will always be normal and compressive. It will be downward on the top. How to calculate the downward, the magnitude of vertical force on the top? Extend the edges normally up to free surface. Extend the edges normally up to free surface. So weight of the fluid which can be contained by this curve up to free surface is Fv1. On the bottom surface, the vertical force will be upward. On the bottom, the vertical force is upward. And how to calculate Fv2? Look. This is the surface. Any surface can be considered as curved, whether it is a flat or not, whether it is a curved or not, even if it is a flat. So weight of the fluid, try to understand Fp2. Try to understand Fp2. Try to understand weight of the fluid which can be contained by this curve up to free surface. This will give you the magnitude of Fp2. This will give you the magnitude of Fp2. So if I ask you Fp2, then Fp2 will be equal to this volume, this weight, that is ρ2gv2 plus this weight plus ρ1gv1 plus this weight, again ρ1 GVX. This is Fp2. If I ask you Fe2 only, then your answer will be this. If I ask you Fe1 only, then your answer will be this. So Fb is equal to Fe2 minus Fe1. If you subtract these two, then this will vanish. This will vanish, and you are left with ρ1 g v1 plus ρ2 g v2. Yes or no? बताइए. कभी नहीं आएगा नेगेटिव. बाइंड फोर्स कभी भी नेगेटिव नहीं होता. नेगेटिव कभी नहीं आएगा. बाइंड फोर्स हमेशा अपवर्ड होगा, एंड द मैग्नीट्यूड विल बी द वेट ऑफ द फ्लूइड डिस्प्लेस्ड बाय द बॉडी. दिस इज द वेट ऑफ द फ्लूइड डिस्प्लेस्ड. ये ρ1 फ्लूइड इतना डिस्प्लेस कर रहा है, ρ2 इतना कर रहा है. दिस इज द वेट ऑफ द फ्लूइड डिस्प्लेस्ड. अगर आप ऐसी गलती करेंगे तो आर्किमिडीज को हार्ट अटैक आ जाएगा. मैंने डायरेक्टली लिख दिया ऐसा. अगर आप Fe1 Fe2 लिख के सब्ट्रैक्ट करके लिखेंगे तो यू विल गेट द सेम रिजल्ट. नो क्लियर? I hope this is clear. Now, if a body is immersed in a fluid, whenever a body is immersed in a fluid, there are two forces acting on the body. One is the downward weight, and another is the upward force, that is the buoyant force. And if we want the vertical equilibrium of the body, condition for equilibrium of the body, for vertical equilibrium, net vertical force must be 0. For vertical equilibrium, net vertical force must be 0. So we can say it means buoyant force must be equal to weight of the body. And what is the buoyant force? We can say rho f into g into vfd will be equal to rho b into g into vb. So from here we can get the relation g and g getting cancelled out. So volume of the displaced fluid is equal to rho b into vb upon rho f. This is the volume of the displaced fluid. There are 4 parameters, any 3 can be given to you, 4th can be asked, but this is the condition when the body is in vertical equilibrium. Otherwise, if the body is not in vertical equilibrium, then buoyant force might be more than weight might be more than buoyant force, isn't it? But for vertical equilibrium, rho b is the average density of the body. Rho b is the average density of the immersed body. Vb is the total volume of the body. Total volume of immersed body. And VFD is the volume of the displaced fluid. Fluid displaced by the body. And rho f is the density of the fluid. That is how we get the condition for vertical equilibrium. And based on the magnitude of FB and W, one is acting in downward direction, another is acting in upward direction. So when the density, what we obtain is VFD is equal to rho B into VB upon rho F for vertical equilibrium. This is the condition for vertical equilibrium. If the density of the body is less than density of the fluid, if the density of the body is less than density of the fluid, then we can say VFD will be less than VB, isn't it? So the body will be floating, partially submerged. If density of the body is equal to density of the fluid, then we can say VFD is equal to VB. Yes or no? The body is known as suspended body, completely submerged. Or we can call it as neutrally buoyant. If the density of the body is greater than density of the fluid, then in that case, the weight of the body is greater than buoyant force. No equilibrium will be achieved. The body will sink. In the third case, if the density of the body, average density of the body is greater than density of the fluid, then the body will sink to the bottom of the surface. So the body can be partially submerged, the body can be completely submerged depending on the relative magnitude of density of the body and density of the fluid. Clear? Is this clear? Now, after this vertical equilibrium, we can talk about the rotational equilibrium. The second is condition for rotational equilibrium. Net moment must be zero. वाह अनवर, ये क्या है? प्लास्टिक बॉल, वाटरमेलन, एग. अच्छा, इन तीनों में से आप बता रहे हो. अच्छा, ऑलराइट, करेक्ट. हाँ, द फर्स्ट स्पेयर वाज प्लास्टिक बॉल, द सेकेंड इज वाटरमेलन, द थर्ड इज एग. For rotational equilibrium, now try to understand. There are two forces acting on the body. One is weight is acting in downward direction at G. Another is the buoyant force is acting in upward direction at B. These are the two forces, and for vertical equilibrium they are equal. FB is equal to W for vertical equilibrium. But if the line of action of these forces are not equal, if the line of action of these forces are not same, then this will develop a couple. Then there will be a rotation, isn't it? The body will rotate. Even though the body will not move in vertical direction, but there is a rotation in the body. Couple will be developed, equal and opposite forces separated by a distance. So for rotational equilibrium, do you agree B and G must lie in same vertical line, isn't it? Or we can say line of action of buoyant force and weight must be same. These are the two conditions for equilibrium. For rotational equilibrium, the line of action of buoyant force, the line of action of weight and the buoyant force must be same. For B and G, this is let us say G, this is let us say B, the B and G should lie in the same vertical plane for rotational equilibrium. So the body which is immersed in the fluid is said to be in complete equilibrium when it is in vertical equilibrium. Along with that, it is in rotational equilibrium. So both the conditions must be simultaneously satisfied. Sigma F is equal to 0 and sigma M is equal to 0. When both these conditions are simultaneously satisfied, then the body will be in complete equilibrium. And once the body is in complete equilibrium, equilibrium means sigma Fp is equal to 0, sigma M is equal to 0. Then we can classify the equilibrium into three types. It is called, it can be stable equilibrium, it can be unstable, it can be neutral. The equilibrium can be of three types: stable, unstable, or neutral. And how to find out? By disturbing the body slightly. When a body in equilibrium is slightly disturbed, if the force or a couple is developed which brings the body back to its original equilibrium position, such force or a couple is called as restoring force or restoring couple. If a restoring force or a couple is developed, then the body will be in stable equilibrium. This is an example of stable equilibrium. A sphere kept on a concave surface. If you disturb the sphere, it will come back. This is stable equilibrium. Unstable, when a body in equilibrium is slightly disturbed, if a force or a couple is developed which moves the body away, from its original equilibrium position, that type of force or couple is called as overturning force or overturning couple. This is also in equilibrium on a convex surface, sphere kept on a convex surface. If you slightly disturb it, it will go further away. This is unstable. And what is neutral equilibrium? When a body in equilibrium is slightly disturbed, if the body attains a new equilibrium position, neither force will be developed nor couple will be developed. So on a flat surface, a sphere kept on a flat surface is in neutral equilibrium. If you disturb this body, it will attain a new equilibrium at a new position. So these are the three types of equilibrium for a body which is already in equilibrium. Is this clear? बताइए, if anybody is having any doubts up to this point, can we proceed further? Now let us apply this concept for the fluid mechanics or the body which is immersed in the fluid. Let us apply this concept for a body which is immersed in a fluid. If the body is completely submerged, so FB must be equal to W, and B and G must lie in the same vertical line. B and G. But if B is lying above G, then the body will be in stable equilibrium. For a completely submerged body, if the center of buoyancy is lying above center of gravity, then the body will be in stable equilibrium. देखिए कैसे? The body rotates due to disturbance. The body oscillate about B. This is B. Let us say this is the center of buoyancy. The body oscillate about B. So if you disturb it clockwise, and if the G is lying below, at G weight is acting, weight will bring the body back. So it is stable. If B and G coincide with each other, then if you disturb the body slightly, no moment will be developed, because the line of action of weight is already passing through B only. So there is no moment about B, so the body will not rotate about B. That is called as neutrally stable or neutral equilibrium. But if G is lying above B, if the center of buoyancy is lying below, center of buoyancy is, let us say, here. If G is above, if you disturb the body clockwise, at G weight is acting, weight will overturn the body. So that type of equilibrium is called as unstable. So for a completely submerged body, what you need to memorize? BAG. For stable equilibrium, center of buoyancy must lie above center of gravity. B is center of buoyancy. This is above. G is center of gravity. Center of buoyancy must lie above center of gravity, then stable. Center of buoyancy coinciding with G, then it is neutral. Center of buoyancy lying below, then it is unstable. BAG, that is the shortcut. There are theoretical questions which are asked, which had been asked previously so many times from this condition. What is the correct condition for unstable equilibrium? What is the correct condition for neutrally stable? What is the correct condition for the stable equilibrium? Right? So you must memorize BAG. Similarly, for a floating body, there is a point defined called as meta center. Now, for a floating body, the body oscillates about meta center. It is not oscillating about B, because the location of B changes. Now, if B lying below G, then it is vertical. Buoyant force is equal to weight, and B and G are lying in the same vertical line. Same vertical line. So this is in equilibrium. If we disturb the body, if the meta center is lying above G, then at G weight will be acting and it will bring the body back, isn't it? At G weight will be acting, which will bring the body back. B dash is the new position of center of buoyancy. This is the free surface. This is about the partially submerged. This is the new free surface. If meta center is lying above G, then it will be restoring moment, it will be stable. Yes or no? If you disturb it clockwise, then the moment will be anti-clockwise, bring the body back. If the meta center is lying below G, then at G weight is acting, so weight will rotate the body clockwise only. That is why it is overturning moment and it is unstable. And if M and G coincide, this is B dash, new position of center of buoyancy. If M and G coincide, the line of action of weight is passing through M only, so there is no moment. So it is neutral equilibrium. So what you need to remember for a floating body, MAG. So the relative position of B and G is not sufficient. The relative position of B and G is insufficient to decide whether the body will be in stable, unstable, or neutral equilibrium. The location of meta center is the one which decides the stability of a body. A means above. If the meta center is lying above center of gravity, then the body will be stable. If the meta center is lying below, G, then the body will be in unstable. If the meta center and G coincide, then it is neutral equilibrium. Bag and mag. Yes, that is true. Faninder. Clear? Is this clear? You have to memorize. But you need to check whether the question is about a floating body or a submerged body. If it is about a submerged body, we do not talk about meta center. If it is about a submerged body, we only talk about relative position of B and G. But if it is about floating body, then meta center is defined. And how to define the meta center? The body oscillates about the meta center. This is meta center. This point is meta center. Ship is an example of a floating body. The body always oscillates about the meta center. हाँ श्रेया अभी बताता हूं मैं how to utilize this concept. What is meta center? Meta center is the point of intersection of new line of action of bind force with the neutral axis of the body. Look how we define the meta center. This is the new line of action of bind force, and this line is neutral axis. This is neutral axis. The point of intersection of new line of action of bind force with the neutral axis. This is the neutral axis. And this is the new line of action of bind force, B dash. The point of intersection of new line of action of bind force with the neutral axis. Or it is the point of intersection of action of bind force before and after rotation. Before rotation is neutral axis only. After rotation is B dash. Or it is defined as the point about which a floating body is supposed to be oscillating. The floating body always oscillates about meta center. No, meta center is above G, then is stable. Huh? If the meta center is lying above G, then the body will be in stable equilibrium. MAG. Meta center must lie above center of gravity, then is stable. Stable. ये stable है ना? Meta center is lying above G. It is stable. It is unstable. It is neutral. Clear? And the time period of oscillation is given by 2 pi under root of Rg square upon G into Gm. This is how we can define the time period of oscillation of the floating body, where Rg is radius of gyration, which will be provided to you. It will be the radius of gyration of the body. And Gm is known as metacentric height. Gm is called as metacentric height. The distance between G and M. How the body will be stable? Here there will be B, there will be G, and there will be M. If this is the situation, then the body will be stable. कौन सा previous slide चाहिए आपको? ये? Do you want this one? हो गया? Is this the slide you wanted? कौन? इससे भी पहले वाली? Previous to that you want? ये वाली? The meta center can be outside the body also. The meta center can be inside the body also. The location of matter center can be outside, the location of matter center can be inside. Shall we proceed further? किसी को कोई doubt हो? If anybody is having anything to ask, you are most welcome. Buoyancy and flotation is about to over. In the next 10 minutes, we will stop for lunch break, and then after the break, we will start kinematics and then dynamics. So please do not forget to like and share. I want more and more students to be part of this session so that everyone gets benefited. So what is metacentric height? The distance between G and M. This is the metacentric height. This is called as GM. And how to calculate GM? It is subtraction of BM and BG. It is the subtraction of BM and BG. Ronaldo, around 4 hours, 4 more hours, around 4 hours. So what is BM? BM is calculated by Ixx upon volume of the fluid displaced. And what is Ixx? Ixx is the area moment of inertia of horizontal section of the floating surface on the fluid about its longitudinal axis. It is the horizontal section of the floating surface. Whatever the surface is floating, we take the horizontal section of the floating surface on the fluid. अभी बताऊंगा वामसी. I will tell you. We will discuss. Vamsi, don't worry. Through one question. And metacenter is always a fixed point for small rolling angle. We are talking about small disturbance. All the concepts are valid only for small disturbance. So metacenter will be a fixed point. Yes, this is the question. We will solve this question and then we will stop. Look, how to make use of BM, BG. देखो जैसे Shreya, if it is a cylinder, if the body is having a cylindrical shape, then if it is partially immersed cylinder, then the horizontal section of the floating surface on the fluid will be a circle. So the moment of inertia of the circle about the longitudinal axis. If it is a cuboid, then the horizontal section will be a rectangle. If it is irregular geometry, then Ixx will be provided to you. It will either be the cylinder or cuboid. Other shapes will not be asked. So if a cylinder of 4 meter diameter and height of 3 meter is placed in water with its axis vertical, then it will float in. Density of cylinder is 600. Like this. So first of all, what you need to do, this is the neutral axis. This is the neutral axis. First of all, we will find out the depth of immersion, because stability, instability comes into picture when the body is in equilibrium first. So to find out H, depth of immersion, we can say buoyant force is equal to weight, density of the fluid into G into volume of the fluid displaced is equal to density of the body into G into volume of the body. G and G getting cancelled out. What is the density of the fluid? It is water. So it will be 1000 into what is the volume of the fluid displaced. Let me call it as A. A is the area and capital H is the height. So can we call it as A into small h? Depth, the volume of the fluid displaced is this much only. This is the volume of the displaced fluid. Is equal to what is the density of the body? 600 into A into capital H. Yes or no? A into capital H. So area getting cancelled out. So small h is equal to 0.6 into capital H. What is capital H? 3. 1.8 meter. So this is called as depth of immersion. This is depth of immersion. right? Small h is 1.8 meter. Are you getting it? Now, how to locate B and G? How to locate B and G? Now, how to locate B and G? Try to understand. The total height of the body is 3 meter. Do you agree the location of G will be from the bottom? It will be 1.5, capital H by 2. That is 1.5 meter. Yes or no? If the body is symmetrical, if the body is having mass distribution symmetrical, then the location of G is capital H by 2. And the location of B from the bottom, isn't it small h by 2? That is 0.9. Yes or no? So we can easily calculate BG. What is the distance BG? This distance. So BG will be equal to capital H by 2 minus small h by 2. That is 1.5 minus 0.9. That is 0.6 meter. That is the distance BG. Now BM. Then BM. BM is Ixx upon volume of the fluid displaced. This is Ixx. Volume of fluid displaced. What is Ixx? It will be pi by 64 d to the power 4. What is the volume of the fluid displaced? Pi by 4 d square into h. Put the value. Diameter is 3 meter. Diameter is 4 meter. So can you solve it? Pi getting cancelled out. If you solve this, what is the value of BM? What is the value of BM? Are you getting 0.55 meter or not? Are you getting 0.55 meter or not? So if the value of GM, that is BM minus BG, if that will be positive, if it is greater than 0, then it will be stable. If metacentric height is positive, then it will be stable. Or we can say if BM is greater than BG, then it will be stable. If equal to 0, then it is neutral. Or we can say if the value of BM is coming out to be equal to BG, then it is neutral. And if it is less than 0, then it is unstable. Can you tell me whether the equilibrium is stable, unstable, or neutral? Which equilibrium it will attain? Which equilibrium it will attain? If the metacentric height is positive, then it's stable equilibrium. If the metacentric height is negative, unstable equilibrium. If the metacentric height is 0, it means G and M will coincide. If BG is equal to BM, BM is equal to BG. क्या होगा इसका आंसर? Tell me, will it be stable, unstable, or neutral? Will it be stable, unstable, or neutral? It will be negative. So the surface will be in unstable equilibrium. Yes or no? It will be unstable. So that is how the questions can be solved based on this concept. I hope this is clear to everyone. I hope this is clear to all of you. Any doubt? If anybody is having any doubt, please do let me know. Otherwise, we will solve one more question. इसका आंसर मुझे बता दीजिए. Tell me the answer to this one. What will be the answer to this question? Good afternoon, Sumit. इतना लेट कैसे हुए? What is the answer? the force required is equal to downward force by the fluid. The force required will be equal to downward force by the fluid. And how much is the downward force? That is pressure into area. What is the pressure at the bottom? That is equal to rho into G into H. What is the area? This area, that is A. Isn't it? Rho G H A. जिन लोगों को B लगता है, they are committing the mistake. If you draw the free body diagram of this piston, then the downward force is equal to upward force. And what is the downward force on the piston? That is pressure into area, pressure of the fluid. This is the free surface. Pressure at the bottom is rho G H, capital H, into area of the piston, that is capital A. Yes or no? ऐसे क्वेश्चंस आते हैं. बी विल बी द करेक्ट आंसर. और या आप कैलकुलेट कर सकते हैं. हाउ टू कैलकुलेट एफ ई? द वेट ऑफ द फ्लूइड विच कैन बी कंटेन्ड बाय द कर्व अप टू फ्री सरफेस. दिस इज द मैग्नीट्यूड ऑफ एफ ई. दिस विल डिसाइड द मैग्नीट्यूड ऑफ एफ ई. द वेट ऑफ द फ्लूइड विच कैन बी कंटेन्ड बाय द कर्व अप टू फ्री सरफेस. बहुत सारे लोगों ने ऑप्शन ए को सेलेक्ट किया है. ए इज नॉट करेक्ट. बी विल बी द करेक्ट आंसर. If the question is about weight of the fluid, then your answer will be A. But if the question is, this is the piston, let us say, this is the piston, upward force is F, downward force is by the fluid. So we need to calculate what is the force exerted by the fluid on the surface. That will give you the magnitude of F. So extend the edges normally up to free surface. Extend this as normally up to free surface. Extend this as normally up to free surface. Extend this as. All the surfaces must be extended normally up to free surface. So this, the weight of the fluid which can be contained by the curve up to free surface will give you the magnitude of Fv. So the answer will be option B. Yes? तो चलिए, now let us take a break. कितना टाइम का ब्रेक चाहिए? हाफ एन आवर. Shall we take a break for half an hour? And then we will start our discussion for fluid kinematics. We will meet again at 4 p.m. 4 p.m. हो जाएगा क्या? और 4:15 कर देते हैं. We will meet again at 4:15 p.m. and we will complete our discussion. हाँ, कुछ confusion है श्रवण? Sorry. Is there any confusion? If we draw free body diagram of the piston, this is the piston. The area of the piston is A. We need to find out F for equilibrium. So F is equal to vertical downward force. So weight of the fluid which can be contained by the curve up to free surface is the magnitude of vertical force. या फिर pressure into area. ये जो है, ये है weight of the liquid contained by the container. This is the weight of liquid. अगर weight of the liquid पूछा जाता तो आप बोलते this weight plus this weight. This is the total weight of the liquid. But the total weight of the liquid can be less than the vertical hydrostatic force. It can be more than vertical hydrostatic force. It can be less, it can be more. ठीक है? सी और डी में तो कोई कंफ्यूजन नहीं है. जो कंफ्यूजन है वो ए और बी में है. नहीं कहाँ? यहाँ कहाँ है? कैंटीन में रखा. अच्छा, वहीं खा लेंगे. वहीं आ रहा हूँ. ठीक है, तो चलिए, लेट अस टेक ए ब्रेक नाउ and we will meet again at 4:15. Okay, so have your lunch and come back with more energy, more power, because now we are slowly entering into the more complicated discussion, that is kinematics and dynamics. See you at 4:15. Till then, enjoy, take care, have some rest and get yourself charged up. Thank you guys. Thank you. See you at 4:15. So guys, welcome back. How are you all? Have you had your lunch? Shall we start the kinematics of the fluid flow? Please do join me fast and let me know if my audio and visual quality are fine. All right. Hi Dreams, Kunal, Shomik, Vinay. Welcome once again for the next part. We will start with the kinematics of the fluid flow. What is kinematics? The kinematics is analysis of the flowing fluid without considering the forces causing the motion. Clear? Audio, video clear? All right. So in this part, we will discuss the kinematic quantities, the quantities which are related with the motion. Kinematics is all about analysis of velocity of the fluid, acceleration, deformation, angular deformation, rotational components, etc. तो चलिए स्टार्ट करते हैं काइनेमेटिक्स ऑफ द फ्लूइड फ्लो. The fluid kinematics. So in the kinematics, we will start with the types of flow, the various types of fluid flow. Start करें. Those who have joined me recently, those who have joined me for the first time, a very, very warm welcome to you all once again for this wonderful marathon session for fluid mechanics. Fluid properties and fluid statics is all over. I hope everything is clear to everybody, whatever we have discussed so far. Now we will be moving to the kinematics, the various types of flow. These are the various types of the flow. The flow can be classified as steady and unsteady flow. क्या होता है? What is steady? What is unsteady flow? When do we call the flow to be steady? The flow is said to be steady when the fluid behavior does not change with time at any section. If temperature is not a variable, then it is steady flow. Right? Hi Hari, welcome. Yes, when the flow behavior, क्या होता है flow behavior? The flow is said to be steady flow when pressure, density, velocity, they are independent of time. Then the flow is said to be steady, otherwise it is unsteady flow. इनमें से एक भी पैरामीटर अगर टाइम के साथ चेंज हो रहा होगा, there are two coordinates जिसमें हम flow behavior को analyze करेंगे. One is the space coordinate, space, and t represents the time. So the behavior of the fluid might change with space, the behavior of the fluid might change with time. So steady flow is the flow when the fluid behavior does not change with time. Otherwise it is unsteady flow. The next classification is uniform and non-uniform flow. The flow is said to be uniform when the velocity is not a function of space. When the velocity of the flow does not change with space. Space means in the flow direction, if the velocity remains constant, then the flow is said to be uniform flow. If the velocity changes with space, then it becomes non-uniform flow. Then the classification of real flow. The real flow can be laminar or turbulent. The flow is said to be laminar if the real flow means viscous force is not zero. The tangential force is not zero. In ideal flow, viscous force are taken as zero. But in real flow, the viscous forces are taken as non-zero. The flow will be laminar when the viscous force dominates. When the viscous force dominates, then the fluid particles move in layers with one particle sliding over the other. There is the motion of the fluid particles are in layers. Organized flow, that is called as laminar, and the flow becomes turbulent when the viscous force is less dominating. When the viscous force is dominating, then Reynolds number is low. The value of Reynolds number is less for the laminar flow, and the value of Reynolds number is high when the flow becomes turbulent. All right. Then compressible and incompressible flow. दो अलग अलग चीजें, compressible and incompressible fluid and compressible and incompressible flow. The flow is said to be compressible when the density of the fluid is either be a function of space or time. During the flow, if the density changes with space or time, then the flow is compressible. Incompressible flow is when the density is neither be a function of space nor time. If the density throughout the flow remains constant, then it is incompressible. Clear? Then rotational and irrotational flow. The flow is rotational when the fluid particles rotate about their mass centers during the flow. And when the fluid particles do not rotate about their mass centers, then the flow becomes irrotational. When the rotational flow is real flow, because the rotation is due to the rotation in the fluid particles is because of the torque, and the torque is developed when there is a tangential force or shear force or viscous force. So rotational is real. It means laminar and turbulent both are rotational flow. Laminar and turbulent, and irrotational is ideal flow. When viscous force is zero. There is no viscous force, there is no torque. Yes, about their mass centers. Then the flow can be classified as one-dimensional, two-dimensional, and three-dimensional flow. When only one space coordinate is required to describe the flow, it is 1D. When two space coordinates are required to describe the flow, it is two-dimensional. And when there are three space coordinates required for the flow. Three-dimensional flow means velocity is a function of x, y as well as z. When the velocity becomes a function of x, y, z, all the three coordinates, space coordinates are required to describe the flow, it becomes three-dimensional. So in our analysis of the fluid flow, we will only focusing on two-dimensional, steady and incompressible flow. In fluid mechanics, देखिए अगेन फ्लो की बात करें या फ्लूइड की बात करें, देयर इज अ डिफरेंस. व्हेन द फ्लूइड इज आइडियल, एमवीएस, आइडियल फ्लूइड मींस विस्कोसिटी इज जीरो. आइडियल फ्लूइड की डेफिनेशन आई हैव ऑलरेडी टोल्ड यू अर्लियर. नाउ वी आर टॉकिंग अबाउट द फ्लो. द फ्लो इज नॉन विस्कस व्हेन द विस्कस फोर्स इज जीरो. अब वो विस्कस फोर्स किसी भी वजह से हो सकता है. विस्कस फोर्स का एक्सप्रेशन क्या होता है? Viscous force is mu into du by dy into area, isn't it? This is the shear force or the tangential force. FM हार्ड है वैभव. अभी आप क्लास को कंटिन्यूसली अटेंड करिए, आपको फ्लूइड मैकेनिक्स बहुत सिंपल लगेगा. तो विस्कस फोर्स किसी भी वजह से जीरो हो सकता है. विस्कोसिटी जीरो होने की वजह से भी हो सकता है, या du by dy के जीरो होने की वजह से भी हो सकता है. तो अगर हम बात करते हैं नॉन विस्कस फ्लो, इफ यू आर टॉकिंग अबाउट नॉन विस्कस फ्लो, इट मींस द विस्कस फोर्सेस विल बी जीरो और शियर स्ट्रेस विल बी जीरो. बट इफ वी से नॉन विस्कस फ्लूइड, इट मींस विस्कोसिटी मस्ट बी जीरो. राइट, दैट इज द डिफरेंस. जैसे इनकंप्रेसिबल और कंप्रेसिबल फ्लो एंड फ्लूइड में मैंने बताया, the flow behavior decide whether the flow is ideal or real. Similarly, the flow behavior decide whether the flow is incompressible or incompressible. When we talk about the fluid, then the fluid property decides. So जरूरी नहीं है कि viscosity non zero हो तो flow non viscous ही होगा. Viscosity non zero है, उसके बावजूद भी flow non viscous हो सकता है when du by dy is taken as zero, isn't it? So these are the various types of fluid flow. कोई कंफ्यूजन हो तो बताइएगा. So whenever we call the flow to be ideal, the flow is said to be ideal flow when viscous force is equal to 0 or shear stress developed is equal to 0. Or we can call it as non-viscous or inviscid flow. One condition. Inviscid. Or we can call it as irrotational. Or we can call it as frictionless flow. When there is no relative motion between the particles. When there is no relative motion between the adjacent fluid particles. Yes, PR. I will provide you the PDF of this session to my Telegram channel. If you are not part of my Telegram channel, please do join my Telegram channel, Mechanical by Chandrasekhar. I will provide the PDF along with annotation. Don't worry about that. Please focus on understanding the concept. I will provide the PDF of this session also. I will provide the entire fluid mechanics notes also, my handwritten notes. Yes, PR. So I will provide the PDF. Don't worry. And the second condition for the flow to be ideal is incompressible. Incompressible flow. It means density is neither be a function of space nor time. If density throughout the flow remains constant. The third condition which makes the flow to be ideal is steady. The flow which is steady, incompressible and irrotational is known as ideal flow. So what is steady flow? When density, velocity and pressure, they are independent of time. They will remain constant with respect to time. All right. So this is ideal flow. This is the definition of being the flow to be ideal. तो सबसे पहले हम बात करते हैं viscous flow or laminar flow is also called as laminar flow is also known as viscous flow. Why it is called as viscous flow? Because viscous force dominates. Or we can also call it as streamlined flow. Laminar flow is called as streamlined flow. And what is the streamlined flow? When the fluid particles are actually moving along the streamlines, that flow is called as streamlined flow. So laminar flow is having two more names. Either we call it as viscous flow or streamlined flow. Streamline kya hoti hai? Let us try to understand. Now let us try to understand the definition of a streamline. Look, streamline is an imaginary line or a curve. It is an imaginary line or a curve drawn through the flowing fluid in space such that a tangent drawn to it at any point gives the velocity of the flow at that particular point at any given instant. So that the conclusion here is the streamline is always tangent to the velocity vector. अनवर किसका लिंक नहीं है? मेरे टेलीग्राम चैनल का. You can search me by Mechanical by Chandrasekhar on the Telegram. So the line which is tangent to the velocity vector at every point in the flow, this is called as streamline. इस लाइन को streamline कब बोलेंगे? When we draw a tangent at any point, this is the tangent. When we draw a tangent, it must represent the velocity vector. And the normal to the tangent, the velocity in normal direction will be 0. At any point, if we draw a tangent at this point, it must represent the velocity vector or the tangential velocity. We can also call it as tangential velocity. So the streamline is a line or a curve at every point of which the velocity is tangent. Or we can say velocity vector and velocity vector and streamline are always tangent to each other. There is no flow, there is no velocity component of velocity in normal direction. So that is why there is no flow across the streamline. The flow is always along a streamline. The fluid always flow along the streamline. Streamline is defined for the entire flow. Velocity constant नहीं होगा अनवर. Velocity can change in magnitude, velocity can change in direction. But at every point, यहाँ पे velocity का direction कुछ अलग है, यहाँ पे velocity का direction कुछ अलग है. यहाँ पे अगर tangent draw करेंगे तो velocity का direction अलग है. So velocity may change in the direction, it may change in the magnitude. But at any point, the tangent will represent the velocity vector. At each and every point, velocity vector and the streamline are tangent to each other. That is the condition, right? And how to define the velocity vector? Ui cap plus Vj cap plus Wk cap. This is the representation of velocity vector. The magnitude of velocity is equal to under root of u square plus v square plus w square. U is the velocity component in x direction. What is u? U is equal to distance traveled in x direction per unit time. V is the velocity component in y direction, distance traveled in y direction per unit time. And W is the velocity vector in z direction, which is distance traveled in z direction per unit time. This is how we define the velocity. Now let us talk about the differential equation of the streamline. जैसा कि मैंने बताया, u is equal to dx by dt, v is equal to dy by dt, and w is equal to dz by dt. If we equate dt, then dt will come out to be, what is dt? Can we call it as dx by u, or can we call it as dy by v, or we can call it as dz by w? This equation is called as differential equation of the streamline. This is known as differential equation of the streamline in Cartesian coordinate system. This is the differential equation of the streamline, right? If we integrate this, then we get a relation between x, y, and z, isn't it? That will be constant. That is called as equation of the streamline. Three-dimensional equation of the streamline. This is the three-dimensional equation of the streamline. Integration of this differential equation will give you the equation of the streamline. For two-dimensional flow, dx by u is equal to dy by v. That will be the equation. Or we can call it as, or we can write it as v dx minus u dy is equal to 0. Or we can write it as dy by dx is equal to v by u. That can also be called as slope of a streamline, because a relation between x and y is the different equation of the streamline. This is the slope of a streamline. Differential equation of the streamline or the slope of the streamline. dy by dx is equal to v by u, right? Clear? For two-dimensional flow, a relation between x and y. This is the equation of the streamline for 2D flow. And that is the reason dy by dx is called as the slope of the streamline or differential equation of the streamline. जैसा कि मैंने बताया अभी, the streamline is defined for the entire flow. The streamline is defined for the entire flow. Thank you, Alak. Thank you very much for your motivational words. I also require the motivation, and I get the motivation from your dedication, from your enthusiasm and your energy. So keep your energy high And do not forget to like and share so that the session reaches to all of your friends who are preparing for GATE 2024. We want all the students who are connected directly or indirectly to BYJU'S exam prep must get selected in your... Hi Deepak, welcome. Thank you. So the family of curves satisfying the above equation represents the streamlines of the flow. The curves which satisfy this equation are called as streamlines of the flow. And the streamlines are always parallel to each other. These are the streamlines for a flow. They are parallel because the streamline cannot intersect each other, because at the intersection point there will be two tangents. At the intersection point there will be two tangents, and the tangent to the streamline represents the velocity vector. There is no possibility to have two velocity at a particular point. Acha Deepak, I will check and definitely revert you. Now there is a question. Try to solve this one. Everyone, please give it a try and do let me know the answer. This is how the questions are going to be asked. Thank you, Fanidhar from Telangana. This is the question. Can you simplify this? A flow is represented by this velocity profile. Then we need to find out the equation of the streamline passing through point 1, 2. So if we equate this with ui cap plus vj cap, so u is equal to ax and v is equal to ay, isn't it? And the differential of equation of the streamline is dy by dx is equal to v by u. Put the value of v, that is ay. Put the value of u, that is ax. A getting cancelled out. Then separate the variables. dy by y is equal to dx by x. And integration of this will give you the equation of the streamline. If you integrate LHS and RHS, then you will get ln of y is equal to ln x plus constant. And the constant can be taken as natural log of constant. इसको सिंप्लीफाई करेंगे तो ln of y is equal to ln of cx. Yes or no? Natural log will get cancelled out. So our equation of the streamline is x is equal to, so y is equal to cx. This is the general equation of the streamline. But we are focusing on the equation of the streamline which is passing through 1, 2. So at 1, 2, x is equal to 1, y is equal to 2. X is equal to 1, y is equal to 2. So c will be equal to 2. Yes? The value of c will be 2. So our equation of the streamline will be equal to y is equal to 2x. Or we can say 2x minus y is equal to 0. This is the equation of the streamline passing through point 1, 2. This will be the equation of the streamline which will be passing through 1, 2. Isn't it? C is the correct answer. Well done, Veera Babu, Shreyas. Good, good, good. Keep it up. This is how the questions are going to be asked. And it is very important, this differential equation of the streamline, and using the differential equation of the streamline, developing the equation of the streamline is important in your GATE exam. Good evening, Kaviraj. Welcome. How are you after a long time? Now the continuity equation or mass conservation equation. Mass conservation for any system or a control volume. If we define a control volume, some mass will be entering into the control volume, some mass will be leaving from the control volume. The difference of these two masses will be the change in mass in the control volume. So we can say m in minus m out is equal to change in mass in the control volume. That is general continuity equation or mass conservation equation. Now 2y minus x is not correct. अलग अभी 4 घंटे और चला लेते हैं इसको. आप बताइए कितना देर तक चलाना चाहेंगे. आप ये कहना चाह रहे हैं एक करेक्ट क्यों नहीं है? देखिए कैसे एक करेक्ट कैसे होगा, बताइए। ए करेक्ट तब होता जब 2,1 होता। अगर x2 होता y1 होता, तब होता क्या? 2,1 पे क्या होता? c की वैल्यू, इक्वेशन ऑफ द स्ट्रीमलाइन ये जनरल इक्वेशन ऑफ द स्ट्रीमलाइन y इक्वल टू सी एक्स एट 2,1 क्या होता? x इज इक्वल टू 2c इज इक्वल टू 1, c इज इक्वल टू 1/2। इस केस में c की वैल्यू 1/2 होती, सो y इज इक्वल टू 1/2x, तब होता ये 2y इज इक्वल टू x, तब बनता ये 2y माइनस x इज इक्वल टू 0। पॉइंट्स आर डिफरेंट, द एक्सप्रेशन विल बी डिफरेंट, राइट? सो 2,1 पे 2y माइनस x इज इक्वल टू 0 होता, बट 1,2 पे इट विल बी ऑप्शन सी। This is the mass conservation equation, basic mass conservation. Mass is entering, mass is leaving, the remaining mass is accumulated in the control volume. For one dimensional and steady flow, for steady flow, change in mass in control volume must be 0. Change in mass in control volume must be 0. If we write per unit time, then we can say mass flow rate entering minus mass flow rate leaving is equal to dm by dt in control volume, isn't it? So for one dimensional and steady flow, dm by dt is equal to 0. So we can say mass flow rate entering will be equal to mass flow rate leaving. That is the equation of that is the continuity equation for one dimensional and steady flow. Or we can say, what is mass entering? Rho into A into V in is equal to rho into A into V out. If the density is constant for incompressible fluid or incompressible flow, if density is constant, then we could have said area into velocity in entering will be equal to area into velocity leaving. Or that means Q in is equal to Q out. So if the flow is one dimensional, steady and incompressible, then discharge entering must be equal to discharge leaving. That is the continuity equation. But if the flow is not incompressible, then this will be the expression. The total mass entering per unit time. So there are two parameters. One is mass flow rate. The unit will be kg per second. That is called as mass flow rate. Or flow rate is also called as flux. Mass flow rate or mass flux. Then there is another parameter Q, that is area into velocity. That is called as volume flow rate. The unit is meter cube per second. Or volume flux. Volume flow rate or volume flux. So sometimes the question gives you if the question gives you the flow rate, if the question only gives you the information about the flow rate, whether it will be mass flow rate or volume flow rate will be decided by the fact that the unit of these two parameters are different. If the unit is given as meter cube per second, then it will be volume flow rate or discharge. If the unit is given as kg per second, then the expression will be mass flow rate, right? Viscosity के टाइम पे भी मैंने ये बताया, डेंसिटी के टाइम पे भी ये चीज मैंने आपको बताई. यूनिट्स आर गोइंग टू बी वेरी वेरी इंपॉर्टेंट टू नो द पैरामीटर गिवन. So if we apply the mass conservation equation for the three-dimensional control volume, this is dx, this is dy, and this is dz. If we apply the continuity equation or mass conservation for the entire control volume, then our expression will be del rho by del t plus del by del x rho u plus del by del y rho into v plus del by This is the general continuity equation which is valid for every type of fluid flow. Steady, unsteady, compressible, incompressible, uniform, non-uniform, etc. This is the general continuity equation. If rho is not a function of x, y, z and time, if density remains constant throughout the flow, look, this is the general continuity equation. You should memorize this. We are obtaining this equation by applying the mass conservation in the control volume, right? U is the velocity in x direction, V is the velocity in y direction, W is the velocity in z direction respectively. So if this equation is satisfied, then only the flow is possible. Fluid flow is possible only when the continuity equation is satisfied. When the continuity equation is not satisfied, then the particular flow is impossible. Then the flow will not be possible. If the flow is steady, density, pressure, velocity are independent of time. In that case, what is the continuity equation for a steady flow? Our continuity equation will become, when density is not a function of time, then we will have del by del x rho into u plus del by del y rho into v plus del by del z rho into w is equal to 0. That is the continuity equation for steady flow. This is the modified continuity equation when the flow is steady, right? If the flow is incompressible, it means density is neither be a function of space nor time. If density remains constant, then our earlier equation rho can be taken outside, rho can be taken outside, rho can be taken outside, because it is not a function of time, not a function of space. So for incompressible flow, del u by del x plus del v by del y plus del w by del z is equal to 0. Or we can also call it as del operator dot velocity vector, that is called as divergent of velocity vector, is equal to 0. For incompressible flow, this is the continuity equation. This will be the continuity equation for incompressible flow. And for two-dimensional flow, the third velocity will be taken as 0. So accordingly, we can apply the continuity equation. This is the continuity equation. This will be the continuity equation, right? Now, can you solve one question? There is a question on the screen. Apply the mass conservation equation and find out the value of lambda. The velocity field for the flow is given. Apply the mass conservation equation to find out the value of lambda. Can you do that? Density, variation of density, because density varies with time. So can we call the flow to be unsteady plus compressible, isn't it? The flow is unsteady and compressible. Rho is given as rho naught exponent minus 2t, e to the power minus 2t. So our original expression, what is del rho by del t from here? Is equal to rho naught into minus 2 e to the power minus 2t. Yes or no? And rho naught e to the power minus 2t is again rho into minus 2. So this is u, this is v, this is w. If we equate this with ui cap plus vj cap plus wk cap. Ui cap plus vj cap plus wk cap. So what is du by dx? Del u by del x? What is del u by del x? Rho is not a function of x, y and z. So if we del u by del x is 5, what is del v by del y? Del u by del x is 5. Del u, del v by del y is also 5. And what is del w by del z? That is lambda. Put the values in the expression. Del rho by del t plus del by del x, rho into u plus del by del y, rho into v plus del by del z, rho into w is equal to 0. Del rho by del t, rho into minus 2 plus this rho can be taken outside the differentiation because it is independent of x. This rho can be taken outside the differentiation because it is independent of y. This rho can be taken outside the differentiation because it is independent of z as well. So rho is taken as common. Del u by del x is 5. Del v by del y is also 5. And del w by del z is lambda is equal to 0. Rho is common. So it will be minus 2 plus 10 plus lambda is equal to 0. So the value of lambda will be equal to minus 8. The value of lambda will be minus 8, isn't it? Minus 8. Correct, Saurabh. Vinay, Kunal, Kaviraj, good. Sumit, well done. Abhi, Anwar, great. Shreyas, keep it up. Clear? This is about the continuity equation. The next important parameter is fluid acceleration. The next is fluid acceleration. I told you that velocity is a function of space and time. The flow behavior changes with the space, the flow behavior changes with time. So velocity can be a function of space, can be a function of time, can be a function of both. If we differentiate this, then dv by dt, total derivative of velocity with time, is equal to del v by del s into ds by dt plus del v by del t into dt by dt. This is how partial derivatives are done. This is called as acceleration. And ds by dt is again velocity. Velocity into del v by del s plus this dt dt getting cancelled out. So that is del v by del t. When the velocity changes with, this is the total acceleration. When the velocity changes with time, that gives the local acceleration. When the velocity changes with space, that is called as convective acceleration. So the total acceleration of the fluid is sum of local and convective. The total acceleration of the fluid will be sum of local and convective acceleration. This is convective, this is local. Clear? So there are two type of acceleration in the fluid flow. One is local, another is convective. Local is also called as temporal because the velocity changes with time. Local or temporal acceleration is developed due to change in velocity with time. So what is local acceleration? That is partial derivative velocity with time. Convective acceleration is also known as advective acceleration when the velocity changes with space. So convective acceleration is v into del v by del s. The convective acceleration is developed when the velocity changes with space. These are the two components of acceleration for 1D flow. For steady flow, do you agree velocity is independent of time? And when the velocity is independent of time, local will be 0. When the flow is steady, don't say that the total acceleration will be 0. When the flow is steady, it implies only that the local acceleration is 0. Convective can be possible, may not be there. When the flow is uniform, it means velocity is not a function of space. So it means the convective acceleration will be 0. For uniform flow, it does not mean that the flow, that the acceleration is zero. Total acceleration won't be zero. Uniform flow means convective acceleration will be zero. But if the flow is steady and uniform both, it means local and convective, both acceleration will be zero, local as well as convective. Or we can say the total acceleration will be zero. There is no acceleration. Or we can say velocity is neither be a function of space nor time. Velocity throughout the flow remains constant when the flow is steady as well as uniform. And in our internal flow or in our real flow, we will be discussing about the flow to be steady and uniform. We will be discussing about the flow where the acceleration is zero. The acceleration will be zero when the flow is steady as well as uniform both. Right? So that is for 1D. Now if we write the general expression for acceleration, if we write the general expression for acceleration for three-dimensional Cartesian coordinate system, so acceleration vector is given by axi cap plus ayj cap plus azk cap. Acceleration is given by axi cap, ayj cap, azk cap, and the magnitude of acceleration is under root of ax square plus ay square plus az square. And what is the ax? Acceleration in x direction. Ax is change in velocity in x direction per unit time. That can be written as u into del u by del x plus v into del u by del y plus w into del u by del z plus del u by del t. That is acceleration component in x direction. Similarly, we can write ay, that is dv by dt. Again u into del v by del x now plus v del v by del y plus w del v by del z plus del v by del t. And acceleration in z direction, dw by dt, change in velocity in z direction per unit time, is equal to u into del w by del x plus v into del w by del y plus w into del w by del z plus del w by del t. These components are called as local acceleration, and these components are called as convective acceleration. This is how the acceleration in any direction can be obtained. Is this clear? So we can say acceleration vector is equal to dv by dt, velocity vector per unit time, is equal to del v by del t plus v dot del multiplied by velocity vector. That is the acceleration. थैंक यू पेरी चेरी, थैंक यू वेरी मच. जब आपका सिलेक्शन होगा और जब आप हमें फोन करके बताएंगे, देन ऑल द टायर्डनेस विल गो ऑफ. सारी मेहनत का फल जब मीठा मिलेगा, जब अच्छा मिलेगा, सो वी विल बी मोर हैप्पी. There is a question on the screen. Try to solve this one. The velocity field is given by this expression. We can Compare it with ui cap plus vj cap. It is 2D flow. X and y are in meter. The acceleration of the fluid particle at 1,1 in x direction. We are only interested in x direction. It is not a function of time. The velocity is not a function of time. It means local acceleration will be 0. So in x direction, ax is equal to del u by del t plus u into del u by del x plus v into del u by del y. This will be 0 because u is not a function of time. Local acceleration will be 0. U is 2y. 2y. What is del u by del x? 0. Plus v is 3x. What is del u by del y? 2. So it will be 6x. And at 1,1. At 1,1. X is equal to 1. So ax will be 6 meter per second square. Similarly, you can find out ay. Can you find out ay? Can you guys find out ay for this? Can you find out ay? C will be the answer. What about ay? If I ask you ay, ay is equal to del v by del t, local acceleration, plus u into del v by del x now, plus v into del v by del y. This is also 0 because the velocity is independent of time. Steady flow. U, that is 2y, del v by del x, that is 3, plus v, that is 3x, and del v by del y, that is 0. So it will be 6y. Ay will be 6y. At 1,1. At 1,1. Ay is equal to 6 meter per second square. Ay will also be 6 meter per second square. What is the magnitude of total acceleration? Under root of 6 square plus 6 square. ये बनेगा. That will be 8.48 meter per second square. The total acceleration is 8.48. मीटर स्क्वायर पर सेकंड नहीं होगा. मीटर स्क्वायर पर सेकंड नहीं होगा. मीटर स्क्वायर पर सेकंड is the unit of kinematic viscosity. Meter per second square is the unit of acceleration. Yes. Right? There is a difference between unit of kinematic viscosity and acceleration. आगे बढ़े. Is this clear to everyone? ये क्वेश्चन सॉल्व करके बताइए. Let us solve this one and then we will proceed further. अच्छा, हाँ. The question says the area of a 2 meter long tapered duct decreases as this. Area is decreasing. It means it is a converging section. And because area is decreasing with x, so the velocity will be a function of x. So non-uniform flow. Flow is non-uniform. At a given instant, a discharge of 0.5 meter cube per second is flowing in the duct and is found to increase at the rate of this 0.2 meter cube per second. This is dq by dt. dq by dt. Rate of change of discharge. Because discharge is a function of time, it means velocity is a function of time as well. Here the velocity is a function of x. Here the velocity is a function of time, so it is unsteady. The flow, the given flow is unsteady as well as non-uniform. The given flow is neither steady nor uniform. Right? Now, the local acceleration in meter per second square at x is equal to 0. So we will find out the local acceleration at any x. Del Vx by del t. That is the local acceleration. And Vx can be written as Q upon Ax. and 1 upon ax can be taken outside, del q by del t. That is the local acceleration. And that will be equal to 1 upon 0.5 minus 0.2x. That is ax into del q by del t is 0.2. That is the expression for local acceleration at any x. This is the general expression. Now at x is equal to 0, at the inlet, what is ax local? What is the local acceleration? If you put x is equal to 0, then it will be 0.2 upon 0.5. Kitna aega? What is 0.2 by 0.5? 2 by 5, 0.4. Isn't it option C? Can you find out the convective acceleration also, because it is non-uniform flow? So there must be a convective acceleration as well. Can you find out the convective acceleration? If we want to find out ax convective, that is Vx into del Vx by del x. And what is Vx q by ax into del by del x, again q by ax. So it will be q square by ax into del by del x. Then what is ax? 0.5 minus 0.2x. This will be the convective. Q square upon ax. If you do the differentiation with respect to x, that will be minus 1. Then 0.5 minus 0.2x to the power minus 2 into minus 0.2. That will be the expression. Ax is, this is ax only. So it will be q square upon 0.5 minus 0.2x to the power 3 into 0.2. That is the expression for convective acceleration. Correct? And at x is equal to 0, at x is equal to 0, so q square, what is q? Q is equal to, this is q, 0.5 meter cube per second. So it is 0.5 square into 0.2 upon 0.5 cube. This will be the expression. So this is also 0.2 by 0.5. Yes or no? That is equal to 0.4. Ax convective will also be 0.4. Convective will also be 0.4. Sumit, convective will also be 0.4. And the total acceleration will be local plus convective. That is 0.4 positive plus 0.4 again positive. So 0.8 will be the total acceleration at x is equal to 0. 0.8 will be the total acceleration at x is equal to 0. Anybody is having any doubt, please do let me know. If you have anything to ask. This is about the acceleration. Clear? The next parameter is rate of angular deformation. The rate of angular deformation is total rate of change of angle of initially drawn perpendicular line segments. Rate of angular deformation is d theta by dt or epsilon. The notation is d theta by dt. Rate of angular deformation. कविराज स्टूडियो में ठंड नहीं लग रही है, आई एम इनसाइड द स्टूडियो, वरना बाहर बहुत ठंडा है. टेक केयर ऑफ योर हेल्थ, वेरी वेरी इंपॉर्टेंट. जो भी आपने तैयारी की है, अगर लास्ट मोमेंट पे आपकी हेल्थ आपका साथ नहीं देगी, सो इट विल बी डिफिकल्ट टू कॉन्सेंट्रेट ऑन द स्टडीज, बिकॉज इन नॉर्थ द क्लाइमेट इज और द वेदर इज वेरी कोल्ड. सो टेक केयर ऑफ द हेल्थ, वेरी इंपॉर्टेंट फॉर बेटर concentration. It is the total rate of change of angles of initially drawn perpendicular line segments. So in xy plane, epsilon xy is equal to d alpha by dt plus d beta by dt. Change in angle for x will be alpha or d alpha, and this is d beta. This will give you total rate of change of angle, will give you the rate of angular deformation. If we write in terms of velocity, so it will be del x plus del y. Here it will be del u, here it will be del v. This is the expression for rate of angular deformation in xy plane. Similarly epsilon yz लिख सकते हैं आप. कैसे? del y plus del z. यहां पे वेलोसिटी इन z डायरेक्शन आ जाएगा, यहां पे वेलोसिटी इन y डायरेक्शन, दैट इज v. Similarly epsilon zx, here del z plus here del x, here it will be del u, here del w. Right? This is the formula. These are the formula for rate of angular deformation. Then another parameter is the rotation. For rotation, we define the rate of rotation. Omega. It is a vector quantity. Omega, rate of rotation or angular velocity omega. It is the average of rate of change of angles of initially drawn perpendicular line segments. This is d alpha, this is d beta. So omega about z axis is equal to half of d alpha by dt plus d beta by dt. So it will become half of del x minus del y. Here it will be del v, here it will be del u. This is the expression. हाँ, कुछ जगह पे कविराज कुछ लोग हाफ लिखते हैं डिफॉर्मेशन के केस में, बट वो गलत है. डिफॉर्मेशन में हाफ नहीं आएगा, रोटेशन में हाफ आएगा, क्योंकि रोटेशन इज एवरेज. द रेट ऑफ रोटेशन इज एवरेज ऑफ रेट ऑफ चेंज ऑफ एंगल्स, बट डिफॉर्मेशन, रेट ऑफ एंगुलर डिफॉर्मेशन इज द टोटल रेट ऑफ चेंज ऑफ एंगल्स. तो यहां पे आपको हाफ नहीं लेना है. राइट? ओमेगा एक्स लिखा जा सकता है, हाफ लेंगे, एक्स के बाद वाई आता है, देन नेगेटिव साइन आएगा, देन जेड आता है. यहां पे डब्ल्यू और यहां पे वी. ओमेगा वाई लेना है, हाफ आएगा, वाई के बाद जेड माइनस जेड के बाद एक्स, यहां पे यू, यहां पे डब्ल्यू. These are the expression for rate of rotation. अगर इसको जनरलाइज करें, सॉरी, ये एंड ओमेगा वेक्टर कैन बी रिटन एज ओमेगा एक्स आई कैप प्लस ओमेगा वाई जे कैप प्लस ओमेगा जेड k cap. This is the angular velocity vector. There is one more parameter defined that is called as vorticity. Vorticity. नेगेटिव इसलिए क्योंकि ये पॉजिटिव x डायरेक्शन है और ये पॉजिटिव y डायरेक्शन है. So, अगर फ्लूइड एलिमेंट इधर मूव करता है, इसका मतलब वेलोसिटी इज इन दिस डायरेक्शन, दैट इज नेगेटिव. ये फ्लूइड अगर इधर मूव कर रहा है तो ये दिस इज पॉजिटिव बट दिस डायरेक्शन इज नेगेटिव, दैट इज व्हाई देयर इज द नेगेटिव साइन. इसकी वजह से यहां पे नेगेटिव साइन आता है. अगर रेट ऑफ एंगुलर डिफॉर्मेशन में बात करें, ये भी एलिमेंट इधर जा रहा है और ये भी एलिमेंट इधर जा रहा है, तो बोथ आर पॉजिटिव। ये एंटायर फ्लो का एंगुलर वेलोसिटी है। दिस इज द वेलोसिटी ऑफ द फ्लो ऑफ एंटायर फ्लूइड। Right? Then one more term is defined that is called as vorticity vector. The tendency of the fluid element to spin or rotate. ये microscopic property है, microscopic parameter है। Fluid particles की बात कर रहे हैं यहाँ पे। Tendency of the fluid element to spin, or mathematically it is twice the rotation. So vorticity vector is equal to twice of omega vector. यहाँ पे half नहीं आएगा because it is multiplied with 2. So it will be I cap, J cap, K cap, del by del X, del by del Y, del by del Z, U, V, W. Solving this determinant will give you that vorticity vector, or we can call it as del cross V. It is the cross product of del and V, or that is called as curl of velocity vector. It is a vector quantity. So if we want vorticity about z-axis, then it will be del v by del x minus del u by del y. Vorticity में half नहीं आएगा, angular velocity में half आएगा. There will not be half in vorticity, there will not be half in vorticity, but there will be half in angular velocity. Twice the rotation is called as vorticity, right? There is a question on the screen. Can you solve this one? There is a question. Please give it a try. Please give it a try. Velocity is given by this expression. It is u, it is v, it is 2D flow. So whether it is compressible or incompressible, how to check? Apply the continuity equation for incompressible flow. Apply the continuity equation for incompressible flow. That is del u by del x plus del v by del y is equal to 0. If this condition is getting satisfied, then it is incompressible, otherwise compressible. So what is del u by del x? 1. And what is del v by del y? That is minus 1. So LHS will be 1 plus minus 1 is equal to 0 RHS. So the flow is not compressible. Flow is incompressible. Now, whether it is rotational or not rotational, find out the angular velocity about z-axis. Del v by del x minus del u by del y. What is del v by del x? Del v by del x is equal to 0. What is del u by del y is equal to 2. So del v by del x is 0 minus 2. It is not 0, so rotational. The flow will be rotational. It is not irrotational. So the correct answer is option D. The flow is incompressible but not irrotational. It is rotational flow. Clear? The next parameter defined is velocity potential function phi. It is a function of space and time. It is a scalar quantity. It is a scalar and continuous function of space and time such that its negative derivative with respect to space gives the velocity of the flow in that direction. The flow always takes place in the direction of decreasing potential. In the flow direction, phi decreases. The velocity potential function decreases in the flow direction. So minus of del u by del x, minus of del phi by del x is equal to u, minus of del phi by del y is equal to v, and minus of del phi by del z is equal to w. This is how the function is defined. Now, if we apply the continuity equation, then the continuity equation will be satisfied only when the velocity potential function satisfies the Laplace equation. The continuity equation will be satisfied only when the velocity potential function satisfies Laplace equation, and the flow is always irrotational. It means velocity potential function only exists for irrotational or ideal flow. That is important result. About the velocity potential function, these are the properties of velocity potential function. The fluid flow is possible only if the velocity potential function satisfies the Laplace equation. What is Laplace equation? Del square phi is equal to 0. That is called as Laplace equation. When the velocity potential function satisfies the Laplace equation, यस सुमित, क्या पूछना चाह रहे हैं आप? अगर फ्लो को रोटेशनल और इरोटेशनल चेक करना है तो एंगुलर वेलोसिटी कैलकुलेट करिए. If the angular velocity is coming out to be 0, it means irrotational flow. If the angular velocity is coming out to be non-zero, it is rotational flow. So velocity potential function is only defined for irrotational flow, and that is the reason ideal flow is also called as potential flow. आइडियल फ्लो के लिए पोटेंशियल फंक्शन डिफाइन किया जाता है. रियल फ्लो के लिए पोटेंशियल फंक्शन इज नॉट डिफाइंड. It is only defined for the ideal flow, but the flow will be possible only when the velocity potential function satisfy the Laplace equation. All right. The another function is called as stream function. Stream function psi. It is a function of space and time. It is also a function of space and time. Continuous and scalar function of space and time, which is defined such that it must satisfy continuity equation for two-dimensional incompressible flow. So it means the existence of a stream function guarantee the possibility of the flow. And value of psi increases to the left of the flow direction. Psi increases to the left of the flow direction. This is the flow direction, let us say. In the left, the stream function increases. In the right, stream function decreases. In the right side of the flow direction, the velocity the stream function decreases. In the left hand side, it will increase. So this function is defined like this. Del phi by del y is equal to del psi by del y. Del psi by del y is equal to u, and minus of del psi by del x is equal to v. Now we can say stream function exists for both types of 2D flow. It is defined only for two-dimensional flow, but both type means rotational as well as irrotational. The flow will be irrotational only if stream function satisfies the Laplace equation. What is the Laplace equation for a stream function? This is the Laplace equation. When this is true, then the flow will be irrotational. Otherwise, the flow will be rotational. otherwise the flow will be rotational. क्लियर? तो हमने क्या कहा, u is given as minus del phi by del x, or we can call it as del psi by del y. Similarly, v is equal to minus del phi by del y, or it will be minus of del psi by del x. So u is so these two equations, the relation between phi and psi, they are known as Cauchy-Riemann equations. These equations are known as Cauchy-Riemann equations. हाँ, यहां पे थोड़ा सा किसी को डाउट है, यहां पे थोड़ा डाउट है. कुछ लोग ऐसा भी लिखते हैं, ध्यान दीजिए, मैंने यहां पॉजिटिव साइन लगाया, यहां नेगेटिव साइन लगाया. यहां पे तो दोनों नेगेटिव हैं, both are negative. Phi will have negative sign at both the position. But some people write like this: u is equal to minus del phi by del x. That is always valid. But some people put negative sign here, and v is equal to minus del phi by del y. That is valid everywhere. And putting positive sign here. कुछ लोग ऐसा भी लिखते हैं. This is also correct. This is also correct, because the condition for stream function is the continuity equation must be satisfied. That is the condition. The function is defined such that the continuity equation must be satisfied. तो एक जगह पॉजिटिव होगा, एक जगह नेगेटिव होगा, then only continuity equation will be valid. But कुछ लोग पॉजिटिव नेगेटिव को इंटरचेंज करते हैं. That is also fine. That is also fine. That will not violate the definition of stream function. Are you getting it? So it does not matter whether you are putting negative sign in u or you are putting negative sign in v. But one should be positive, one should be negative. That is आप लोगों के लेवल पे both will be treated correct. But if you will analyze more in detail, then you will realize that this is only correct. But आपके लेवल पे, ग्रेजुएशन लेवल पे, it does not matter whether you put negative sign here or positive sign here, right? So if the option is containing this, then this will also be taken as correct, right? Kaviraj, more appropriate is this. But अगर दोनों ही गिवन है, ऐसा होगा नहीं, दोनों एक्सप्रेशन विल नॉट बी देयर इन योर एग्जाम. बट अगर फिर भी होता है तो दिस इज मोर अप्रोप्रिएट. पुटिंग पॉजिटिव साइन इन यू एंड पुटिंग नेगेटिव साइन. क्यों? क्योंकि ये जो मैंने कंडीशन बताई है, ये टू द लेफ्ट ऑफ द फ्लो डायरेक्शन, अगर मान लीजिए फ्लो डायरेक्शन ये है, दैट इज यू. लेफ्ट क्या होगा? ये लेफ्ट में साई इंक्रीज. इसका मतलब अगर y इंक्रीज कर रहा है तो साई इंक्रीज करेगा. सो डेल साई बाय डेल वाई विल बी पॉजिटिव. आर यू गेटिंग इट? और राइट डायरेक्शन में साई डिक्रीज. del psi by del y will be positive, right? तो बट आपको इतना टेंशन लेने की जरूरत नहीं है. You do not have to worry much about this. One should be positive, another should be negative. So the final conclusion for the velocity potential function is it is valid for 3D flows and only irrotational, whereas the stream function is valid only for planar flow or two-dimensional flow, axisymmetric, which is valid for both rotational and irrotational. It is valid for both rotational as well as irrotational. Couple of more important points. When the flow is steady, जैसे मान लीजिए, जैसे इसका सिग्निफिकेंस यही है, if there are three streamlines, 1 2 3, there are three streamlines, the stream function remains constant for a particular streamline. For a particular streamline, stream function remains constant. So psi1 is equal to c1, psi2 is equal to c2, and psi3 is equal to c3. These along the streamline, the stream function remain constant, and to the left of the flow direction, psi increases. This is the left direction. इसका मतलब क्या है? psi1 will be greater than psi2 will be greater than psi3. सिर्फ ये मतलब है. If there are multiple streamlines, psi1 will be more than psi2 then psi3 to the left of the flow direction. Along the flow direction, stream function does not change, but to the left of the flow direction, stream function increases. So there is another definition of streamline. The curves of constant stream function psi are known as streamlines of the flow. The curves which are having constant streamline throughout, constant stream function values throughout, they are known as streamline. Psi1 is constant, it means it is a streamline. Psi2 is constant, it means it is also a streamline. Psi3 is constant, it means it is also a streamline. So curves of constant stream function values represent the streamlines of the flow. And the difference between any two stream functions psi1 and psi2 represents the discharge per unit width between the streamline. So discharge is given by psi2 minus psi1. Discharge is calculated by the difference between stream function values for the two streamline. And for the steady flow, discharge remains constant. For a steady and incompressible flow, discharge will be constant. So these are two important points you should know, you should understand. Now, equipotential lines and streamlines. What are equipotential lines? For which phi is constant. These are known as equipotential lines. What are streamlines? Psi is constant. Equipotential line, potential function remains constant. Streamlines, stream function remains constant. So if there is a flow in x direction, these are the streamlines. So we can say psi will not be a function of x. Psi will not change in x direction. Psi will be a function of y. And if we draw the equipotential lines and streamlines are always perpendicular to each other. They will always be perpendicular to each other. This is how equipotential lines will be drawn. Psi is not a function of y. Phi will be a function of x. These are the streamlines, and equipotential lines will be drawn perpendicular to the streamlines. This is known as flow net. Equipotential lines and streamlines are orthogonal or perpendicular to each other in a flow field, except at the stagnation point. What is the stagnation point? Where the velocity is zero. The point of zero velocity. When the velocity is zero, it means there is no flow. And when there is no flow, these lines are not defined. The lines are not defined for the stagnation point. So that is why, except at a stagnation point, equipotential lines and streamlines are always perpendicular to each other in the flow field. Now, please try to solve this one. Can you solve this one? There is a question on the screen. This is all about kinematics. We have completed our analysis of kinematics very fast. Total difference in the stream function values represent the discharge per unit width. कविराज पर यूनिट विड्थ है वो, तो इसको विड्थ से मल्टीप्लाई करेंगे तभी टोटल डिस्चार्ज मिलेगा. ये डिस्चार्ज पर यूनिट विड्थ है. अगर विड्थ से मल्टीप्लाई करेंगे तभी टोटल डिस्चार्ज मिलेगा. यही मैंने लिखा है, पर यूनिट विड्थ. राइट? क्लियर? Stream function is given by this expression. What is the velocity at point 2,1? तो हम बोल सकते हैं del psi by del y is equal to u. U की वैल्यू क्या होगी? del psi by del y 2x and minus del psi by del x is equal to v. V की वैल्यू क्या होगी? minus del psi by del x, that is minus 2y. Yes or no? At 2,1. At 2,1, u will be equal to 4, v is equal to minus 2, u is equal to 4, v is equal to minus 2, and the magnitude of velocity will be under root of u square plus v square. That is under root of 4 square plus minus 2 square. That will give you the answer. That will give you the answer. (2x) u is equal to 2x, v is equal to minus 2y. Correct? The answer will be 4.47. Are you getting it? 4.47. D will be the correct answer. अगर ये phi given है, क्या हम स्ट्रीम फंक्शन गिवन है, क्या हम फाइंड आउट कर सकते हैं वेलोसिटी पोटेंशियल फंक्शन? फॉर द गिवन स्ट्रीम फंक्शन कैन वी फाइंड आउट द वेलोसिटी पोटेंशियल फंक्शन? कैसे फाइंड आउट करेंगे? अगर इसको डिफरेंशिएट करें, if we differentiate this, then what we will get? D phi is equal to del phi by del x into dx plus del phi by del y into dy. तो ये जो u है, this u is minus of del phi by del x, isn't it? So what is del phi by del x? Isn't it minus 2x? And this v is equal to minus of del phi by del y. Yes or no? So del phi by del y is 2y is equal to d phi. अगर इसको इंटीग्रेट कर दें, if we integrate this, then what do we get? We will get phi is equal to integration of minus 2x dx minus 2x square by 2. So it will be minus x square 2y dy, integration of 2y dy, integration of 2y dy, 2y square by 2, that will be y square. So that is the corresponding velocity potential function. For the given stream function, the corresponding velocity potential function is minus x square plus y square. अगर आप इसको x square minus y square लिखेंगे तो भी कोई प्रॉब्लम नहीं है. Both are correct. Minus x square plus y square, or we can write x square minus y square, both will be correct. Clear? I hope this is clear. कोई डाउट हो तो बताइए. Tell me. Yes. And one more question, and then we will enter into the dynamics of the fluid flow. Then we will be talking about the dynamics. For a two-dimensional flow field, stream function is given by this. Stream function is given by this. The magnitude of discharge occurring between the streamline passing through 0, 3, let me call it as psi 1, and 3, 4, that is psi 2. So what is the magnitude of discharge occurring between these streamline? Isn't it psi 2 minus psi 1? So what is psi 2? 3, 4, 3 by 2, then y square, 4 square, minus 3 square. How much is that? And what is psi 1? Psi 1 is equal to 3 by 2. Then y square, that is 3 square minus 0. So psi 1 is equal to 27 by 2. And what is psi 2? Five. Sorry. 16 minus 9. 21 by 2. Isn't it 21 by 2? So what is discharge mode? Six by 2. Isn't it 3? 3 units. B. B will be the answer. I hope this is clear. Yes. अब बताइए, in kinematics, if you have anything to ask, any doubt. So this is all about kinematics of the fluid flow. Then we will be talking about the dynamics, fluid dynamics. Please, those who have joined me late, please do like and share. And do subscribe our BYJU'S YouTube channel, because every day there will be one marathon, complete marathon for each and every subject till 20th of January. After 20th, you will feel that your preparation is will be at par with your other competitors. So do not forget to join these sessions, marathon sessions. It will help you to boost up your confidence. And now the last topic of our syllabus, that is dynamics. What is fluid dynamics? The fluid dynamics is the study of the flowing fluid considering the forces causing the motion. Dynamics is study of the flowing fluid considering forces causing the motion. Here we will be talking about the forces. And the dynamics will be studied in two parts. One is ideal flow, another will be real flow. Ideal flow and real flow. First, we will analyze the ideal flow, which is the application of Bernoulli equation, and then we will move to the real flow. Then our analysis of fluid mechanics will be over. क्लियर? यस ड्रीम्स. ब्रेक चाहिए 5 मिनट का. आइडियल फ्लो के बाद ब्रेक लेंगे 10 मिनट का. बाउंड्री लेयर इज अ पार्ट ऑफ रियल फ्लो ओनली. रियल फ्लो को भी दो पार्ट में स्टडी करते हैं. एक internal flow, that is flow in a pipe. Another is external flow, that is flow over a surface. तो एक्सटर्नल फ्लो को भी डिस्कस करेंगे, इंटरनल फ्लो को भी डिस्कस करेंगे. दैट इज द पार्ट ऑफ रियल फ्लो ओनली. So let us start talking about the dynamics. After the ideal flow, we will take another break for 10-15 minutes. Model laws वगैरह हम dimensional and model analysis will be covered separately along with the hydraulic machine. वो पोर्शन हाइड्रोलिक मशीन के साथ कवर करेंगे, वरना आपके लिए भी हेक्टिक हो जाएगा, मेरे लिए भी हेक्टिक हो जाएगा. So the plan is to complete the entire fluid mechanics including statics, kinematics and dynamics. ठीक है. हाइड्रोलिक मशीन के साथ मैं वो अलग से ले लूंगा. राइट इतना आप करिए एक बार के लिए. एक ही दिन में सब कुछ कर देंगे तो इट विल बिकम डिफिकल्ट फॉर यू टू डाइजेस्ट. So for ideal flow, we apply the Bernoulli equation. What is ideal flow? Already मैं आपको बता चुका हूं. When the viscous forces are taken as zero. Ideal flow is the flow when the viscous forces are taken as zero. Right? So for ideal flow, the energy conservation equation is known as Bernoulli equation. For Bernoulli equation to be applied, the flow is non-viscous. Fe is equal to 0. The flow must be steady. Steady flow. Density, velocity, pressure are independent of time. The flow is incompressible. Density is neither be a function of space nor time. Density remains constant throughout the flow. And there is no heat and mass transfer. It means there is no any other form of energy transfer to the fluid, from the fluid, to the fluid and from the fluid. And the equation is written along the tangential direction. Flow direction means tangential direction along a streamline. The direction of the streamline or the tangent to the streamline is the velocity vector. So the equation will be applied along the streamline or in tangential direction or flow direction. And according to Bernoulli equation, what is Bernoulli equation? There are three ways in which Bernoulli equation is written. P plus rho gz plus rho v square by 2 is equal to constant. That is one form of Bernoulli equation. Whenever the flow is ideal, the total energy of the fluid remains constant. P plus rho gz plus rho v square by 2 is constant. The unit of each and every term is energy per unit volume or joule per meter cube, or it can be called as Newton per meter square or Pascal. So this is the energy equation in terms of pressure. First term represents the static pressure of the fluid. First term represents the static pressure of the fluid. Will it be absolute pressure or gauge pressure? अब बताइए. Will this pressure be absolute or gauge? Static pressure. Will it be absolute or gauge? Will it be absolute pressure or the gauge pressure? It is purely your choice. You can take it absolute or you can take it gauge. There is no rule as such. There is no rule. You can take it gauge pressure, you can take it absolute pressure. कुछ लोग absolute लिख रहे हैं, कुछ लोग gauge लिख रहे हैं. कोई भी ये नहीं बता रहा कि gauge or absolute anything can be taken. Right? Rho gz is hydrostatic pressure obtained from the hydrostatic law. This is called as hydrostatic pressure. And rho v square by 2 is called as dynamic pressure. And sum of static pressure and hydrostatic pressure is known as piezometric pressure. This is piezometric pressure. And sum of static and dynamic Sum of static and dynamic is called as stagnation pressure. Sum of static and dynamic is called as stagnation pressure. Right? Stagnation. अगर मैं पूरी की पूरी इक्वेशन को रो से डिवाइड कर दूं, बिकॉज रो इज कांस्टेंट, रो इज कांस्टेंट. If we divide the entire equation by rho, then we will get another form. So the first term will become P by rho plus GZ plus V square by 2 is another constant. Now each and every term represents energy per unit mass, joule per kg, energy per unit mass. This is another way of writing the Bernoulli equation. राइट क्यों ऐसा बोल रहा हूं एनर्जी पर यूनिट मास है? क्योंकि mgz is potential energy, half mv square is kinetic energy, pressure into volume is pressure energy. ये तीन एनर्जी है. mgz is potential energy, half mv square is kinetic energy, and pressure into volume. So mgz, m is missing, half mv square, m is missing, so it is energy per unit mass. If we divide by g also, g is also constant. If we divide entire equation by g, so the first term will be p by rho g, the second term will be z, then the third term will be v square by 2g, is another constant. Now each and every term represents energy per unit weight, energy per unit weight, and joule per Newton. And what is joule per Newton? That is meter. So this is capital H. This is energy equation in terms of flowing fluid head. This is static pressure head. It is static pressure head. This is potential energy head, or we can call it as datum or elevation head. And this is called as kinetic energy head, or we can call it as dynamic pressure head, or we can call it as velocity head. So each and every term represents head in terms of flowing fluid. The heads are written in terms of flowing fluid. The heads are written in terms of flowing fluid, right? So what we can say, the sum of these three energies is called as total hydraulic energy. Total hydraulic or mechanical energy, we can call it as mechanical energy also. For an ideal flow, if the flow is ideal, for an ideal flow, the total hydraulic energy of the fluid always remains constant. So Bernoulli equation is nothing but energy conservation equation for an ideal flow. It is energy conservation equation for an ideal flow. Ideal flow means there is no energy loss. Ideal flow means there is no energy loss. So Bernoulli equation is energy conservation equation for an ideal flow. Clear? Any doubt? Whenever we talk about ideal flow, there is no energy loss. There is no energy loss. Are you able to see it? No energy loss. So the total energy at 1 is equal to total energy at 2. This is 0.1. This is 0.2. In terms of flowing fluid head, we can write head, we can say H1 is equal to H2. And what is H1? P1 is the static pressure, P1 by rho g, plus Z1. What is Z1? Z1 is the potential energy head from the reference line. We can draw any horizontal line and call it as reference line. Z1 is the height of point 1. Z2 is the height of point 2 from the reference line. Z1 and Z2. So P1 by rho g plus Z1 plus V1 square by 2g must be equal to P2 by rho g plus Z2 plus V2 square by 2g. That is called as Bernoulli equation. V2 is the velocity of flow at point 2. V1 is the velocity of flow at point 1. P1 is the static pressure at point 1. P2 is the static pressure at point 2. And Z1 and Z2 are the vertical distance from the reference line. Vertical distance of point 1 and point 2 from the reference line. This is how we can write the Bernoulli equation for an ideal flow. If the flow is real, for a real flow, energy loss will be, real flow can be laminar or turbulent. There will be energy loss in the flow direction. There is always energy loss in flow direction. So if we write energy equation, then we will say H1 is equal to H2 plus HL. That is the frictional head loss. HL is the frictional head loss. HL is the frictional head loss. If the flow is from 1 to 2, if the direction of flow is from 1 to 2, then there will be energy loss in the flow direction. So here we will write H1 is P1 by rho g plus Z1 plus V1 square by 2g is equal to P2 by rho g plus Z2 plus V2 square by 2g plus HL. This is the energy conservation equation for the real flow. Real flow, examples of real flow are laminar and turbulent. So the conclusion here is fluid always flow in the direction of decreasing total hydraulic energy of the fluid. Or we can say in the direction of the flow, total energy of the fluid always decreases. In the direction of the flow, the total energy of the fluid always decreases. That is energy conservation equation for real flow. We do not call it as Bernoulli equation. It is not a Bernoulli equation. It is not a Bernoulli equation. It is simply the energy conservation equation for a real flow. Now let us solve one question. There is a question on the screen. Everyone, please try to solve this. Can you solve this? A smooth pipe of diameter 200 mm carries water. The pressure in the pipe at section S1, the elevation of point S1 is 10 meter is 50 kilopascal. Pressure is 50 kilopascal. At section S2, elevation is 12 meter. The pressure is 20 and velocity is 2 meter per second. Which of the following is true? One is the direction of the flow. Another is the amount of head loss. These are the two things which we need to calculate. क्या करेंगे? Assume the flow to be from 1 to 2. You can assume the direction of the flow from 1 to 2 or 2 to 1. Assume the flow to be from 1 to 2. If we are assuming the flow to be from 1 to 2, then we can say P1 by rho g plus Z1 plus V1 square by 2g is equal to P2 by rho g plus Z2 plus V2 square by 2g plus HL. Isn't it? The loss will be added in 2. The loss will be added in 2 because the flow is assumed to be from 1 to 2. The velocity is 2 meters per second and the diameter is constant. Because the diameter is constant, so Q is equal to A1 V1 is equal to A2 V2 is constant. That is the continuity equation. And we can say V1 is equal to V2 because area is constant. Because A1 is equal to A2. So according to continuity equation, velocity will remain same. So V1 square and V2 square will get cancelled out. So what is P1 by rho G? P1 is 50 kilopascal. 50 into 10 to the power 3 upon rho is 10 to the power 3, it is water, into G is, let us say, 10. Z1 is 10 meter is equal to P2 is 20 kilopascal. 20 into 10 to the power 3 kilopascal. Rho is 10 to the power 3 into G is, let us say, 10 plus Z2. What is Z2? 12 plus HL. The only unknown is HL. If you simplify this, 10 to the power 3 getting cancelled out, 10 to the power 3 getting cancelled out. So it is 5 plus 10 is equal to 2 plus 12 plus HL. How much is that? HL will be around 1 meter. Because we are getting it as positive value, it means assumption is correct. Because we are getting a positive value, assumed direction is correct. Our assumed direction is correct. So the flow is from 1 to 2. 2 to 1 is incorrect. 2 to 1 is incorrect because we are getting a positive value. If we will get HL to be negative, it means our direction is incorrect. Yes. Yes, Shreya. यही किया मैंने. Better write the equation. Assume any direction. If HL will be coming out to be positive, it means your direction is correct. If HL will come out to be negative, it means the direction is opposite. The value will not change. The value of HL will not change. Whether you put HL on the left hand side or the right hand side. If you put HL on the left hand side, then HL will be -1. It means your direction is incorrect. Isn't it? Because the question is to find out the amount of loss also. So the direction will be from 1 to 2, A and C. And the head loss will be around 1 meter. Why we are not getting exactly 1.06? Because G is taken as 10. Because we have taken G as 10. That is why there is a slight difference, but the nearest option is 1.06. C will be the answer. C will be the correct answer. Then application of Bernoulli equation. 10 लेने पे नियरेस्ट आंसर मिल जाएगा वीरा बाबू. Because exact value is not important here. The nearest value will also work. If it is NAT type question, then you have to take GS 9.81 only. सोफिया टेलीग्राम चैनल, आप टेलीग्राम सर्च कर सकते हैं, मैकेनिकल बाय चंद्रशेखर. On the Telegram, search by the name Mechanical by Chandrasekhar, you will find the link. Then there are 3 instruments which are based on Bernoulli principle: venturimeter, orifice meter, and pitot tube. These are the flow measuring devices which are based on the concept of Bernoulli equation. Let us first talk about the venturimeter. Venturimeter is a gradual converging and then gradual diverging section like this. Venturimeter is a gradual converging and gradual diverging section instrument which is used to measure the flow rate or discharge. This is called as inlet. This is called as throat. Area at the throat is A2. Area at inlet is A1. So 1 and 2 are inlet and throat respectively. So if we apply between 1 and 2, if we apply continuity equation, and Bernoulli equation. If we apply continuity equation and Bernoulli equation between 1 and 2, then we will get the expression for discharge as A1 A2 under root of 2GH upon under root of A1 square minus A2 square. This is the expression for discharge. Because we are applying Bernoulli equation without loss, so that gives the theoretical discharge. This is theoretical discharge. What is H? H is equal to P1 by rho G plus Z1 minus P2 by rho G plus Z2. Or if we attach a U2 manometer, that is X into SM by SF minus 1. If we attach a U2 manometer, then this will be H is piezometric pressure head difference between 1 and 2. X is the manometric fluid deflection, SM is the specific gravity of manometric fluid, SF is the specific gravity of flowing fluid minus 1. For horizontal pipe, Z1 is equal to Z2. So H will simply be P1 minus P2 by rho G, static pressure difference. For inclined, it will be this. And for horizontal pipe, P1 minus P2 by rho G, that is X into SM by SF minus 1. This is the expression for discharge for Venturi meter. How we obtain this? By applying the continuity equation, mass conservation and energy conservation equation between 1 and 2. SM is the specific gravity of manometric fluid. If you attach U to manometer between 1 and 2, manometric fluid specific gravity is SM, specific gravity of the flowing fluid is SF. X is the manometric fluid deflection. What we discussed in our fluid statics manometry. So in the previous expression of discharge, losses are not considered. So it gives the theoretical discharge. For actual discharge, we introduce the coefficient of discharge. What is the coefficient of discharge? The ratio of Q actual by Q theoretical. And that is under root of H minus HL by H. That is called as coefficient of discharge. H is piezometric pressure head difference and HL is the frictional head loss between 1 and 2. HL is the frictional head loss, H is the piezometric pressure head difference. So Q actual, if you want to write Q actual, then coefficient of discharge into Q theoretical. That will be the expression for actual discharge. Because Venturi meter is a gradual converging and diverging pipe. It is a gradual converging and diverging section. So the losses are very small. So coefficient of discharge for Venturi meter. Coefficient of discharge for Venturi meter is around 0.96 to 0.98. Very close to 1. The coefficient of discharge for Venturi meter is close to 1. That is why theoretical discharge is almost same as actual discharge. There is very less difference between theoretical and actual discharge using the Venturi meter. So the measurement of discharge is very much accurate in case of Venturi meter. But if we use the orifice meter is also having the same Bernoulli principle. The only thing is CD for orifice meter lies between 0.64 to 0.76. So the losses are more. It is a thin circular angular plate. Here A1 is the pipe area and A2 will be orifice area. Orifice means the hole. The expression will be same. Q is equal to CD into A1, A2 under root of 2GH. H is again the same under root of A1 square minus A2 square. The formula will remain same by applying the mass conservation and energy conservation. Yes, if you want to apply the formula directly, then you have to memorize this formula. Otherwise, you can apply continuity equation between 1 and 2 and applying the Bernoulli equation between 1 and 2, you will get the same result. 3 equations are to be applied. Continuity equation, Bernoulli equation and and pressure equation in terms of flowing fluid, you will get these results. Better if you memorize this formula. Right? The next is pitot tube. This is a pitot tube attached to the aeroplane. What is pitot tube? Pitot probe? A small open-ended tube with a short right-angled bend. There is a 90-degree bend. Is used to find out the velocity of the flow or dynamic pressure in a pipe or a channel. It is based on the Bernoulli principle that if velocity of the flow becomes zero, that is the stagnation point, the pressure of the fluid increases because the kinetic energy gets converted into pressure energy. So this is the pitot tube. So when the fluid is coming like this, here the velocity is V, but here at this point velocity becomes zero. So when the velocity becomes zero, the fluid rises in the tube. So how much fluid rises in the tube will give you the value of dynamic pressure. So if we apply Bernoulli equation between 1 and 2, point 2 is having zero velocity and point 1 is having velocity V, we can easily find out the velocity of the flow. Right? This is, let us say, point 1. This is, let us, point 2. V2 is equal to 0. This is V. V1 is equal to V. And Z1 is equal to Z2 because the points are very close to each other. Z1 is equal to Z2. If you attach U to manometer, there is the manometric fluid deflection X. This is the specific gravity of manometric fluid. This is the specific gravity of flowing fluid. So if we apply the Bernoulli equation between 1 and 2 and the pressure equation between 1 and 2, then we will get, this is the manometric fluid deflection. Then we can write velocity to be coefficient of velocity into under root of 2gh. This is the formula where h is equal to P2 minus P1 by rho g. H is equal to P2 minus P1 by rho g. P2 is more compared to P1. And that is equal to x into Sm by Sf minus 1. Zero velocity इसलिए होगा, ध्यान दीजिए, this is the pitot tube, that is the inlet of the pitot tube. When the fluid is coming, then this pitot tube will restrict the flow. The fluid will strike on the tube. When the fluid will strike on the tube, the velocity will become zero. किसी भी flow के path में, if there is a restriction, if you put your hand in the fluid flow, then the fluid particles striking your hand will have zero velocity. The velocity will become zero after striking. All the kinetic energy will get converted into pressure energy. Here you will feel more pressure compared to other side. When the fluid is moving, the pressure on the other side will be less. The pressure on this side will become more because the kinetic energy becomes converts into pressure energy, right? But फिर उसके बाद क्या होगा? This pitot tube will act like a piezometer. Velocity zero होने की वजह से pressure बढ़ जाएगा, and then this tube will act like a piezometer. Here the pressure is P atm. Here the pressure is P2, which is large than P atm. Then due to pressure difference, the fluid will rise like this. So this is H. This is H. जितना fluid rise करेगा, that can be calculated. P2 is the stagnation pressure. Velocity of flow बता रहा है वो. Velocity of flow. It is used to find out the velocity of the flow. Dynamic pressure. To find out the speed of the aeroplane. To find the speed of the speed boats. Velocity find out करता है. किस स्पीड से एरोप्लेन मूव कर रहा है. relative velocity between air and the aeroplane. That is what it tells. Right? अगर एनर्जी इक्वेशन अप्लाई करेंगे P1 1 और 2 में, तो वी विल गेट P1 by rho g plus V1 square by 2g is equal to P2 by rho g. स्टैटिक प्रेशर प्लस डायनेमिक प्रेशर इज इक्वल टू स्टैग्नेशन प्रेशर हेड. तो यहां से V1 स्क्वायर बाई 2g will be equal to P2 minus P1 by rho g, and that is equal to H. यहां से V की वैल्यू आएगी. CV represents the coefficient of velocity for actual velocity, because when we apply Bernoulli equation we do not consider the loss. Bernoulli equation apply करते time we do not consider the loss. बट बाहर भी फ्लूइड एयर भी अगर ब्लो कर रही है तो फिर वो स्पीडोमीटर नहीं मेजर कर पाएगा. स्पीडोमीटर सिर्फ एरोप्लेन की स्पीड मेजर कर रहा है, ये रिलेटिव वेलोसिटी को मेजर कर रहा है. द रिलेटिव वेलोसिटी. एयर भी तो ब्लो कर रही होगी. With respect to the aeroplane, the air velocity it measures. Right? So these are the instruments which uses Bernoulli equation in their working. Can you solve this question? Can you try solving this question? एक दो क्वेश्चन सॉल्व करेंगे, then we will move to the momentum equation. Can you give it a try? Everyone, please try to solve this one. बताइए, सॉल्व कर सकते हैं? Arrangement shown in figure measure the velocity of a gas of density 1 kg per meter cube flowing through a pipe. There is a pipe, it is a pipe. If manometric fluid is water, this is the deflection. H is the deflection of the manometric fluid. We can call it as X. X is the manometric fluid deflection. And density of flowing fluid is 1. Density of the manometric fluid is 1000. And velocity is 20 meter per second. Differential head H between two arms of manometer. Can we say V is equal to CV? CV is taken as 1 under root of 2gx Sm by, or we can write it as rho m by rho f minus 1. CV can be taken as 1. Velocity is 20 meter per second is equal to under root of 2 into 9.81 into H. H is the head 1000 by 1 minus 1. So we will get the value of H. कितना आ रहा है? What will be the value of H? What will be the value of H? In millimeter. The only unknown is H. You can easily solve it. ना 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 2.05 तो नहीं आएगा. It will not be 2.05. It will not be 2.05. Yes, it will be something around 20.3 millimeter. It will be 20.3 mm. It will be 24.4 mm. Are you getting 20.4? Something around 20.4. सुमित क्या कर रहे हैं? Anwar has given the correct answer. Yes, Abhi, Shreyas, Vinay. Sumit, please check. Samaira, well done. Good. Good, 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 good. It will be 20.4 mm. Yes. एक और क्वेश्चन करते हैं. A siphon draws water. Siphon क्या होता है? Do you know what is a siphon? This type of pipe is called a siphon. When the pipe is inserted from above, from the top, to remove the liquid, that type of pipe is called as. अरे वो एच नहीं है, यही तो. विनय, अच्छा आपका जवाब सही है. वी स्क्वायर बाई 2g. एच इज इक्वल टू वी स्क्वायर बाई 2g कर दिया. आपका जवाब गलत हो जाता विनय अगर आप वी स्क्वायर बाई 2g इज इक्वल टू एच कर दिया. आपका जवाब इसलिए सही हो गया बिकॉज डेंसिटी ऑफ द फ्लोइंग फ्लूइड इज वेरी वेरी लेस कंपेयर टू डेंसिटी ऑफ मैनोमेट्रिक फ्लूइड. अगर ये ऑयल होता और ये वाटर होता तो आपका आंसर गलत हो जाता. अगर ऑयल और वाटर होते तो आपके आंसर गलत हो जाते. राइट? आपने क्या किया? इसको हटा दिया. नहीं, आपने कैसे किया? वी स्क्वायर बाई 2g इज इक्वल टू एच से कर दिया. ये तो नहीं आएगा ना इससे. वी स्क्वायर बाई 2g इज इक्वल टू एच कर दिया क्या? नो, दैट विल नॉट गिव यू द आंसर. ये थोड़ी दे देगा. वी स्क्वायर बाई 2g से थोड़ी आ जाएगा ना. दैट इज नॉट करेक्ट. वो एच नहीं है, वो मैनोमेट्रिक फ्लूइड डिफ्लेक्शन है. एच इज द मैनोमेट्रिक फ्लूइड डिफ्लेक्शन हियर. वी स्क्वायर बाई 2g से थोड़ी आंसर आएगा. ऐसा कुछ भी नहीं करना. ऐसे ही क्वेश्चंस फ्रेम होते हैं. द एग्जाम विल बी गोइंग टू आस्क दिस टाइप ऑफ क्वेश्चन. एच इज नॉट द एच विच वी हैव डिफाइंड. H is not this. This H is different. H is given as this. This is the manometric fluid deflection. X. Actually, X is to be calculated. Right? So, if a siphon draws water from a reservoir and discharges out at atmospheric pressure, assuming the ideal fluid, and the reservoir is large. When the reservoir is large, velocity will be taken as 0. In case of large reservoir, velocity of flow will be taken as 0 in the reservoir. Find the velocity at point P. We need to find out the velocity at here. So what we will do? We will write the Bernoulli equation. But for that, we need to select the points. Point 1 is taken here, let us say. Point 2 is taken here. Point 1, P1 is equal to P80m. Yes or no? Because it is on the free surface. P2 is also P80m. Z1 and Z2 will be decided by the reference line. Any horizontal line can be taken as the reference line. So in that case, Z1 is equal to minus H1. Here Z2 will be equal to minus H2. Why it is minus H1 and minus H2? Because the points are taken below the reference line. When the points are below the reference line, they will have negative potential energy. When the points lie on the reference line, they will have zero potential energy. When the points lie above the reference line, they will have positive potential energy, right? And V1 is equal to 0 because area is large. So velocity of flow in the reservoir is 0. V2 unknown. If we apply the Bernoulli equation between 1 and 2, what is the value of V2? P1 and P2 will get cancelled out. Z1 is equal to minus H1 is equal to Z2 is minus H2 plus V2 square by 2G. Isn't it? That is the Bernoulli equation. If we apply Bernoulli equation between 1 and 2, yes, points are lying below the reference line. We can take any horizontal line and call it as reference line. I am calling this horizontal line as reference line because the points are lying below. So what is V2? V2 is under root of 2G H2 minus H1. Yes or no? V2 is. But we are not interested in V2. We are interested in velocity at point P. Then apply the continuity equation. So we can say AP Vp is equal to A2 V2. That is the discharge remains constant for steady flow, steady and incompressible flow. And we can say Vp is equal to V2. That is under root of 2G H2 minus H1. Why? Because AP is equal to A2 is constant. The area of the siphon is constant. So that is why the velocity at point P will be same as velocity at point 2. The answer will be under root of 2G H2 minus H1. Under root of 2G H2 minus H1. Well done. Area same hai. But why did not we take point P for applying the Bernoulli equation? What is the reason of not taking point P? Because the pressure at P is unknown. Velocity at P is unknown. Two unknowns. We will not be able to get two unknowns from one equation. That is why we avoid taking the point P. We cannot find out the pressure at P because neither hydrostatic law nor Pascal law will be applicable at point P. Point P is in the flowing fluid. That is why we avoid taking the point P and we will apply the Bernoulli equation between 1 and 2. Right? एक और क्वेश्चन करेंगे, then our Bernoulli equation will be over. One more question. इसका आंसर बताइए. Now your turn. आप लोग बताइए. Tell me the answer for this. Can you guys give it a try? जब मल्टीपल फ्लूइड्स होते हैं तो हाउ टू प्रोसीड? What is the answer? Everybody, please try to solve it. अब थकान होने लगी. It is 6:36. अब थकने लग गए. Good evening, study with Kailash Jarwa. वेलकम. कर सकते हैं इस क्वेश्चन को. देखिए इसमें क्या है. There are multiple fluids. This is row 2, this is row 1. Because of the multiple fluids, the analysis will be slightly different. हरी सिंधु खत्म करने की बात कर रहे हैं क्या? 9 बजे से पहले करने की कोशिश करेंगे. 9 बजे से पहले, बिफोर 9. 7 o'clock तक हम आइडियल फ्लो को खत्म कर देंगे along with the momentum equation, और उसके बाद रियल फ्लो में एंटर कर जाएंगे. राइट? देखिए ध्यान दीजिए. when I write P by rho G plus Z plus V square by 2G, ये जो बर्नौली इक्वेशन है in terms of head, this equation is in terms of flowing fluid head, isn't it? This equation is in terms of flowing fluid head. Yes or no? All the parameters are in terms of flowing fluid head. P by rho G is the static pressure head in terms of flowing fluid. Z is the potential energy head in terms of flowing fluid. V square by 2G is the kinetic energy head in terms of flowing fluid. And what is the fluid which is flowing? Which fluid is flowing, rho 1 or rho 2? Which is flowing, rho 1 or rho 2? The opening is in rho 2. So rho 1. So which fluid is flowing? Isn't it rho 1? Isn't it rho 1? Yes. So all the terms should be taken in terms of, all the parameters should be taken in terms of head of the flowing fluid, rho 1, in terms of rho 1. Now try to understand. अगर मैं एक पॉइंट यहां लेता हूं, if I take point 1 here, what is P1? 0. What is Z1? If this is the reference line, let us say, if this line is the reference line, Z1 is 0 and V1 is to be calculated. Yes or no? P1 is 0, Z1 is 0, V1 needs to be calculated. But because there are two fluids and we want the head in terms of rho 1, so what we can do, we can convert this rho 2 in terms of rho 1, conversion of one fluid column into another. So the height will be somewhere like this. This can be written as rho 2 H2 by rho 1, isn't it? The free surface, the rho 2 fluid can be converted into rho 1 by using the concept of conversion of one fluid column into another. So the free surface will be at a height. If rho 2 is replaced by rho 1, then the height of the fluid will be rho 2 H2 by rho 1. Yes or no? So if we take point 2 here, then P2 will be equal to 0, V2 is equal to 0, and what is Z2? Z2 will be this height from the reference line. Yes or no? So Z2 will be equal to H1 plus rho 2 H2 by rho 1. If you are writing this Z2 correctly, then you will get the correct answer, otherwise not. That is one method. Then if we apply the Bernoulli equation, P1 by rho G, V1 square, so we can say V1 square by 2G is equal to V1 square by 2G, the velocity head in terms of flowing fluid. Then we will be writing H1 plus rho 2 H2 by rho 1, or V1 is equal to 2G. If we take H1 common, then 1 plus rho 2 H2 by rho 1 H1 and under root. Yes or no? Convert rho 2 in terms of rho 1. Conversion of one fluid column into another. This will be the answer. Clear? Yes, converted into single fluid, but which fluid? That is also a question. Rho 2 is converted into rho 1 or rho 1 is converted into rho 2. So it is in terms of flowing fluid. So the entire fluid should be flowing fluid. The entire fluid should be rho 1. So rho 2 must be converted in terms of rho 1. Are you getting it? Why we are converting rho 2 only? Why not rho 1? Because rho 1 is the flowing fluid and our equation is in terms of flowing fluid head. So that will give you the answer. कौन सा है? बी है क्या? It is option B. This is how multiple fluids are analyzed. This is how multiple fluids will be analyzed. I hope it is clear. So this completes our Bernoulli equation. Anybody is having any doubt? आप ऐसे भी कर सकते थे. क्या कर सकते थे? अगर पॉइंट यहां लेते 2, अगर ये पॉइंट यहां लेते तो आप बोलते Z2 इज इक्वल टू 0, आप बोलते V2 इज इक्वल टू 0. P2 को आप लिखते ρ2GH2 प्लस ρ1GH1. Yes or no? P2 would have been written ρ2GH2 plus ρ1GH1. But क्योंकि the head must be in terms of flowing fluid, so divide by ρ1G. If you divide this by ρ1G, then this is the pressure at point 2 in terms of flowing fluid. Divide by ρ1G will get the pressure head. अगर इसको इक्वेट करते, ये पॉइंट 1 था, P1 0 है, Z1 0 है, V1 इज अननोन. इन दोनों में अगर बर्नौली इक्वेशन लगाते, then also you will get the same answer B. Then also you will get the same answer B. So always take care when there are multiple fluids, and multiple fluids are nowadays in for the GATE exam. Nowadays, the simple questions are not asked. They slightly twist the question by introducing multiple fluids in the same concept. So if there are multiple fluids, that is how the Bernoulli equation must be applied. I hope it is clear. Now, the momentum equation for ideal flow, momentum equation. What is momentum equation? Net force is equal to rate of change of linear momentum. Net force is equal to rate of change of linear momentum. That is momentum equation or Newton's second law. What is momentum equation? It is nothing but Newton's second law. It is Newton's second law. Now, the fluid is our control mass. The analysis is done for the fluid, control mass or control volume. The control volume is the fluid. So we can say, if we write net force on the fluid, if we write net force on the fluid's momentum will increase. So it will be final momentum minus initial momentum of the fluid. When we write force on the fluid, then the change in momentum of the fluid will be final minus initial. And what is momentum? What is momentum? Mass into velocity. Linear momentum is mass into velocity. So we can say mass flow rate into final velocity minus initial velocity. And if we write net force by the fluid, then if the fluid is exerting a force, fluid's momentum will decrease. So then it will be initial momentum minus final momentum per second for the fluid. Or we can say mass flow rate into initial velocity minus final velocity of the fluid. So if the force is exerted on the fluid, the change in momentum of the fluid will be final minus initial. If the force is calculated by the fluid, then the change in momentum of the fluid will be initial minus final, right? Because it is a vector equation. It is vector. So it is direction specific. So we need to specify the direction in which momentum equation is applied. We need to specify the direction in which momentum equation is applied. So there are two applications of this momentum equation. One is force on the pipe bend and another is impact of jet. There are two cases which we are going to discuss. One is the force on the pipe bend or force on the fluid due to pipe bend. Now try to understand. If there is a bend in a pipe, everybody please have a look. If there is a bend in a pipe, the pressure of the fluid will exert a force which is normal and compressive. If there is a bend is in XY plane. It is in a horizontal plane, XY plane. So the fluid will exert a force like this, normal and compressive. The inside fluid will exert a force like this. On the outer walls, the force will be exerted like this. Now, pressure on the inner walls will be less, Pi. Then pressure on the outer walls. Pi is less than P naught. If there are curved streamline, inner streamlines will have less pressure, outer streamline will have more pressure. Area on the inner walls will be less than area of the outer walls because of convergence. Ai is less than A naught. Yes or no? So the net force, so we can say Fi will be less than F naught. Yes or no? The force exerted by the fluid on the inner walls will be less and force exerted by the fluid on the outer walls will be more. So the net force exerted by the fluid on the force exerted on pipe will be having this direction. And according to Newton's third law, force on the fluid will be opposite to this. This will be the direction of the force on the fluid and this will be the direction of force on the pipe. If we talk only about the direction, inner surface will have less pressure, outer surface will have more pressure. Inner walls will have less area, outer walls will have more area. So force exerted by the fluid on the inner walls will be less, force exerted by the fluid on the outer walls will be more. So the resultant will be outward. Force on the pipe, this will be the direction. This will be the direction of force on the fluid. Isn't it? Now if we calculate the magnitude, this is our control volume. This is our control volume. Here the pressure is, this is section 1, inlet. Section 1 is inlet. Pressure at inlet is P1. So pressure force will be P1A1. This is the velocity V1. This is section 2, outlet section. Velocity at section is V2. And the pressure force will be P2A2 like this. And this is angle theta. Angle with X direction. This is XY plane. This is X direction. This is Y direction. Now, if we write force on the fluid, I have already told you this is the force on the fluid. This is force on the pipe. So, if we resolve force on the fluid into two components, this is Fx, X component of force on the fluid. This is Fy, isn't it? This is Ff. Force on the fluid. They will have two components, Fx and Fy. Fx and Fy are forces on the fluid. Forces on fluid. So if we write momentum equation in X direction, then one force on the fluid is P1A1 is in positive X direction, P1A1. Then Fx is in negative X direction. This is positive. Fx is in negative X direction minus Fx. P2A2 will have a component in X direction that is negative minus P2A2 cos theta. That is the net force in X direction is equal to, because these are the forces on the fluid. So if the forces are on the fluid, rate of change of momentum is initial minus final. Sorry. On the fluid means final minus initial. I told you. On the fluid, final minus initial, because the final momentum of the fluid will be more. Getting it? So mass flow rate into change in velocity. Final minus initial. What is final velocity? V2. but its component in x direction is v2 cos theta. Minus, what is the initial velocity? Initial velocity is v1. This is the momentum equation. Similarly, in y direction, by solving this equation, we can find out fx. Similarly, in y direction, the component of P1, A1 in y direction is 0. Then Fy will be positive plus Fy. Component of P2, A2 in y direction will be negative, P2, A2 sin theta. These are the forces is equal to mass flow rate into change in velocity, final minus initial. What is the final velocity in y direction? V2 sin theta. What is the initial velocity in y direction? Initial velocity is v1. So its component in y direction is 0. This will give you Fy. That is how we can write the momentum equation. But what we need to take care is, because the outer fluid or air, the atmospheric air is also exerting the force on the pipe wall. The atmosphere is also exerting the force on the wall of the pipe. So that should not be taken into consideration. अगर ध्यान दीजिए, dreams, this is the pipe. If the fluid is flowing from left to right, then this fluid will exert a force on the fluid like this, normal and compressive. But this fluid will exert a force on the fluid that is normal and compressive. So at outlet, the pressure force will be opposite to the flow direction. At inlet, the pressure force will be in the flow direction, isn't it? At outlet, this fluid will exert a force on the fluid which is normal and compressive. Here, sorry. So here, this fluid will exert a force on the fluid which is normal and compressive. At inlet, it will be in the direction of the flow. At outlet, it will be in the direction opposite to the flow. Yes or no? Clear or not? I hope this is clear. Yes, the pipe is continuous only. So this is, so because the atmosphere effect to be taken as 0, what is the gauge pressure for the atmosphere? It is 0. The gauge pressure at atmosphere will be 0. So P1 in this equation, P1 and P2 must be taken as gauge pressure. Must be gauge pressure. If we take P1 and P2 gauge pressure, then only the force by the fluid, the force on the fluid by the pipe band will be calculated. So P1 is the gauge pressure, P2 is also gauge pressure. Wherever we are writing P1 and P2, and what is the mass flow rate? Mass flow rate either rho A1V1 or we can call it as rho A2V2. That is the mass flow rate that remains constant because the flow is steady. So this is how momentum equation will be applied, and Fx and Fy will be calculated, and Ff will be equal to under root of Fx square plus Fy square. The resultant force will be the resultant force. This is the force on the fluid. This will be the force on the fluid. This is Fx. This is Fy. So force on the fluid, the resultant force on the fluid is equal to under root of Fx square plus Fy square. And what is this angle phi? Phi will be equal to tan inverse of Fy by Fx. This phi is angle of Fr, angle of Ff with respect to x direction. Clear? So force on the pipe will be this direction. Force on the pipe will be like this. Force on the pipe. If there is a force on the pipe will start moving in this direction. The pipe will move in this direction. So the force required to hold the pipe is same as FF. We can also call it as, this FF can also be called as force required to hold the pipe. This is same as FF. According to Newton's third law, FF is equal to FP, force on the pipe. So to avoid the motion of the pipe, FF is the amount of FF is supplied from outside. That is the force which is required to hold the pipe in position. Right? Now there is a special case. Let us talk about this special case. A horizontal nozzle discharging liquid to atmosphere. There is a nozzle converging section. This is section 1. This is section 2. Horizontal nozzle Z1 is equal to Z2. Let me assume this as Fx. This is V1. This is V2. So Fx is the force on the fluid. So if we write the momentum equation in x direction, then what we will write? We will write P1A1 plus Fx minus P2A2 is equal to mass flow rate, because it is the force on the fluid, final velocity V2 minus initial velocity V1, and P1 and P2 must be taken as gauge pressure. P2 gauge will be 0 because the fluid is discharged into the atmosphere. So Fx can be calculated as mass flow rate into V2 minus V1 minus P1 gauge into A1. If we are getting Fx as positive, then the direction is correct. If we are getting the value of Fx as negative, then our direction is incorrect. The actual direction is opposite of our assumption. The opposite direction should be opposite. The actual direction should be opposite of what we have assumed. We can assume any direction for Fx and apply the momentum equation correctly. Then the sign of Fx, the sign of n unknown will give you us whether our direction is correct or incorrect. Now impact of jet. Impact of the jet on a surface. So impact of jet on a surface means force by the fluid. So sigma F by the fluid is equal to initial momentum minus final momentum of the fluid, or we can say mass flow rate into initial velocity minus final velocity of the fluid. And from the Bernoulli equation, Z1 is equal to Z2. Z1 is before impact. This is our control volume. Z1 is this one and Z2 is this one. Z1 is equal to Z2. P1 is equal to P2 is equal to P-ATM. So V1, the magnitude of V1 is equal to V2. The velocity will remain constant. Whatever the velocity here will be same after the striking, the velocity will remain same. And this is the normal direction. So the only force is Fn. Only force is Fn, because pressure force will be 0. P1 and P2 must be taken as gauge pressure. So pressure force will be 0. The only force will be the force exerted by the jet on the surface. So if we talk about some cases, if it is a stationary normal flat plate, V is the velocity of the jet. V is the velocity of the water jet. A is the jet area. And rho is the density of the fluid. And Q is the discharge, let us say. Q is the discharge. So this is Fn. The force exerted in normal direction, this is normal. So if we write for the control volume, if we write the momentum equation in x direction, in normal direction. If we write the momentum equation in normal direction. If you write the momentum equation in normal direction, force exerted by the jet on the plate is Fn is equal to mass flow rate, mass of the fluid striking the plate per second, that is rho AB, that is the mass flow rate, into change in velocity, that will be initial minus final. Initial velocity is V in normal direction, minus final velocity is also V, but final velocity is in tangential direction. So component in normal direction will be 0. This is the expression. Right? And work done will be equal to work done or power transfer, work done per second or power transfer is equal to force exerted on the plate into plate velocity. And the plate velocity is 0 because it is stationary, so that will be equal to 0. Power transfer to the plate will be equal to 0. That is how we can write the momentum equation for the impact of jet. Fn is the force exerted by the jet on the plate. If it is an inclined plate, this is the flow direction, angle of inclination is, let us say, theta. This is the normal direction. This is Fn in normal direction. This is our control volume. Initial velocity is V. Jet velocity is V. Jet area is A. Density is rho. Discharge is Q. Final discharge Q1 here, Q2 here. The velocity will remain V. Velocity will remain V. Now, if we apply the momentum equation in normal direction, now Fn will be equal to mass of the fluid striking the plate per second, that is rho AB. That is the mass flow rate. Mass is a scalar quantity. Into change in velocity. Initial velocity is V. And what is component in normal direction? This is the normal direction. Component of V in normal direction, initial velocity. Isn't it V sine theta? Minus what is the final velocity? Final velocity is also V. But the component of final velocity in normal direction is 0. This is Fn. क्या previous slide चाहिए आपको? ये. This is the previous slide. बताइए, कुछ confusion? Mass flow rate into change in velocity, that is initial minus final. एक और पीछे. This is Bernoulli equation for ideal flow. इससे भी पीछे, इससे पीछे कहाँ है? इम्पैक्ट स्पेशल केस पे ये चाहिए आपको. हो गया? आगे बढ़े. ये समझ में आया? V sin थीटा माइनस 0. अगर मोमेंटम इक्वेशन को अप्लाई करें टेंजेंशियल डायरेक्शन में, ट्राई टू अंडरस्टैंड. इफ यू अप्लाई द मोमेंटम इक्वेशन इन दिस डायरेक्शन, दिस इज टेंजेंशियल डायरेक्शन. So in tangential direction, force will be 0. Why force will be 0? Because it is ideal flow. So tangential force is always 0. If we apply the momentum equation in tangential direction, force will be 0. Is equal to rate of change of linear momentum in tangential direction. What is the initial momentum? In tangential direction, initial momentum is equal to rho q v sin rho qv. Rho qv is the initial momentum, but the direction is this. Its component in tangential direction will be equal to cos theta. That is the initial momentum. What is the final momentum? Q1 is going in this direction, Q2 is going in this direction. So final momentum is rho Q1 minus Q2 into V. This is the momentum equation in tangential direction. Initial momentum in tangential direction minus final momentum. So from here we can say Q1 minus Q2 is equal to Q cos theta. And we know Q1 plus Q2 is equal to Q. From these two equations, we can find out Q1 is equal to Q by 2, 1 plus cos theta, and Q2 is equal to Q by 2, 1 minus cos theta. Or we can say the ratio of Q1 by Q2 is equal to 1 plus cos theta upon 1 minus cos theta. And what will be the power transfer? Power transfer will be 0 because the plate is still stationary. Power transfer will be 0. जब भी टेंजेंशियल डायरेक्शन में मोमेंटम इक्वेशन अप्लाई करेंगे, फोर्स विल बी टेकन एज 0 because it is an ideal flow. So the tangential force will not be taken into consideration. For ideal flow, the force will be taken as 0. The force will be taken as 0. Right? अगर इसमें थीटा को 90 कर दिया जाए, if we make theta is 90, then all the formula will become same as the previous case. Here, if we apply the tangential direction, this is Q1, this is Q2. So we can say according to symmetry, Q1 is equal to Q2 is equal to Q by 2 each. Symmetry, or we can say by applying the momentum equation in tangential direction. Yes, the discharge entering should be equal to discharge leaving. That is continuity equation. Whatever the discharge entering into the control volume is equal to discharge leaving. Q1, Q is equal, this is the discharge entering, Q is equal to Q1 plus Q2 everywhere from the continuity equation. The discharge entering is Q. The discharge leaving is Q1 and Q2 from the control volume. Rho is constant throughout. Because if it is symmetrical plate, it is symmetrical. So that is why Q1 and Q2 will be equally distributed. Q1 is equal to Q2 by 2, or we can say A1 is equal to A2 is equal to A by 2, because velocity is constant. There is no change in velocity. So this area and this area will be half of this area. A1 and A2, this is A1, this is A2. The area of the jet A1 and A2 will be half of A. Area will get distributed. Clear? कोई confusion, कोई doubt हो तो बताइए. So if theta is taken as 90 degree for normal plate, then all the formula will modify to the previous case. Now for a curved plate, if it is symmetrical, symmetrical means beta 1 is equal to beta 2 is constant. That is beta. This angle is also beta, this angle is also beta. This is the normal direction, Fn. This is normal direction. So if we apply the momentum equation in normal direction, the force exerted Fn will be equal to mass flow rate, rho AV, into change in velocity. What is the initial velocity? Initial velocity is V in normal direction. So V minus what is the final velocity? Final velocity is also v. There is no change in the velocity. So its component in normal direction is v cos beta, isn't it? But it is in negative direction. So final velocity will be minus v cos beta. Final velocity is minus v cos beta. Momentum flow rate होता है rho into q into v. That is the momentum flow rate. Mass flow rate into velocity is momentum flow rate. विनय, v भी तो आएगा. That is the momentum flow rate. That is nothing but m dot into v. Rho qv is the momentum flow rate. So momentum change लिख रहे हैं ना, इसमें momentum change लिख रहे हैं ना. So rho qv cos theta ही तो होगा. Rho qv is the momentum flow rate. और ये इसका डायरेक्शन ये है, इसका कंपोनेंट हमें इस डायरेक्शन में चाहिए तो कॉस कंपोनेंट आएगा. Rho qv cos theta. Rho qv is the momentum. Rho qv is the momentum per second. Do you understand? This is Fn. And from the symmetry, Q1 is equal to Q2. Because this angle is also beta, this angle is also beta. So Q1 is equal to Q2 is equal to Q by 2. It will become 1. It will become plus. So Fn is equal to rho a v square 1 plus cos beta. This is Fn. Force exerted on the curved plate. हाँ, ये थीटा भी तो हॉरिजॉन्टल है ना. ये एंगल थीटा हो चाहे ये एंगल, एक ही बात है ना. थीटा with normal x direction. This angle is given as theta. So this angle is also theta. Right? Traversing dreams. So angle of the inclined plane is with the initial flow direction. This is the initial flow direction. Angle is with the initial flow direction. Here also theta is with initial flow direction. This is beta is this angle beta. Now, if it is a moving plate, the velocity of the plate is, let us say, u. The plate is moving with the velocity u. So we will talk about the relative velocity because the control volume is also moving. So to calculate the force Fn, we will sit on the control volume. So the mass of the fluid striking the plate per second is rho a v minus u. V is greater than u. So mass of the fluid striking will be rho a v minus u into change in velocity. Initial velocity is v minus u, relative velocity. Final velocity is also v minus u, but the direction is tangential. So initial velocity is v minus u, final velocity will be 0. This will be the expression. Or Fn is equal to rho a v minus u whole square. That is the force. And what is the work done? That is Fn into u. That will be the power transfer. This will be the power transfer if the plate is moving in the direction of the flow. If the plate is moving in the direction of the flow. अगर ये प्लेट अपोजिट मूव कर रही होती u, फ्लूइड v से जाता तो Fn इस पे लग रहा होता रो a v प्लस u इंटू v प्लस u माइनस 0. ये एक्सप्रेशन होता. अपोजिट टू द फ्लो अगर प्लेट का डायरेक्शन होता. So that completes our analysis of momentum equation. Can you quickly solve this question? Can you solve this question and let me know the answer? इसको ट्राई कर सकते हैं using the momentum equation. वेन का मतलब है कर्व्ड प्लेट. Vein is a curved plate. श्रेयस, जब भी मूविंग प्लेट होगी, whenever the plate is moving, the surface is moving, so control volume is also moving. So we will write the momentum equation by sitting on the control volume or the plate. So the relative velocity comes into picture. If the plate and the fluid are moving in the same direction, then the relative velocity of the fluid is V minus U. So the mass of the fluid is striking, or mass flow rate will be rho A V minus U. And change in the velocity is V minus U is the initial relative velocity, and 0 will be the final relative velocity in the direction of the flow, in the flow direction or in the normal direction. Final velocity will also be V minus U. Final velocity will also be V minus U. But the direction is tangential. These are the relative velocity. This is initial relative velocity. This is the final relative velocity. Isn't it? This is the mass flow rate, and this is the change in relative velocity. Initial relative velocity, final relative velocity in normal direction. देखिए इस क्वेश्चन को. F is given 100 Newton. Force is already given. We need to find out the angle alpha because it is symmetrical, stationary, curved plate. So we can say this angle is also alpha. This angle will also be alpha. So if we write the momentum equation in this normal direction, if we write the momentum equation in normal direction, so we can say F is equal to mass flow rate into change in velocity. Initial velocity is V. Its component in normal direction is V cos alpha, yes or no? Final velocity is also V after striking, but its component in normal direction is again V cos alpha because this angle is alpha, this angle is alpha. So m dot into V cos alpha is the initial velocity minus final velocity is minus V cos alpha. Yes or no? Final velocity will be minus V cos alpha because the direction of final velocity is opposite, negative. Initial velocity is positive. Final velocity is negative. Final velocity is negative. So force is 100. What is the mass flow rate? 5 kg per second into 2V cos alpha. 2 into V. What is V? V is 20 cos alpha. Can you find out the value of alpha? Cos alpha is 1 by 2. Cos alpha is 1 by 2. Yes or no? What is alpha? Isn't it 60 degree? Isn't it 60 degree? Yes. Do you understand how to write the momentum equation? Initial velocity in normal direction is V cos alpha. Final velocity in normal direction is minus V cos alpha. And subtract these two. Ha, Devika. That is why if you will start memorizing these formula, it will not work. The questions will not be asked from the cases we discussed. Jaruri nahi hai. That is why you need to understand how to write the momentum equation. That is how the questions are going to be asked. You should be able to write the momentum equation on your own in any direction. That is what is required. Right? So अब तक पुराने गेट के पेपर्स में जो भी क्वेश्चंस आए हैं, most of them were not from the standard results. But these cases are only to make you comfortable with the momentum equation. That is what you need to understand. I hope this is clear. अब बताइए, what next? Shall we continue the real flow or you want to take a break? Do you want a small break before starting the real flow, laminar and turbulent? $15 minutes का ब्रेक ले लें या 10 minutes का? फिर अगले 1 घंटे में वी विल ट्राई टू कंप्लीट. 1 घंटा और मैक्सिमम 1.5 hour. ठीक है? लेट अस टेक ए ब्रेक. 10 minutes का ब्रेक लेते हैं. इन माई वॉच इट इज 22, 32, 35. 35 पे मिलते हैं. सेवन 35 पे मिलते हैं. We will meet again at 7:35, right? 15 के आसपास ही है वो. Okay, so see you after the break. हेलो एवरीवन, वेलकम बैक। थोड़ा सा लेट हो गए। शैल वी स्टार्ट द लास्ट लैप? स्टार्ट करें द रियल फ्लो। वी विल ट्राई टू फिनिश बाय 9 o'clock। ऑलराइट, चलिए स्टार्ट करते हैं। रियल फ्लो, when viscous force is not zero, that flow is called as real. When the losses are there, let's finish it. The real flow can either be laminar or turbulent. In case of real flow, viscous force exists. There is tau is not zero. Tau is not zero. Hi Hari, welcome back guys. So get ready for the last lap. We will not take any further break. We will finish it out. All right. So the nature of the real flow is decided by the Reynolds number. And what is the Reynolds number? The ratio of inertia force to viscous force. So the expression for Reynolds number is rho VL by mu. In real flow, we will be analyzing the flow which is steady and uniform. क्या मतलब होता है steady and uniform flow? Acceleration के time पे मैंने बताया था, I told you, when the flow is steady, local acceleration will be zero. When the flow is uniform, convective acceleration will be zero. So the acceleration will be zero for the real flow. There is neither any local acceleration nor any convective acceleration. Acceleration will be taken as zero. Rho is the density of the fluid. V is the average velocity. V is the average velocity of the flow, which remains constant throughout the flow. L is the characteristic length. Mu is the viscosity, or we can write it as VL by kinematic viscosity. VL by kinematic viscosity. So in real flow, first we will talk about the internal flow, flow in a pipe. Then we will be talking about the external flow, which is the flow over a plate, flow over a surface. Laminar flow is organized. Turbulent flow is disorganized. Disorganized flow is turbulent. Organized flow is laminar. Laminar is organized. Turbulent is disorganized. Internal flow, flow in a pipe. When the fluid is flowing in a pipe, we will carry these assumptions. No acceleration. Acceleration will be zero. Local and convective both. Characteristic length will be replaced by DH. That is called as hydraulic diameter, which is 4A by P. A is called as flow area and P is the wetted perimeter. When do we use hydraulic diameter? When the pipe cross section is not circular. When the cross section of the pipe is not circular, then we will calculate the hydraulic diameter. अगर pipe already circular है, if the pipe is already circular, then if we use the formula for hydraulic diameter, it will come out to be diameter of the pipe only. But if it is having some other cross section like a square, if the cross section of the pipe is square, then hydraulic diameter will be equal to side 4A by P. Perimeter is 4A, area is A square. If it is a rectangular duct, A into B, then the hydraulic diameter will come out to be 2AB upon A plus B. Hydraulic diameter. So Reynolds number is equal to, the expression for Reynolds number will be equal to rho into V into DH by dynamic viscosity or V into DH by kinematic viscosity. That is the expression for Reynolds number. For low value of Reynolds number, flow is laminar. If the Reynolds number is less than 2000, less than or equal to 2000, the internal flow will be laminar. And if the Reynolds number is greater than 4000, then the internal flow will be turbulent. Right? इक्वेशन सॉल्व करिए. Water flows through a pipe having an inner radius of 10 mm. Radius is given as 10 millimeter at the rate of 36 kg per hour. What is this? This is the mass flow rate. Kg per hour is the unit of mass flow rate. Right? The viscosity of water at 25 degrees Celsius is 10 to the power minus 1 Pascal second. 10 to the power minus 3.001. What is the Reynolds number of the flow? रेनॉल्ड नंबर क्या होता है बताइए, इसको सॉल्व करके बताइए. रेनॉल्ड नंबर इज रो इंटू वी इंटू डी बाई म्यू. रो इज नॉन, म्यू इज नॉन. नाउ मास फ्लो रेट इज इक्वल टू रो इंटू एरिया पाई बाय 4 डी स्क्वायर इंटू वेलोसिटी इज इक्वल टू 36 kg पर आर. आर को सेकंड में कन्वर्ट करेंगे तो इट विल बी 3600. यहां से रो वी डी को अगर फाइंड आउट करें, सो रो वी डी इज इक्वल टू 4/100 पाई इंटू डायमीटर. यस और नो? अगर ये वैल्यू यहां पे पुट कर देंगे रो वी डी, सो रेनॉल्ड नंबर इज इक्वल टू 4/100 पाई डी इंटू डायनेमिक विस्कोसिटी. डायनेमिक विस्कोसिटी क्या वैल्यू आएगी? 4/100 पाई. डायमीटर कितना होगा? रेडियस अगर 10 mm है तो डायमीटर होगा 20 mm. सो इंटू 20 इंटू 10 to the power minus 3 इंटू विस्कोसिटी 0. और 10 to the power minus 3 0.001. What is the value of Reynolds number? So Reynolds number will come out to be 636.96 something. 636.9. Yes. Which is less than 2000. So laminar flow 636.94. Yes, correct. So the flow will be laminar. Reynolds number will be 636.9. Clear? ये मास फ्लो रेट गिवन है, मैंने पहले भी आपको बताया था. द यूनिट विल टेल अस whether it is the volume flow rate or mass flow rate, because kg per hour is the unit, that is means it is mass flow rate, density into discharge. The next question, there are two pipes of uniform section but different diameters. D is variable, carry water at the same flow rate. Q is constant. Q is constant. Density is constant, so discharge will be constant. Flow rate, whether it is mass flow rate or volume flow rate, discharge will be constant. Water properties are same. It means density and viscosity are same. The Reynolds number based on pipe diameter will. So we will develop the Reynolds number as a function of diameter. What is the answer to this one? The Reynolds number will be same in both pipes, large in narrow pipe or small in narrow pipe, or depends on pipe material. Reynolds number does not depend on pipe material. What is the expression for Reynolds number? Rho V D by mu. No parameter is related to the material of the pipe. Reynolds number does not depend on the pipe material, right? Density is constant, viscosity is constant, properties are constant. So Reynolds number is proportional to V into D. But V is variable. Why? Because Q is constant. Q is equal to pi by 4 D square into V is constant. So V is inversely proportional to diameter square. And if V is inversely proportional to diameter square, Reynolds number is proportional to 1 by D square into D. So Reynolds number is inversely proportional to diameter. For the constant discharge, for the constant flow rate, Reynolds number is inversely proportional to diameter. So as the diameter decreases, Reynolds number increases. Yes or no? So it will be large. The value of Reynolds number will be large in narrow pipe. The Reynolds number will be large in narrow pipe. B होगा ना? It will be B. यहां से D को नहीं. Reynolds number is not proportional to diameter. Velocity will also be variable if the flow rate is constant. C नहीं होगा. It will not be C. It will be B, isn't it? That is how you need to develop the correct relation. The relation should be correct. I hope this is clear. Numerical भी frame हो सकता है. If the diameter is twice, then the Reynolds number will become half. ये बेसिक माइन्यूट चीजों को आपको ध्यान रखना है. That is where students commit the silly mistake. They directly see the formula and develop the relationship. Please remove those parameters which are constant and develop a relation. Now for the real flow, if we apply the continuity equation between 1 and 2, so we will say Q is equal to A1 V1 is equal to A2 V2 remains constant. Why it is constant? Because the flow is steady. And from here we can say V1 is equal to V2 is equal to constant. That is the average velocity. Because A1 is equal to A2. Because the flow is uniform also. There is no change in area. For a steady and uniform flow, velocity will remain constant. If we apply energy equation, P1 by rho g plus Z1 plus V1 square by 2g is equal to P2 by rho g plus Z2 plus V2 square by 2g plus head loss due to friction. V1 and V2 will be equal from the continuity equation. So HL will be equal to P1 by rho g plus Z1, piezometric head at 1 minus P2 by rho g plus Z2, piezometric head at 2. If we write this as delta PL by rho g, because it is the drop in piezometric pressure. So HL will be equal to delta PL by rho g. Delta PL is the piezometric pressure difference between 1 and 2. That is how we can develop the expression for HL. HL is the frictional head loss, right? That is the energy conservation equation in the flow direction. The flow direction is from 1 to 2. Right? And if we apply the Darcy-Weisbach equation, this is the direction of the flow, this is 1, this is 2. According to Darcy-Weisbach equation, HL is FLV square by 2GD. Or we can write it as FLQ square upon 12.1 D to the power 5. And that is equal to delta PL by rho g. Where F is the friction factor. F is equal to 4 times of friction coefficient. 4 times of friction coefficient is tau naught by rho v square by 2. This is friction factor. कई बार क्वेश्चन में फ्रिक्शन कोएफिशिएंट भी दिया होता है. This is F dash is called as friction coefficient. L is the pipe length between 1 and 2. This is the length of the pipe between 1 and 2. V is the velocity of the flow, average velocity of the flow. D is the diameter of the pipe. If the pipe is not having the constant or the pipe is not circular, then D will be replaced by PL is the pressure drop, pressure loss. The piezometric pressure will decrease in the flow direction to compensate the loss. यहाँ पे piezometric pressure will decrease in the direction of the flow to compensate the loss. So delta PL is the piezometric pressure drop. Piezometric pressure drop or piezometric pressure loss in the flow direction, right? Dreams? So this Darcy-Weisbach equation is valid for laminar as well as turbulent flow both. To find out the frictional head loss, the flow must be steady and uniform. This is the formula. So these are the 3 equations to be applied to find out this. Pressure decreases linearly. So pressure is a linear function of x. X is the direction of flow. Linear. तो उस केस में dp by dx will be constant and negative. dp by dx, pressure gradient will be constant, negative constant. Pressure gradient will be negative constant. X is the flow direction. And P is the piezometric pressure. Piezometric pressure. The piezometric pressure will decrease linearly in the flow direction to compensate the energy loss. क्योंकि velocity constant है, there is no change in. Yes, Sumit? Darcy-Weisbach equation, Yeri. This is called as Darcy-Weisbach equation. To find out HL. Now we will talk about the laminar flow. I will write the formula for laminar flow. These are the equations which are valid for laminar and turbulent both. The equation I have mentioned are valid for laminar and turbulent both flow. If the flow is laminar, for laminar flow in pipe, when the Reynolds number is less than 2000, velocity profile कैसा होगा? U is equal to, अगर dp by dx नेगेटिव है, नेगेटिव कांस्टेंट है, so minus dp by dx can be written as delta PL by L. That is constant. Minus dp by dx. It is a function of x only. Right? So U is given by U maximum 1 minus R square by capital R square. That is parabola. The velocity profile is parabolic, where U maximum is equal to 1 by 4 mu delta PL by L into R square. This is maximum velocity. आवाज आ रही है बाकी लोगों को? थिक स्किन बोल रहे हैं, एम आई ऑडिबल और नॉट? इज माई वॉइस क्लियर? द नेक्स्ट फॉर्मूला इज एवरेज वेलोसिटी is twice of maximum velocity, that is equal to 1 by 8 mu delta PL by L into R square. Third formula, discharge is equal to pi by 4 into d square into average velocity. तो ये बन जाएगा pi by 8 mu delta PL by L into R to the power 4. Shear stress का जो फॉर्मूला है माइनस म्यू इंटू डी यू बाई डी आर, म्यू इंटू डी यू बाई डी वाई, और डी यू बाई डी आर की वैल्यू पुट करेंगे यहां से डी यू बाई डी आर पुट करेंगे तो ये बन जाएगा 2 म्यू यू मैक्सिमम आर बाई कैपिटल आर स्क्वायर. इट इज लीनियर, द वेरिएशन ऑफ शियर स्ट्रेस विल बी लीनियर. और यू मैक्सिमम की वैल्यू पुट कर देंगे तो ये बन जाएगा डेल्टा पी एल बाई एल इंटू आर बाई 2. And at R is equal to capital R, that means the center line. At the center line, tau is maximum, that is tau naught. So tau naught can be written as 2 mu u maximum by R. Tau naught is 2 mu u maximum by R. It is linear. Tau is a linear function of R. These are important formula which are applicable to laminar flow in a pipe. Average velocity is half of maximum velocity. Sorry, average velocity will be half. Correct. U maximum by 2. Yes, correct. Average velocity is half of maximum velocity. उसके बाद the next formula, delta PL. We can calculate delta PL from this 32 mu V average L by D square. कहां से मिला ये? V average के फॉर्मूले से. That is 1 by 8 mu delta PL by L into R square. R can be written as D by 2. R can be written as D by 2. So that is called as Hagen-Poiseuille equation. Hagen-Poiseuille equation, delta PL. उसके अलावा there is a parameter defined that is called as shear velocity, under root of tau naught by rho. That is under root of F by 8 into V average. Shear velocity. And from here, F is equal to 64 by Reynolds number. That is equal to 8 tau naught upon rho V square. That is 4 times of friction coefficient. These are the formula which you remember for laminar flow. हाँ, इसको Poiseuille flow बोल सकते हैं. We can call it as Poiseuille flow. What is delta PL here? अगर फ्लो का डायरेक्शन 1 से 2 है, so delta PL will be equal to P1 plus rho G Z1 minus P2 plus rho G Z2. P1 shear velocity एक hypothetical concept है. Shear velocity is given by under root of tau naught by rho. That is a hypothetical concept. So it gives the relation between the flow velocity and the velocity due to the relative motion between the layers. So these are the formula. So ये laminar flow के लिए valid है. There are some common formula. One is Q is equal to area into average velocity. दूसरा formula HL is equal to FL V square by 2GD और FL Q square upon 12.1 D to the power 5 or that is equal to delta PL by rho G. These are the common formula. Third is tau is equal to delta PL by L into R by 2. This is valid for laminar as well as turbulent. Fourth one is shear velocity. That is under root of tau naught by rho is equal to under root of F by 8 into average velocity. That is called as shear velocity. ये common formula है जो laminar और turbulent दोनों के लिए applicable होंगे. Laminar plus turbulent. These are the common formula. ये फॉर्मूला मास कंजर्वेशन से मिला, कंटिन्यूटी इक्वेशन से. ये एक्सप्रेशन बनता है डार्सी-वासबैक इक्वेशन एंड एनर्जी इक्वेशन से. ये फॉर्मूला मिलता है मोमेंटम इक्वेशन से. सो दे आर वैलिड फॉर लैमिनार एज वेल एज टर्बुलेंट. जब वेलोसिटी के बारे में कुछ नहीं मेंशन किया हो तो एवरेज वेलोसिटी लिया करते हैं. If nothing is given regarding the velocity, then we take the average velocity. V is the average velocity. और अगर velocity किसी particular location R पे find out करनी है, that means the local velocity. Right? shear stress variation is linear in radial direction. अगर velocity profile बनाए, laminar flow के लिए velocity profile बनाए, तो velocity profile will be parabola, maximum velocity is at the center. और अगर shear stress variation बनाए, so it will be linear. Maximum is at the pipe wall and zero will be at the center. Yeah, shear stress variation is linear. Minimum is at center 0 because R is equal to 0. And maximum is at wall of the pipe. Like this. ये बनेगा. Right? These are common formula which are valid for laminar and turbulent. So there is a question on the screen. Try to solve this one. जो भी formulae लिखे मैंने, they are valid for fully developed flow. When velocity is a function of R only, that is called as fully developed. When the flow becomes fully developed, whether it is mentioned in the question or not, the flow is always treated as fully developed. A fluid, viscosity is this, density is this, flows with an average velocity of 1 meter per second through a long duct of rectangular cross section. The duct is having rectangular cross section, so we will calculate hydraulic diameter. Right? That is 4A by P. So 2 into AB upon A plus B. We find out this is A, this is B. Rectangular cross section है तो hydraulic diameter calculate करेंगे पहले. And delta PL will be equal to, because it is laminar, so we can use Hagen-Poiseuille equation, 32 mu V average L upon D square. D will be replaced by DH. कितना आएगा आंसर? You will get it as, put the values, you will get the answer. Viscosity is given, average velocity is given, length is, the question is to find out per meter length. Length is equal to 1 meter. And DH can be calculated from here. Put all the parameter in their SI unit, then only you will get the pressure drop in SI unit. Your answer should be 1.82 Pascal or Newton per meter square. The pressure drop 1.82. Are you getting it? Is this clear? The next one. Consider a fully developed steady laminar flow of an incompressible fluid with viscosity mu through a pipe of radius capital R. The radius of the pipe is capital R. Given that the velocity at a radial location of R by 2 from the center line of the pipe is U1. The shear stress at the wall, that means tau naught. Shear stress at the wall is tau naught is given by K mu U1 by R. What is the value of K? What is the value of K? फॉर्मूला बेस्ड क्वेश्चन ही आएंगे सुमित. तो टॉ नॉट का जो एक्सप्रेशन है वो होता है 2 म्यू यू मैक्सिमम बाई आर, बट यू मैक्सिमम शुड बी रिप्लेस बाई U1. सो व्हाट इज द वेलोसिटी प्रोफाइल? U इज इक्वल टू यू मैक्सिमम इंटू 1 माइनस आर स्क्वायर बाई कैपिटल आर स्क्वायर एट R is equal to R by 2. U is equal to U1. So if we put the values here, so U1 is equal to U maximum into 1 minus small r is capital R by 2. So it will be capital R square by 4, 1 by 4. So U1 is equal to 3 U maximum by 4. Yes or no? So we can say U maximum is equal to 4 by 3 U1. If you put this value here, then tau naught will come out to be 2 mu by R, 2 mu by R into 4 by 3 U1. So it will become 8 by 3 mu U1 by R. If we compare these two, then your answer for K is equal to 8 by 3. The answer will be 8 by 3. Yes. Eight by 3. Clear? Now the power transmission through pipe. Power क्या होता है? Energy per unit time. Energy per unit time is power transfer. Energy per unit time. So power transmission through pipe will be V is the velocity of flow in the pipe. The length of the pipe is, let us say, L. L is the length of the pipe. So power होगा, energy is mgh by T. M by T is mass flow rate into G into H. Mass flow rate को लिख सकते हैं rho into Q into G into H. So power transmitted through pipe is given by rho into Q into G into H. If we talk about actual power transmitted, there will be energy loss. There will be loss. So this will be H minus HL. The actual power transfer by the pipe is equal to rho QG H minus HL. Power required to maintain the flow, that is power loss. That will be power loss. So power loss will be equal to rho into Q into G into HL. And the value of HL minimum is equal to H by 3. So the minimum power required to maintain the flow will be equal to rho QG, or HL can be written as delta PL by rho G. So Q into delta PL. Pump power required to rise the fluid to height H. Power given to the pump is equal to rho QG H plus HL. Extra power will be given to the pump so that the fluid rises to the height H. So loss will be taken into consideration. And for minimum pump power, we will put HL is equal to H by 3. Minimum value of HL is H by 3. So efficiency of the pipe is theoretical power. This is theoretical power. This is theoretical power transmission. Actual power will be theoretical minus power loss. P theoretical minus P loss. That is actual power. Differentiate करने पे आएगा इसको अगर differentiate करें. If we want to have maximum power transmission. So if we differentiate, ये कैसे मिला? If dP actual by dV and put it as 0 for actual power to be maximum. That is the condition we will be getting. For maximum power transmission, HL will come out to be H by 3. Right? Minimum value of HL will be H by 3. Right? Height, traversing dreams. Value of HL, minimum value of HL will come out to be H by 3 when you differentiate this power with respect to velocity. Q is having the velocity, area into velocity. HL is also having the velocity, FLV square by 2GD. Differentiate with respect to velocity and put it as 0. Then you will get minimum value of HL. This is the minimum possible value of loss in the pipe. So efficiency of the pipe can be defined as the ratio of actual power to the theoretical power, that is H minus HL upon H. That is the pipe efficiency. That will be the efficiency of the pipe. Next, hydraulic gradient line and total energy line. Hydraulic gradient line is the line joining piezometric pressure heads. Piezometric pressure is static pressure head plus potential energy head. The line which joins these points is called as hydraulic gradient line. And the total energy line or energy gradient line, the line which is joining the total energy head, that is static pressure head plus potential energy head plus kinetic energy head. So we can say EGL minus HGL is equal to V square by 2G, velocity head. EGL minus HGL will be equal to V square by 2G. So if we draw hydraulic gradient line for a pipe, if there is a fluid flowing from left to right, this is point 1, this is point 2. If we draw, this is the datum line, this is Z1, this is Z2. P1 by rho G is this. This point represents the piezometric head at 1. This point represents the piezometric head at 2. And piezometric head decreases in the flow direction to compensate the loss. This is HGL. And if we add V square by 2G, because V1 is equal to V2, according to continuity equation. So that is why the EGL or total energy line will shift above. So they are parallel lines. HGL and TEL will be parallel. And the difference of HGL and EGL will be V square by 2G. V1 is equal to V2. These are the lines to be drawn. HGL and TEL. So HGL can rise, pressure can increase in the flow direction, but the total energy line will never rise. The total energy of the fluid always decreases in the flow direction. HGL क्या होता है? Hydraulic gradient line is the line which joins the piezometric pressure heads. Point 1 पे piezometric pressure head कितना होगा? Static pressure head, potential energy head, that is Z1 plus static pressure head, that is P1 by gamma or P1 by rho G. This point represents the hydraulic gradient line at 1. Because the velocity remains constant, V1 is equal to V2 because the flow is steady and uniform. So piezometric pressure decrease करेगा. This point represents piezometric pressure head at 2. So the line which joins these 2 points is a hydraulic gradient line, and it is linear because dP by dx is constant. The slope of this line is constant. That is why it is a straight line, right? और इसी में अगर kinetic energy head और add कर देंगे V square by 2G, then the point will reach here. V square by 2G इसमें add कर देंगे, point will reach here. This line is EGL or total energy line TEL. राइट ये है HGL एंड TEL. तो मैंने पहले भी आपको बताया, इन द फ्लो डायरेक्शन द प्रेशर कैन इंक्रीज, द प्रेशर कैन डिक्रीज, बट द टोटल एनर्जी ऑफ द फ्लूइड ऑलवेज डिक्रीजेज इन द फ्लो डायरेक्शन टू कंपनसेट द लॉस. इसलिए टोटल एनर्जी लाइन हमेशा डिक्रीजिंग होगा. HGL इंक्रीज कर सकता है, प्रेशर कैन इंक्रीज इन द फ्लो डायरेक्शन, राइट, अनलेस देयर इज एन एक्सटर्नल एनर्जी सप्लाई. पंप के केस में EGL भी राइज करेगा बिकॉज वी सप्लाई एनर्जी फ्रॉम आउटसाइड थ्रू पंप. That is why EGL will also increase. But otherwise in the flow, the total energy line will never rise, or the total energy of the fluid never increases in the flow direction, but the pressure energy can increase in the flow direction. That is possible. So कई लोगों को यह गलतफहमी रहती है कि flow always takes place in the direction of decreasing pressure. That is incorrect. The flow always takes place in the direction of decreasing total energy of the fluid, not the pressure. Pressure does not decide the flow direction. It is the total energy of the fluid which decide the flow direction. Right? Then the losses, energy loss. There are two types of losses. One is major energy loss. Major energy loss, which is due to friction and which is calculated by Darcy-Weisbach equation. So HL is equal to FLV square by 2GD or FLQ square upon 12.1 d to the power 5 is equal to delta PL by rho G. That is HL. And there are some minor losses. Why do we call them minor losses? Because major loss is having a contribution greater than 95%. Minor losses are having contribution less than 5%. Minor losses तभी analysis में consider करेंगे when the question asks to consider. Otherwise, we will ignore the minor losses. Otherwise, we will ignore the minor losses. So minor losses are due to sudden expansion, sudden contraction, bend in a pipe. There are fittings or any obstruction in the pipe. Then there will be some minor energy losses. HL is the frictional head loss in terms of flowing fluid. So अगर sudden expansion है, HLE due to sudden expansion. If there is a sudden expansion in the pipe like this, V1 is the velocity here, V2 is the velocity here. So sudden expansion head loss is given by V1 square, ये माइनर लॉसेस के फॉर्मूले सिर्फ याद होने चाहिए, डायरेक्टली कुछ पूछा जा सकता है. V1 minus V2 whole square by 2G. If we take V1 square by 2G common, then it will be 1 minus V2 by V1 whole square. Or we can write it as V1 square by 2G. Then it will be 1 minus A1 by A2 whole square. Because Q is equal to A1 V1 is equal to A2 V2 is constant. So V1 V2 by V1 can be replaced by A2 A1 by A2. This is expansion loss, sudden expansion. This is the sudden expansion head loss. So special case is loss at pipe exit. If we talk about pipe exit, then A2 becomes infinite. At the exit of the pipe, the flow area becomes infinite. So A1 by A2 will become 0. So in that case, the loss will be given by V square by 2G. V is the velocity of the flow in the pipe. If there is a loss at the pipe exit, will be V square by 2G. आइडियल फ्लो के लिए नितेश, आइडियल फ्लो अगर होगा तो HGL और TEL दोनों हॉरिजॉन्टल लाइंस बनेंगी. फॉर एन आइडियल फ्लो HGL एंड TEL विल बी हॉरिजॉन्टल लाइंस. राइट. But real flow के लिए HGL and TEL will have same slope and the slope is negative. Similarly, sudden expansion loss, so sudden contraction. For sudden contraction, if there is a sudden contraction, then there will be a vena contracta. This is point C. This is point 2. For the sudden contraction, there will be a vena contracta point C, and AC by A2 is coefficient of contraction CC. So the sudden contraction, due to sudden contraction, the loss can be calculated by expansion from CN2. So HLC, contraction loss, can be written as VC minus V2 whole square by 2G. और अगर V2 square by 2G कॉमन ले लें, then it will be VC by V2 minus 1 whole square. And VC by V2 can be written as V2 square by 2G. इसको लिख सकते हैं A2 by AC minus 1 whole square. And what is A2 by AC? So it will become V2 square by 2G, then 1 by CC minus 1 whole square. This is coefficient of contraction due to vena contracta. This is called as coefficient of contraction. If CC is not given, then we will take 0.5 V2 square by 2G or V2 square by 4G if CC is not given. If the coefficient of contraction is not given in the question, 1 by CC minus 1 whole square can be taken as 0.5. Special case of sudden contraction is at pipe entrance. when the fluid is entering into a pipe from a reservoir, then there will be sudden contraction. There will be a vena contractor like this. This is point C, this is point 2. The velocity of flow here is V. So the loss due to sudden contraction, this is pipe entrance. Pipe entrance. It will be V square by 4G or 0.5 V square by 2G. And the third one is pipe bend or pipe fittings. So for pipe bend, HLB is given as KV square by 2G, where K is the coefficient of bend. These are minor losses. K is coefficient of bend, which will be given. Coefficient of bend in the pipe or coefficient of obstruction in the pipe, coefficient of valve, bend or valve. So these are some of the minor losses. These are minor losses. पहला है sudden expansion loss, दूसरा है sudden contraction, and the third one is loss due to pipe bend. All the parameters are in terms of flowing fluid head, kV square by 2G. Right? The next will be compound pipe, multi-pipe system. The next will be compound pipe or multi-pipe system. Pipe can be arranged in series, pipe can be arranged in parallel. That is called as compound pipe. The flow is again steady plus uniform. The flow is steady and uniform. There are two types of compound pipe. They can have series combination, they can have parallel combination. Whenever the pipes are connected in series, discharge will remain constant. From the continuity equation, we will say Q is equal to Q1 is equal to Q2 is equal to constant. The discharge will remain constant when the pipes are connected in series. These are the pipes which are connected in series. This is Q1, this is Q2, this is Q3 and so on. So the total discharge remains constant from the continuity equation. From the energy equation, we can say the total energy head loss is equal to sum of HL1, HL2 and HL3, so on. For series combination, these are the two expression you need to remember. One is obtained by applying the continuity equation or mass conservation. Another is obtained by applying the energy conservation in the flow direction. The total energy head loss in the compound pipe is sum of HL1 plus HL2 plus HL3. Series combination का मतलब है when the pipes are connected one after another. That is called a series combination. And for parallel combination, when the pipes are sharing same junctions, inlet and outlet points, same inlet and same outlet point, they are parallel pipes. And for parallel combination, according to continuity equation, Q is equal to Q1 plus Q2 plus Q3 and so on. And the total energy head loss is equal to HL1 is equal to HL2 is equal to constant. These are the expression for parallel combination. Right? और पैरेलल पाइप अगर होंगे, फॉर पैरेलल पाइप HL will remain constant. HL is equal to FLV square by 2GD. Remains constant. From here we can say V is directly proportional to under root of D by FL. V1 by V2. If we write V1 by V2, then it will be under root of D1 by D2 into F2 by F1 into L2 by L1. this is the ratio of velocity, and q is proportional to d square into v. So we can write q1 by q2 as d1 by d2 whole square into v1 by v2. That is the ratio of discharge. Q1 is the discharge in this is first pipe, q2 is the discharge in the second pipe. Total discharge is q. Q is equal to q1 plus q2. Q will be equal to q1 plus q2. Junction क्या होता है? What is the junction? This is the junction. This is called as junction when two or more pipes meet. तो junction के लिए net flow rate will be equal to 0. For a junction, net flow rate will be 0. If discharge entering is Q, discharge leaving is Q1 and Q2. So we can say for the junction, discharge entering should be equal to discharge leaving. That is the continuity equation. That is called as junction. Friction factor F will be taken constant until and unless it is mentioned in the question. Friction factor will be assumed to be constant. Unless it is mentioned. For compound pipe system, we will assume the friction factor to be constant. Right? These are two junctions. One junction is this, another junction is this. When the pipes are sharing same junctions, then they are known as parallel pipes. अगर length L and diameter D of parallel pipes are equal, are same. If the length of each parallel pipe and the diameter of each parallel pipe are same. कौन सा स्लाइड चाहिए आपको? ये वाला? You want this one? कोई भी अगर आपको डाउट होगा, you can connect with me separately, right? Through the Telegram channel. अगर लेंथ और डायमीटर सेम है पैरेलल पाइप्स का, लेंथ L1 L2 से इक्वल है, D1 D2 इक्वल है, तो क्या होगा? पैरेलल पाइप्स है, सो HL कांस्टेंट होता है पैरेलल पाइप्स के लिए. फ्रिक्शन फैक्टर इज ऑल्सो सेम. इफ फ्रिक्शन फैक्टर इज कांस्टेंट फॉर ऑल द पैरेलल पाइप्स, then what we will get? If the length is same, diameter is same, friction factor is also same. So we can say velocity will be constant. Or we can say V1 is equal to V2. If the diameter is same, then we can say Q1 is equal to Q2 is equal to Q by 2 each. If the length and diameter of all the parallel pipes are same, then the discharge will also be equal. If there are two parallel pipes, then Q by 2, Q by 2. If there are three parallel pipes having same length and same diameter and friction factor, then Q1 is equal to Q2 is equal to Q3 is equal to Q by 3. If there are four parallel pipes, then Q1 is equal to Q2 is equal to Q3 is equal to Q4 is equal to Q by 4. The discharge will be equally distributed in all the parallel pipes. Right? That is how you can develop the relations. Now there is a question on the screen.
So guys, enjoying? Okay. So fabulous energy यार you and sir both have. Sir मैं तो कह रहा हूँ कि yesterday me and Dheeraj sir have taken this much duration. Today you are only आपने अकेले ले लिया, so your effort is double than us.
It Students' love and affection.
Yes, and we have done only one day. Yesterday, me and Dheeraj said, today only you. But these students are even one step ahead. They have done it both days. Okay, guys. And आज क्या है सर 10 तारीख है. Guys, on 12th, that is Friday, I'll be coming with the complete soil mechanics. Okay, for civil engineers. Complete soil mechanics. Are you coming there, guys? On 12th, that is Friday, 10 a.m. Friday, 10 a.m., guys, the complete soil mechanics marathon. And you can see the complete schedule, guys, because tomorrow is Dheeraj sir's some subject production. कौन सा है कल? You can see the schedule उसमें है पूरा. Okay? चलो, guys, carry on, guys. Wonderful effort. Okay, sir, आप लीजिए.
आप निकल रहे हैं, आप जा रहे हैं?
मैं तो 1 बजे तक यही हूँ. सोम भी है ना दोस्तों, सोम भी है रात को 11:30 बजे सोम का प्रैक्टिस होगा. ओके गाइस, थैंक यू.
अच्छा, ड्रीम्स क्या कंफ्यूजन है? डिस्चार्ज इज इक्वल टू π/4 d² इंटू वेलोसिटी. ये नहीं होता एरिया इंटू वेलोसिटी. दैट इज वाई Q इज प्रोपोर्शनल टू d² इंटू वेलोसिटी. area into velocity. So there is a question. 2 water carrying pipes are connected in parallel. Try to solve this one. Try to solve this one. बस अब मेरे पास 20 स्लाइड हो रहे हैं. Only 20 slides are there. So keep yourself charged up for the next 30 minutes. 20 slides, 20 minutes. Or maximum 30 minutes, right? So we will end the session by 9:15. 2 water carrying pipes are connected in parallel. Parallel में अगर है तो HL, which is FL(V²/2GD) will remain constant. Whenever the pipes are connected in parallel, HL will be constant. The length, diameter and friction factor for first pipe. ये length है L1, ये diameter है D1, ये friction factor है F1. For first pipe, second pipe, length is L2, diameter is D2 and friction factor is F2. Then what is the ratio V2/V1? यहां से क्या हम लिख सकते हैं? From here, can we write V is directly proportional to √ of D/FL? So if we write V2/V1, then √ of D2/D1 into F1/F2, yes or no, into L1/L2. Just put the values. Put the values, you will get the answer. This was asked in GATE. कोई फर्क नहीं है कुंदन, whether we call it as frictional head loss or the head loss due to pressure drop, both are same. But the only difference is Hagen-Poiseuille equation is only applicable to laminar flow. Hagen-Poiseuille equation is only applied to the laminar flow, whereas Darcy-Weisbach equation is common equation which is valid for laminar and turbulent both. That is the only difference. Hagen-Poiseuille equation सिर्फ laminar flow में use होगा. Are you getting √5? Yes or no? Are you getting √5, 2.23? Isn't it? Please guys, do like and share. So much hard work, energy we have been putting into these sessions. So we want your love, affection, your enthusiasm and motivation. So the answer will be √5. This question was asked in GATE previous paper. Then we define an equivalent pipe. The compound pipe will be replaced by a single pipe. That single pipe is called as equivalent pipe only when it carries the same amount of discharge and carries same amount of head loss as that of compound pipe. So this will be equivalent pipe. This will be equivalent pipe when the discharge in equivalent pipe QE will be equal to discharge in compound pipe, and the loss in equivalent pipe HLE must be equal to loss in the compound pipe. If these two conditions are satisfied, then only the single pipe will be called as equivalent to the compound pipe. So the compound pipe can be a series combination. So we can say QE must be equal to Q. And what is Q? For series combination, that is equal to Q1 is equal to Q2 is equal to constant. That is one condition. The second condition is HL is equal to HL. And what is HL for a compound pipe? If it is series combination, that is equal to HL1 plus HL2 plus HL3 and so on. So this can be written by using Darcy-Weisbach equation. If we write Darcy-Weisbach equation here, these are the two conditions to be fulfilled for the equivalent pipe. The length of the equivalent pipe is LE, diameter of the equivalent pipe is DE, discharge is QE, loss is HLE. Right? So if you will put Darcy-Weisbach equation, then what we will get? Then we will get LE upon DE to the power 5 is equal to L1 upon D1 to the power 5 plus L2 upon D2 to the power 5 plus so on. This equation is known as Dupuytren's equation. If friction factor is taken constant for all the pipes, HL can be written as FLQ square upon 12.1 D to the power 5. Discharge remains constant. When the pipes are connected in series, discharge remains constant. So Q will be taken outside. Friction factor is assumed to be constant. 12.1 is constant value. So L upon D to the power 5. HL is proportional to L upon D to the power 5. So LE upon DE to the power 5 is equal to L1 upon D1 to the power 5 plus L2 upon D2 to the power 5 and so on. Now for parallel combination, so we can say QE is equal to Q, that is equal to Q1 plus Q2 plus Q3 and so on. And HLE is equal to HL, that is equal to HL1 is equal to HL2 is equal to, for parallel pipe, HL remains constant. If we write using the Darcy-Weisbach equation, FELEQE square upon 12.1 DE to the power 5 is equal to F1 L1 Q1 square upon 12.1 D to the power 5 D1 to the power 5 is equal to so on. This is the expression. And QE is equal to Q and Q is equal to Q1 plus Q2. If the parallel pipes are having same length and same diameter, if the friction factor is constant, if we assume friction factor to be constant, then this FE will get cancelled out with this F1. 12.1 will get cancelled out with this one. So what we will get? QE is equal to Q. So our expression will be LE into Q square upon DE to the power 5 is equal to L1 into Q1 square upon 12. D1 to the power 5. Yes or no? And if length L and diameter D of parallel pipes are same. If length and diameter of parallel pipe are same, then do you agree Q1 is equal to Q2 is equal to Q3? And because Q is equal to Q1 plus Q2 plus Q3, so if Q1 and Q2 are equal, so we can say Q is equal to N times of Q1. Yes or no? Or we can say Q1 is equal to Q by N. This is the special case. So for this case, this is the original equation. Now if we put this expression here, then we will get LE upon DE to the power 5 Q square is equal to L upon D to the power 5. Q1 is Q by N square. So it will be into N square. Yes or no? where n is the number of parallel pipes. Number of parallel pipes having same length L and diameter D. समझ में आया आपको? यहां पे Q स्क्वायर था, यहां पे Q बाई N स्क्वायर लिख दिया मैंने. ये Q स्क्वायर इस Q स्क्वायर से कैंसिल आउट हो गया. So then it will become this. So this will get cancelled out with this Q. So N square is in the denominator. Then N square will be in the denominator. This is how we can find out any unknown. If L1, if the question gives you LE is equal to L, if the length of the equivalent pipe is also same as L, then we will get diameter of the equivalent pipe is equal to D multiplied by N to the power 2 by 5. Yes or no? Yes, Om Prakash. I power will not create a problem. The problem will be when you are having color blindness. I power will not make a problem. You can prepare for engineering services. One more question, and then we will enter into the final lap, that is the external flow. After this question, we will enter into the external flow. Consider steady flow of an incompressible fluid through two long and straight pipes of diameter D1 and D2 arranged in series. If they are arranged in series, Q will be constant. If Q is constant, that is pi by 4 D square into velocity. So V is inversely proportional to D square, isn't it? The velocity is inversely proportional to D square. Friction factor for turbulent flow through pipe is given by this. Neglecting the minor losses, ratio of frictional pressure drop, whether we call it as frictional pressure drop or frictional head loss, one and the same thing. In pipe 1 to that in pipe 2, delta P1 by delta P2 is how much? So we can say HL is equal to delta PL by rho G, which is equal to FLQ square upon 12.1 D to the power 5. So HL is proportional to delta PL, will be proportional to F both the pipes are having equal length is constant, discharge is constant because the pipes are arranged in series. So can we write F upon D to the power 5? This is the expression. Now we need to develop a relation between F and diameter because the options are in terms of diameter. So we need to find out delta PL as a function of diameter. That is the objective. Now how to find out F? F is proportional to Reynolds number, that is rho VD by mu to the power minus n. Rho is constant, mu is constant. So F is proportional to V into D to the power minus n, and V is inversely proportional to D square. So F is proportional to V into diameter to the power minus n, and V is inversely proportional to D square. So we can say F will be proportional to 1 by D square into D to the power minus n. This DD getting cancelled out. So F is proportional to 1 upon D to the power minus n, or we can say F is proportional to D to the power n. Put in equation number 1. This is equation number 1. So if you will put in equation number 1, then what will you get? Delta PL, which is proportional to F upon D to the power 5. So F is replaced here. So delta PL is proportional to D to the power n minus 5. So delta P1 by delta P2 can be written as D1 by D2 to the power n minus 5. And if we want to write D2 by D1, then we will write 5 minus n. Yes or no? 5 minus n. बताइए, do you understand this? Why this is coming? Because Q is constant. So delta P1 by delta P2 is d2 by d1 to the power 5 minus n. Option A. It will be option A. Clear? Is this clear? That is how you should be able to develop the correct relation between the unknowns, between the variable parameters. And now the last part, that is external flow, or which is analyzed by using the boundary layer theory. Turbulent flow, the basic formula I have already discussed. Turbulent flow is not important. Only the formula you must memorize. And we will take a session on formula only. We will, after this marathon session, we will start another series for formula revision. There I will mention all the formula which are important or which are there in fluid mechanics. बाकी जो turbulent flow के जो formula हैं, I have already discussed. The continuity equation is applicable to turbulent flow. The Darcy-Weisbach equation is applicable to the turbulent flow. The momentum equation is also applicable to the turbulent flow. All right. External flow is analyzed by using the boundary layer theory. Whenever the fluid is flowing over a surface, the velocity profile gets developed. This is called as boundary layer region. This region is called as boundary layer region. When the fluid is flowing over a surface, whenever the fluid is flowing on the surface, so what is the boundary layer region? The boundary layer region is a thin region very near to the solid surface in which the fluid velocity gradually increases from 0 at the surface to free stream velocity, that is capital U or U infinity. Machinery, definitely we are planning to have one session for fluid machinery and model analysis. So U becomes a function of Y. The region in which U becomes a function of Y, or we can say du by dy is non-zero. That region is called as boundary layer region, where the velocity gradient exists. In the boundary layer region, the velocity gradient exists. So Bernoulli equation is not applicable because the flow is viscous. And outside the boundary layer region, the flow is non-viscous. The velocity gradually increases. So velocity profile will be drawn like this. This is how the velocity profile will look like. Here is the free stream velocity, and near the surface the velocity is u. Velocity increases in y direction, the velocity changes from 0 to u infinity. This is called as free stream velocity. This is the velocity profile, u as a function of y. That is called as boundary layer region. So for the flow over a flat plate, there is a growth of boundary layer. This is how the boundary layer will grow. This is inlet, x is equal to 0. This is the direction of the flow. So initial part of the boundary layer is laminar. This is laminar. Then there is transition. This is the laminar boundary layer when the fluid particles are flowing in layers. And then there will be turbulent boundary layer. So the boundary layer will keep on growing from the leading edge. X is equal to 0 is called as leading edge. And this is called as trailing edge. X is equal to L. Trailing edge, leading edge and trailing edge. So here the Reynolds number is defined as local Reynolds number. We call it as local Reynolds number because it is a function of x. So it is rho into u infinity into x by mu, or we can write it as u infinity x by kinematic viscosity. Because it is a function of x, that is why it is called as local Reynolds number. And if the local Reynolds number is less than 5 into 10 to the power 5, then it is laminar boundary layer. If the Reynolds number is greater than 5 into 10 to the power 5, then the boundary layer will be turbulent. These are the values which need to be memorized for external flow. These are the values for external flow over a plate. And the critical value of Reynolds number is 5 into 10 to the power 5. That is rho into U infinity into critical value of X, where the boundary layer changes from laminar to turbulent. We can easily find out XCR. That is called as critical value. Here, this is XCR, critical value of X, where the boundary layer changes from laminar to turbulent through transition. We are not going to study transition. We only talk about the laminar and turbulent. This is very thin region, very small region. So that is why we are not going to consider this. In transitional region, some of the fluid particles are having laminar pattern. Some of the fluid particles start mixing from one layer into another. Then the various boundary layer thicknesses. One is called as velocity boundary layer thickness or hydrodynamic boundary layer thickness. This is called as delta X. This is called as delta X. What is delta X? At any section X, at any section, the distance from the solid surface. It is the distance from the solid surface. This is the solid boundary. The distance from the solid surface in y direction, at which the local velocity u becomes 99% of the free stream velocity. So the ratio of u by u infinity becomes 0.99. Then y will become delta X. Why we are writing delta X? Because it is a function of X. That is called as velocity boundary layer thickness. And as X increases, then delta X will also increase. That is why we call it as growth of boundary layer.
आपका कॉफी.
Thank you, sir.
और सर आपका पानी.
Thank you.
मैं क्लास लेता हूँ, मेरा 9 बजे क्लास है.
अच्छा.
ठीक है दोस्तों, मिलेंगे फ्राइडे. स्वाइल, थैंक यू.
Right? Then we define the displacement thickness delta star. Displacement thickness is defined for the mass conservation. The delta star is given by integration 0 to delta 1 minus u by u infinity into dy. That is called as displacement thickness, delta star. So actual mass flow rate can be calculated by integration of rho into u into dy, or without integration also we can calculate rho into, if we find out this distance, this is the mass flow rate. If we assume the velocity to be u infinity, rho into u infinity, then it will be delta minus delta star. That is the mass flow rate. For mass conservation, we define the displacement thickness. This is the formula for displacement thickness. Momentum thickness theta, for momentum conservation, integration of 0 to delta u by u infinity 1 minus u by u infinity into dy. This is momentum thickness. And energy thickness is given by integration of 0 to delta u by u infinity 1 minus u square by u infinity square into dy. If you solve this, you will get the energy thickness. For energy conservation, we define energy thickness. For mass conservation, we define the displacement thickness. And for momentum conservation, we define the momentum thickness. अच्छा प्रभु, डिस्प्लेसमेंट थिकनेस के बारे में बता देता हूं मैं आपको. डिस्प्लेसमेंट थिकनेस के बारे में बता देता हूं. In reality, there is a velocity profile developed. So if we want to calculate the mass flow rate from here, then the mass flow rate will be calculated by this expression, isn't it? Because it is a function of y. Now what we do is, we displace the boundary in y direction. We displace the boundary in y direction such that the actual mass flow rate from this section becomes same as the mass flow rate considering the free stream velocity. So it means, try to understand, कि हमने displacement thickness इस तरह define करते हैं, this area, this is the area, this area becomes equal to this area. When we assume the velocity to be u infinity, then this area and this area becomes equal. That is how the surface is displaced. So the amount by which surface is displaced is known as displacement thickness. Yeah, this is the displacement thickness, right? So if we calculate the mass flow rate from this section, then this will be the expression to be used, rho into u into dy. And if we calculate the same mass flow rate, if we want to find out the same amount of mass flow rate, then we can assume the velocity to be u infinity. And we consider this area. What is this area? Isn't it delta minus delta star? Isn't this area? Total, this distance is delta and this is delta star. So this will be delta minus delta star. So rho into delta minus delta star into u infinity will give the same amount of mass flow rate. That is how it is displaced. The surface is displaced in y direction to compensate the reduction in mass flow rate due to boundary layer growth. I hope this is clear. Is this clear? अभी बताऊंगा ड्रीम्स किस तरह के क्वेश्चंस फ्रेम होते हैं. The question can be directly formula based. If the velocity profile is given by this expression, find out delta star. अगर delta star find out करेंगे displacement thickness, then 0 to delta 1 minus u by u infinity into dy. Do the calculation. U by u infinity is y by delta. Put u by u infinity is y by delta, you will get delta star. Displacement thickness will come out to be कितना आएगा? What will be the displacement thickness? Will you get delta by 2? If you calculate theta, integration of 0 to delta, u by u infinity, 1 minus u by u infinity into dy. U by u infinity is y by delta. If you do the calculation, you will get delta by 6. Right? Energy thickness, integration of 0 to delta, u by u infinity, 1 minus u square by u infinity square into dy. If you calculate, then you will get delta by 4. And what is h? H is called as shape factor. It tells us about the shape of the velocity profile. So that is equal to delta star by theta. If you calculate delta star by theta, you will get 3. This is how question can be asked. Then momentum equation for two-dimensional steady and incompressible flow. This is the momentum integral equation for the boundary layer, which is called as von Karman. Pressure is not a function of x. Pressure is constant in the flow direction. dP by dx is 0, no pressure gradient. dP by dx is equal to 0. It will be when plate is kept parallel to the flow. When the plate is kept parallel to the flow, the expression for von Karman momentum integral equation is this. Tau naught upon rho u infinity square is equal to d theta by dx. Theta is, this is called as von Karman momentum integral equation. Tau naught is the surface shear stress, u infinity is the free stream velocity, theta is the momentum thickness, x is the distance from the leading edge in the flow direction. for laminar boundary layer, velocity profile is given by this expression. This is known as Blasius equation. When the Reynolds number is less than 5 into 10 to the power 5. For turbulent boundary layer, velocity profile is given by 7th power law, 1/7 power law, when the Reynolds number is greater than 5 into 10 to the power 5. These are the general velocity profile for laminar and turbulent boundary layer. U by U infinity is equal to y by delta to the power 1/7, and here U by U infinity is equal to capital U is free stream velocity. Small u is the local velocity at any y. So this is how we can have the general velocity profile. Now the final conclusion. कुछ फॉर्मूले में लिख रहा हूं, and the question will be asked from this formula only. For laminar boundary layer and for turbulent boundary layer over a flat plate. The boundary layer will be laminar when the Reynolds number is less than 5 into 10 to the power 5. So first formula will be delta x by x is equal to 4.64 upon under root of Rex. From here we can say delta x is directly proportional to root x, or delta x is proportional to x to the power 1/2. As x increases, delta x also increases the boundary layer thickness. And for turbulent boundary layer, when the Reynolds number is greater than 5 into 10 to the power 5, here delta x by x is given as 0.376 upon Rex to the power 1/5. So from here delta x is proportional to x to the power 1 minus 1/5, that is 4/5. The second formula, local drag coefficient, CFX, is equal to tau naught upon rho u infinity square by 2. That is given by 0.664 upon under root of Rex. So we can say CFX is directly proportional to tau naught is proportional to x to the power minus 1/2. CFX, local drag coefficient, is proportional to tau naught, surface shear stress, which is proportional to x to the power minus 1/2. So as x increases, CFX will decrease, or we can say tau naught will decrease. The surface shear stress will decrease. ये x भी तो है. So delta x is equal to 4.64 x upon under root of Rex. इसको ऐसा भी तो लिख सकते हैं, डेल्टा एक्स इज इक्वल टू 4.64 x अपॉन अंडर रूट ऑफ Rex, isn't it? सिमिलरली यहां डेल्टा एक्स को लिखा जा सकता है 0.376 x अपॉन Rex टू द पावर 1/5, because the Reynolds number is proportional to x. Reynolds number is directly proportional to x. That is why x upon root x, that is x to the power 1/2. याद ये करना है, याद ये रखना है, याद होगा, जरूर याद होगा. एंड हियर CFX is given by 0.059 upon Rex to the power 1/5. So here CFX, which is directly proportional to tau naught, which is proportional to x to the power minus 1/5. As x increases, CFX or tau naught will decrease. And the third formula is CD, average drag coefficient. That is the drag force upon rho u infinity square by 2 into area. That will be twice of CFX at L. And here CD will be equal to 5 by 4 into CF at X is equal to L. These are the formula. इनमें बताइए कोई डाउट? जो मैंने ब्रैकेट में मेंशन किया है उनको याद रखना है. क्वेश्चन कैसे पूछे जाते हैं इस पे थोड़ा डिस्कशन कर लेते हैं एंड देन वी विल स्टॉप. दिस इज वन ऑफ द क्वेश्चन. An incompressible fluid flows over a flat plate with zero pressure gradient. It means plate is kept parallel to the flow. The boundary layer thickness is 1 mm at a location where Reynolds number is 1000. If the velocity of the fluid alone is increased by a factor of 4, so it means u infinity 2 becomes 4 times of u infinity 1. Then what will be the boundary layer thickness at the same location? Same location means x is equal to constant. When the Reynolds number is 1000, what does that mean? Isn't it laminar? Because it is less than 5 into 10 to the power 5. Laminar boundary layer. For laminar boundary layer, delta x is given by 4.64 x upon under root of Rex. If x is constant, so we can say delta is inversely proportional to under root of Reynolds number, isn't it? So delta 2 by delta 1 is equal to, or Reynolds number is equal to rho into u infinity x by mu. So can we say delta is inversely proportional to under root of u infinity? So delta 2 by delta 1 is equal to under root of u infinity 1 by u infinity 2. What is u infinity 1 by u infinity 2? 1 by 4. So delta 2 is equal to 1 by 2 into delta 1. So if the boundary layer thickness is 1 mm, then at what will be the boundary layer thickness? Isn't it 0.5 millimeter? C, isn't it C? C will be the answer. Well done, Somik, Abhi, Hari Sindhu. Good, good, good. That is how the question can be framed. One more question. ये f less than 1 by 2 है. ये f is equal to 1 by 2 है. This is beautiful question. For a laminar boundary layer over a flat plate of length L, if f is the ratio of drag force on first half of the plate to the drag force on rear half, so f is the ratio of fd1 by fd2, then what is this ratio? अभिषेक ये रहेगी यूट्यूब पे. अगर आपको ये पता हो, दिस इज द प्लेट, इफ यू डिवाइड दिस प्लेट इन टू हाफ 1 and 2, as x increases, tau naught is directly proportional to x to the power 1 by 2 for laminar. For laminar boundary layer, tau naught is proportional to x to the power minus 1 by 2. So as x increases, tau naught decreases, isn't it? Area A1 is equal to area A2. Area are same. So drag force is equal to tau naught into area. Because area is same, tau naught is variable. So if x increases, tau naught decreases. Do you agree tau naught 1 is greater than tau naught 2? Yes or no? If tau naught 1 is greater than tau naught 2, then do you agree FD1 is greater than FD2? And if FD1 is greater than FD2, then this ratio, isn't it greater than 1? Isn't it greater than 1? D will be the answer. The ratio of drag force. On first half, the shear stress will be more. On the second half, the shear stress will be less. Surface shear stress. Because tau naught is proportional to x to the power minus 1 by 2 for laminar boundary layer. It decreases in the direction of the flow. So more will be the drag force on first half, less will be the drag force on the second half. The ratio will be greater than 1. Any formula slide. Tau naught is proportional to x to the power minus 1 by 2. As x increases, tau naught decreases. Clear? One more question. इस क्वेश्चन को देखिए. A steady laminar boundary layer is formed over a flat plate. This is how the boundary layer will be formed. Growth of boundary layer, and it is laminar. The velocity profile at the inlet AB. This is AB, inlet AB. The velocity is constant, uniform. While that at the downstream location CD, this is CD. The velocity profile is given by this expression. Then what is the ratio of mass flow rate from BD to mass flow rate from AB? This is our control volume. If we take this as our control volume, this is our control volume. What is the mass flow rate from AB? Because the velocity is constant, so mass flow rate from AB is equal to rho into area. This is delta. Area will be equal to delta into 1 into U. Capital U or U infinity. We can call it as U infinity. That is mass flow rate from AB. What is the mass flow rate from CD? We need to go for integration. At any y, we will take small element dy. So mass flow rate from CD is equal to integration of rho into U into dy. And the integration will be from 0 to delta. Can you do the integration? Can you do the integration? क्या आएगा? M dot CD. Do the integration, put the limit 0 to delta. That is rho into U infinity. Then integration of 2y by delta. 2 by delta. Integration of y dy, y square by 2. So it will be delta square by 2 minus 1 by delta square into y square into dy, delta cube by 3. This will be the expression. This delta will get cancelled out with this. 2 will get cancelled out. Delta square, delta cube. So it will be rho into U infinity into delta minus delta by 3. How much is that? Rho into U infinity into 2 by 3 delta. Yes or no? That is the mass flow rate from CD. Right? Now, if we apply the mass conservation equation in the control volume, this is our control volume. This is our control volume. If we apply the mass conservation in control volume, there is no flow from AC section because it is in contact with the solid surface. So according to mass conservation, we can say mass flow rate entering through AB is equal to mass flow rate leaving from CD plus mass flow rate leaving from BD, isn't it? There will be some fluid leaving from BD. So mass flow rate from BD is equal to mass flow rate from AB minus mass flow rate from CD. We have already calculated mass flow rate from AB and CD. We have already calculated mass flow rate from AB. Rho delta U infinity is common. And we have already calculated mass flow rate from CD. So it is 1 minus 2 by 3. Yes or no? So rho into U infinity into delta 1 minus 2 by 3. That will be equal to rho U infinity into delta into 2 by 3. Sorry, 1 by 3. This will be 1 by 3. That is mass flow rate from BD. So if we want to find out the ratio, what will be the ratio? The ratio mass flow rate from BD to the mass flow rate from AB. Isn't it 1 by 3? This will be the answer. This will be the answer. This is mass conservation in control volume. Mass flow rate from AC is equal to 0. So that is how you can find out the ratio. The answer will be 1 by 3. It will be 1 by 3. That is how the questions are asked. This is how the questions can be framed from boundary layer theory. I hope this is clear. Now we are at the end of our session for the day. कितने घंटे हो गए? We started at 10 or 10:15 and we are going to close by 9:30. Right? एक और slide में दिखा देता हूं. The boundary layer separation. When there is a convergent boundary, if there is a converging boundary, then dP by dx is negative. This is called as favorable pressure gradient. That will favor the flow. So the boundary layer growth will decrease. The growth of boundary layer decreases. When it is a convergent boundary, the boundary layer growth will decrease because U infinity will increase. In convergent boundary, area will decrease. So U infinity will increase. The fluid velocity will increase, so growth of boundary layer will decrease. But if it is a divergent boundary, so in case of divergent boundary, or we can say pressure will decrease from the energy conservation. So if the pressure will decrease, so dP by dx is negative. If there is a divergent boundary, area will increase in the flow direction, the velocity will decrease, and the pressure will increase. So if the pressure will increase, dP by dx becomes positive. This is called as unfavorable pressure gradient. This will be unfavorable pressure gradient. So that will retard the flow. So the flow gets separated. Initially, the velocity profile will be like this, but due to unfavorable pressure gradient, the pressure will oppose the flow. So the velocity profile will be something like this. This is the point of flow separation when du by dy at y is equal to 0 tends to 0. And when the fluid moves further, then the velocity profile will be like this. This is the back flow, flow reversal, or we can call it as flow separation. This is where the separation of the flow takes place. Some particles are moving in forward direction. Some particle will start moving in backward direction. That is known as separation of the flow. So when the separation of the flow will take place due to reduction in the velocity or due to increase in the pressure in the flow direction, the chances of flow separation will be there in the divergent boundary. This is the point of separation. This is the condition where the flow is on the verge of separation. This is called as boundary layer separation or flow separation. Flow separation. So there is a chances of flow separation in case of divergent boundary because the velocity will decrease in the flow direction. and the pressure will increase in the flow direction. That will make the flow to be reversed. Flow reversal will take place. And the boundary layer will grow suddenly. So that is all about the fluid mechanics. Thank you very much, guys. These are some of the topics which are most important. These are some of the topics which are important, and the topics which are least important for your examination point of view. So please do revise each and every topic, and do not forget to practice the numericals. I will plan a practice session very soon. I will update on my Telegram channel. All right. So if you are not part of my Telegram channel yet, please do join me in the Telegram, Mechanical by Chandrasekhar, and we will meet again very soon. Till then, enjoy, take care, have a good night, and Shubh Ratri, Sabba Khair, and Jai Hind. Thank you, guys. Thank you for joining in. It would not have been possible because of your effort. It would not have been possible without your efforts, without your involvement. So I got the energy from your involvement and your dedication. Thank you guys very much. So get yourself ready for tomorrow's marathon on production. We will bring very soon the marathon classes, marathon session on hydraulic machine and the remaining part of the dimensional and model analysis. All right. Thank you guys. Thank you very much. See you very soon, and have a good night and a great career ahead. Let me take your leave now. Jai Hind.